Good morning, dear students. Yesterday we have started electromagnetic induction. Today continues the same lesson, electromagnetic induction. Yesterday we learnt about Faraday laws and some numericals on the Faraday's laws. And today let us go with the motional EMF, self-induction and mutual induction. So here motional EMF. Motional EMF, let us discuss. What is the motional EMF? When a conductor of particular length is moving in a uniform magnetic field or any magnetic field, then at the ends of the conductor it induces an EMF. That EMF is called motional EMF. Means what? The conductor should be in motion. When the conductor is in motion, it cuts the magnetic field lines. When it cuts the magnetic field lines, magnetic flux changes. When magnetic flux changes, according to Faraday law, so we know that. So that induces one EMF. That EMF is called motional EMF. Because it is in motion, that's why it is called as a motional EMF. For example, let me take, this is the uniform magnetic field. This is one uniform magnetic field I have taken. For example, let me take, this is one of the conductors and the length of the conductor, for example, I am giving that capital L, and the magnitude of the magnetic field is B, and the direction of magnetic field is I have taken into the plane of the paper, and B is the magnetic field. And for example, now the velocity of the conductor I am taking that is a V, and so the velocity vector makes an angle theta with the length of the conductor is theta. Means what? So V is means conductor moving this direction, length is like this, and B is the magnetic field. So here theta is what? Angle between velocity and length of the conductor. So as I told you, length is a scalar, but so in this cases we can take length as a conductor vector, because so it produces induced EMF, because so it is acting as a current element. That's why every current element can be taken as a vector. Therefore length here you can taken as what? So vector quantity only. Now so the motional EMF, for example, now here I am taking that the top end of the conductor I will take that PU, and the bottom end I will take as the Q. Therefore PQ is equal to length, and this length is the shortest distance between the ends of the conductor. So what is the meaning of shortest distance? Here length is also vector quantity, therefore it is the shortest distance between the P and Q. Therefore let us discuss about the length later. Now so in this case the motional EMF is given by E is equal to so B L V into what? Into sin theta. So this is the magnitude of magnetic motional EMF. E is equal to BLV sin theta. Right now if you want to express in terms of the vector, so there are the three forms are there, Nana. So E is equal to, you can say now B bar dot so L bar cross V bar. B bar, this is the answer for that. So B bar dot L bar cross V bar, right? So B bar dot L bar cross V bar is the vector form, or you can convert into another form also. That is equal to, so what I am taking that next, so B bar dot L bar cross V bar, and if you want to take that is a L bar, so dot, next you take the order. So B L V should be in the order. Now we can take that, so V bar cross B bar you can take that. Therefore now, and so next what, so B L V, next what? V bar. After V bar we have to get what now? There is a, so B bar, so cross, so L bar we have to take. Therefore these are the vectors form of motional EMF, and this is the magnitude. So if now here what is the theta in the diagram? Theta is angle between only velocity vector and length I have taken. But according to this you can take theta is not only angle between length and velocity, you can take between velocity vector and magnetic field, or you can take so magnetic field and this one also. Therefore, now what? So in this, so you can say that is the motional EMF formula, but so these are, they are not asking regularly, so better to follow. So this is the formula. Many of the questions are E is equal to BLV. Here the most important thing is that, so L is equal to what? L is equal to shortest distance. Shortest distance, so between ends of the conductor. Between ends of the conductor, that is, we should not forget, because in this case the length of the wire is a straight line. Therefore, now what we can say, direct we can take the length. But in some cases the length of the wire is not straight, it may be in the curved path. So if it is in the curved path, now you can say what, the length can be taken as a shortest distance by using the, so any geometrical principle we can find out the length for that. Therefore, this is a motional EMF. And in this case what I am taking that, for example, if theta is equal to 0, I am taking that. So what is the meaning of theta is equal to 0? Means if theta is equal to 0 between any two terms, means if length and velocity both are parallel to each other, induced EMF, I mean motional EMF is equal to 0. If magnetic field and length both are parallel to each other, in that case also, so EMF is equal to 0. And if velocity vector and field both are parallel, in that case also what? So magnetic field is equal to 0. So here theta is equal to 0 means not only between velocity and length, between any two components. Means what? If theta is equal to 0, that is, if any two parameters, if any two are parallel to each other, then what? So then immediately the induced EMF E is equal to 0. There is no doubt at all. So here this is equal to 0. For example, let us see. Now what I am taking that? For example, here this is the uniform magnetic field. So magnetic field, so acting into the plane of the board. Let me take, this is the, so what I am taking that now, therefore this is the one rod, the length of the rod is L, therefore now, so what, the rod is moving like this, therefore here velocity and length both are parallel to each other. So in this case what? In this case induced EMF E is equal to 0. Next, one more case I am taking that, for example, so now the magnetic field direction I will change like this, therefore this is the direction of magnetic field. Now what I am taking that, therefore this is the length of the rod L and this is the direction of magnetic field. I will take that B bar, and here, so velocity vector is velocity vector is what? V bar. Therefore, once again the velocity of the conductor field both are in the same direction. Therefore, in this case also induced EMF is equal to 0. Therefore, out of the three parameters, magnetic field, length, velocity, if any two of them are parallel to each other, in that case you can take so E is equal to 0. And again you can take for example, here one more case is what, last one. For example, if you take, so this is the magnetic field, and so this is the length of the conductor that I am taking that L. So the direction of magnetic field is B bar, I am taking that. Now here what? This is the velocity vector. Here velocity is perpendicular to length, velocity is perpendicular to field, but now what? Length and magnetic field both are in the same direction, so parallel to each other. In that case also you can say what? So E is equal to 0. Therefore, blindly remember, whenever two components out of the magnetic field, length and velocity, so if any two of them are parallel to each other, the induced EMF must be equal to 0. Therefore, now the third one is what? If three mutually perpendicular to each other are, right? No? So if three are mutually perpendicular, if three components, magnetic field, length, velocity, if three are mutually perpendicular, if three are mutually perpendicular to each other, perpendicular, then what? Theta is equal to 90 in that case, so sin 90 is equal to 1. So now you can say E is equal to what? So motional EMF E is equal to BLV is the formula. So many questions are there from this point only. E is equal to BLVM, right? No? So this is the small introduction of the motional EMF concept. Now, for example, let us solve one problem based on this. For example, what I am taking that, here this is the uniform magnetic field. And so here I am taking, this is the conductor, and so this is the 2 meters length, this is the 2 meters length, and so let me take, this is the P, I am taking that, and let me this end, let me take, that is a Q. Now what? So here this is moving with a velocity, this is moving like this, the system is moving with a velocity, for example V is equal to, so that is the 4 meter per second velocity it is moving, and the magnitude of the magnetic field B is equal to, for example I am taking that, so 20, that is 2 into 10 power minus 2 Tesla. Magnetic field is equal to how much I have given? So B is equal to 2 into 10 power minus 2 Tesla, and velocity is equal to 4 meter per second. Now the effect, the length I am taking what am I? Here 2 meter, here 2 meter, and this angle I am giving the 30 degrees, and this angle also, so I am giving what? 30 degrees. Now they will ask what is the, so motional EMF. Here the problem is what? So here magnetic field is given, okay, no problem, velocity also given, no problem. Therefore magnitude of the magnetic field B is equal to, so what, that is 2 into 10 power minus 2 Tesla, and velocity V is equal to 4 meter per second, that is we have given, but length, effective length we don't know, that we have to find out actually. Therefore now what is the effective length? As I told you, it is the shortest distance between the ends of the conductor. So if it is the ends of the conductor, what we will take now? So for example, if you take this point is the O, now we can think that, so P2O plus O2Q means what? 2 plus 2 is equal to 4 meter is the length of the conductor, that is wrong. So that is the total geometrical length of the conductor, but geometrical length of the conductor we should not take as the length of the conductor in this case. So here in this case E is equal to B LV sin theta. L is the most careful point to have to observe, because that is the shortest distance between the P and Q. If you go from P to O to P, this is O to Q, that is not taken as the shortest distance, that is the total geometrical length, means what? We have to find out this one. We have to find out actually this length, we have to take that. For example, if I will take, this is the Y and this also almost Y only na. So because it is a 2, it is a 2, this is the 30 means this one both are the Y. For example, if you take this point is the C, now from the triangle, so in the, we want the effective length so effective length we have to find out first of all. Therefore from the triangle, which triangle? Now from the triangle, so POC, from the triangle POC, so what we can take here? So we have the hypotenuse and we have the angle 30, and this is what opposite side. Therefore sin 30 is equal to, you can say sin 30 is equal to, so what that is equal to opposite side by, so hypotenuse 2. Therefore Y is equal to, you can say what that is the, so 2 sin 30, and that is nothing but what? 2 into sin 30 1 by 2. Therefore 2 cancel. Y is equal to how much now? 1 meter. But from the figure you can say the total length how much now? Effective length is equal to shortest distance between the P and Q means what? So here this is the Y and this is the, so what is that? That is the also Y. Therefore L is equal to Y plus Y is equal to 2Y, and that is equal to 2 into 1. Therefore finally we got effective length is equal to 2 meters we got it. Therefore length we got it. Okay now when the length we got it, now we can replace. Therefore now tell me here what? So this is the conductor, so P and Q are acting like this, and this is the velocity vector, and this is magnetic field. All three are mutually perpendicular to each other, right now. So velocity vector, if you take along the x-axis, if you take this is the, so along the y-axis, and what this is the into the plane of the paper or out of the plane of the paper can be taken as what? Z-axis. Therefore all three are mutually perpendicular to each other. So in that case the motional EMF formula E is equal to, you can say now what, that is equal to BLV. E is equal to BLV you can take. Therefore if you substitute the values, B is equal to 2 into 10 power minus 2 into L value we got it, that is equal to, so 2 into 1 2, and velocity V is equal to 4. For now what, that is 16 into 10 power minus 2. So volt, now you can say after that E is equal to 0.16 volts. Therefore now what, 4 is 16, so that is so yes, therefore E is equal to 0.16 volts, right? So now if it is acting as the EMF, if it is acting as the source of the EMF, Every source of the EMF having the two terminals, one is positive terminals and one is negative terminal, nothing but every source of the EMF acting as a battery. Therefore, if it is acting as a battery, now then tell me, so what is the positive terminal? But point P acts as the positive terminal, point Q acting as the positive terminal. Therefore, now then let us decide. For example, let me take, now this is one uniform magnetic field. Now, identification of terminals. How to identify? If a moving conductor inside the uniform magnetic field produces your EMF, then every source of EMF acting as a battery. So, every battery consisting of two terminals, one is positive terminals and one more is negative terminals. In that case, for example, if you take this is the uniform magnetic field. Now, let me take, so this is one conductor, this is one conductor. Now, the length of the conductor, for example, I am taking that L, and you know that, so this is the end P and this is the end Q, and this is the direction of velocity. Direction of velocity magnetic field is into. Now, open according to right hand palm rule. By using the right hand palm rule, what rule I am taking that? Now, according to right hand palm rule, so according to right hand palm rule, so we can decide it. First of all, so open your right hand and open the right hand like this. Now, so keep the palm in the direction of velocity, this white part. So for this right hand palm is there, no, this point keep in the direction of velocity. When you keep the palm in the direction of velocity, so curl the fingers in the direction of magnetic field. So when you curl like this, when you turn the magnetic field in the direction of magnetic field, then open the thumb. So in which direction the thumb opens out, that point or that end acting as the positive terminal. Right now, therefore now what? According to right hand palm rule, so what? This is the rule. So according to right hand palm rule or according to right hand rule, therefore now what? This palm is indicating direction of velocity. And so if you curl the finger from that point, the thumb opened out gives what? Positive terminal. Therefore now here you can take what? So this can be taken as now I am converting like this. Therefore now what? This is the terminal P and this is the terminal what? Q I am taking. Therefore this is positive, this is negative, because once again I am saying that, so this is the, if you are keeping right hand in the direction of motion or in the direction of velocity, then at that point, so curl the fingers, the turning the fingers, so into the direction of magnetic field, then what? If you open the thumb upside, therefore now the point towards which the thumb is opened out, that end of the conductor gives the positive terminal. Therefore now this is positive, this is Q and this is now. For example, if this conductor having some resistance, because it is a conductor, right now, every conductor having some resistance. Now, so its EMF, how much we have taken? EMF E is equal to BLV, so sine theta. Of course, you can take, if all three are mutually perpendicular, so all three are mutually perpendicular, you can eliminate sine theta. Therefore, E is equal to BLV, and it has some internal resistance, because in the current electricity, we learnt that, so every battery having two important parameters, one is electromotive force, nothing but EMF, one is the internal resistance, so which is developed due to the electrolyte of the, resistance of the electrolyte. Therefore now what? That is the R is what? Resistance of the conductor, which here we can take as the internal resistance of the battery. Therefore, so this is the, so identification of positive and positive and negative terminals of the battery. Next, motional EMF of a closed loop. For example, once again let me decide. So this is the uniform magnetic field. I am taking only one symbol for that. So which is indicating, so into the plane of the paper. I am not taking the total value. Therefore now just 2 points only I am taking it. In this region, total uniform magnetic field is there. For example, I am taking that. So this is one track, one conducting track. On this conducting track, I am taking that one rod. One rod I am taking that. and so this rod is moving, that rod that is moving with velocity v, and the length of the rod for example L, and let me take this is the P and this is the Q, and in this who is there? Magnetic field is present everywhere. In this total region magnetic field is present. Now, so if the rod is moving away, if the rod is moving like that, therefore now what? As it is a closed loop, so what I told you, this is acting as the higher potential. Therefore now what? This is the positive and this is acting as the negative potential. Therefore this system acting as a battery. If it is acting as a battery, so as we know that current in the discharging case always coming from the positive terminal, that current how much I am taking that. And so if R is the resistance of the conductor and capital R is the resistance of the metallic system, means what? This conductor is moving in this direction, right now, and therefore now what? Its internal resistance R I am taking that. Means what? So this metallic system acting as a external resistance, if it has some resistance, that resistance how much I am taking R, then what is the current in the circuit, they will ask, right now. So what? So this is the one rod, the rod length I have given taken L, and it is moving with a velocity v, and the magnetic field in this region acting into the plane of the paper with a uniform magnetic field value B. Therefore now what? So the ends of the rod are connected to a conducting wire. This system is moving, so inside the magnetic field, this whole system is moving like this. If the system is moving like this, therefore now what we can say now, here some current will be produced. As I told you, so according to right hand palm rule, this part becomes, this end becomes the positive terminal, this end becomes the negative terminal. Therefore now we can imagine, therefore now the circuit diagram, simply you can imagine like this. Therefore now what? So this is the cell, so this is the point P acting as the positive terminal. Therefore now this is what? E comma R. Now what? This is the external resistance. Therefore we got one nice circuit, and now that circuit is given by, the current in the circuit is given by I, that I value only they will ask. Therefore if what is the current in the circuit? Now, so the current in the circuit is given by, the current in the circuit is given by, so what that is equal to? I is equal to, so total effective EMF by, so what we can say now, that is equal to R plus R formula, that is equal to BLV, because here all three are mutually perpendicular. I am not taking BLV sin theta, just I am using that BLV because all three are mutually perpendicular. So BLV by R plus R. Therefore now, so this is the current formula, I is equal to BLV by R plus R. That's it. Therefore now, so this is the what? That is the, so a current in the circuit I is equal to BLV by R plus R. Sometimes if the conductor is having the neglected amount of the internal resistance, that can be acting as a, so small r is equal to 0, means what? It is acting as ideal cell or ideal battery. Therefore, for the ideal cell or for the ideal battery, so small r is equal to compulsory is equal to 0. But in that cases, because every conductor having some resistance, there is no chance to neglect internal resistance. But in some problems, if they will give, it is the ideal conductor, take small r is equal to 0. Every ideal conductor having no internal resistance, therefore small r is equal to 0. Now, let us solve one problem based on this. Now, see, as shown in the figure, now what I am taking that, so the magnetic field B is equal to, for example, so 4 Tesla I am taking that, velocity of the conductor V is equal to 2 meter per second, and length of the conductor, for example, it is equal to 4 meter I am taking that. Next, so if internal resistance R is equal to 2 ohm and external resistance R is equal to, it is also, for example, now I am taking that 4 ohm, right? Now they will ask that, so what is the power produced in the external resistance R? What is the power produced in the external resistance R? For example, better to take this one. So R is equal to 1 ohm, capital R is equal to 3 ohm. I am taking that to simplify the problem easily. Therefore, now what? So what is the power? So produced in the external resistance. Power is equal to how much? Right? So power produced inside the, So, external resistance how much, or heat generated per second is equal to how much. What the rate of heat generation inside the external resistance how much. So, how to find out here? B given, L given, V given and R given, R given. So, first of all, I am not asking what is the motional EMF. I am not asking what is the current produced in the conductor. What I am asking just, so what is the, so external, what is the power generated, so inside the external resistance. That power generated formula what am? So power generated formula P is equal to, so what, that is equal to, so I square into R that is equal to V square by R that is equal to also V into I. So what is the V here? V is not terminal voltage across the cell, that is the potential difference across the resistor. So, if there is a single resistor, single cell, terminal voltage across the cell is equal to, so voltage across the, so external resistance. But for the multiple cells or multiple resistances, the terminal voltage across cell is not equal to terminal voltage across the resistor. Therefore, P is equal to I square is equal to V square by R is equal to V into R. So, out of these three, the better thing is use I square into R is the better one. Therefore, now in this case P is equal to I square into R. Now, so what is the P is equal to I square into R? Let us find out. So, before that, what is the find out? What is the current value? I is equal to, so as I have given BLV by R plus R formula. Right. Therefore, is equal to how much now? B value how much I have given, that is equal to 4. L value we have taken, that is equal also 4. Now, V is equal to 2 we have taken, and what, that is the, so 1 plus 3 is equal to how much? R plus R is equal to 4. 1 4 cancel is equal to how much? That is equal to 8 ampere current is passing through it. Right. So, that is the current passes through the, so in the current passes through the circuit how much? So, 8 ampere we have taken. Therefore, in that case now, so power formula what? Power across the external resistance is equal to I square, nothing but 8 square into R value we have given, that is equal to, so 3, therefore now 64, so into 3 and that is equal to what? So, 192, so watt. So, 192 watt, 64 is 64 into 3 is equal what? So, 192 watt is the power generated in the problem. Again they will ask that, so what is the terminal voltage across the cell? Terminal voltage across the cell is equal to how much? So, if they will ask terminal voltage across the cell, formula what am? Terminal voltage across the cell Vt is equal to given by I minus I into R. That is the expression for that. Okay, terminal voltage across the, sorry, so power E minus I into R is the formula. So, what? Vt is equal to E minus I into R. In place of the E, we can take what? Small e minus I into R. Small e value how much now? That is equal to given by E is equal to BLV, right now, that is equal to B value 4 and L value is 4 and that is a 2. Therefore, now what? So, that is equal to 32 watts. So, 32 volts, if you substitute here, you can get that 32 minus, right now, I value how much you got? Already we have solved in the previous one. I is equal to 8 ampere. Therefore, now what? That is equal to, so E is equal to 32 minus I value 8 into R is equal to how much you have taken? R is equal to 1. Therefore, that is equal to what? 24 volts. Therefore, now, so it is, so having a terminal voltage of the 24 volts. Right now, therefore, 24 volts is the terminal voltage. Therefore, this type of the model problems are very important. So, not only depends upon the only motional EMF. If this conductor is connected into a metallic closed path, if that metallic closed path having some external resistance capital R, now it forms a closed path. If it is forms a closed path, now the current circulates in the circuit. Therefore, that current expression, power expression, all those we have given. Therefore, now what? These are all important power formula, power across this one. Next. See, the difficulty in the moving of the conductor. So, when a conductor is moving, so in a closed path, once again let me take for example, this is a metallic track. On this metallic track, we have taken one conductor This is the conductor. This conductor moving with a constant velocity, for example, Vm. But so we are unable to move this conductor with a constant velocity. Why? Because I will say the reason. For example, in this reason, the total magnetic field is so into the plane of the paper. This is the into the plane of the paper here also into the plane of paper. Imagine that this closed loop is present inside a uniform magnetic field. That uniform magnetic field, so B we have taken. Next, what? The length of the conductor is L now. So what? As it is a closed path, some amount of the current is passing. As I told you, this is acting as the positive terminal, this is acting as the negative terminal. Therefore, current we can expect like this. Therefore, now what? This is the current I. So this is the current I. This is the current I. Now, in this case, what? The current direction I we have taken. This is the direction of current. So this is a current wire. This current wire is present in the magnetic field. So in the yesterday discussion, when a current wire of length L is placed in a uniform magnetic field, it experiences what? Force. Right or not? What the direction of the force? According to Fleming left hand rule. So yesterday what? This forefinger gives the direction of the field and central finger gives the direction of velocity. Then what? Thumb gives the direction of the force. According to that, if you take like this, now what? So forefinger is into the plane of the paper and the central finger or middle finger is in the direction of velocity. Therefore now what? So here we can say what? This is the, so what? This is the current direction because this is the current. So well, not velocity, current direction. Current is what? I. Therefore this is the direction of magnetic field into the plane of the paper and the central finger is in the direction of the current. Now the thumb is acting this side. Therefore now what? The magnetic force experienced by current wire is Fm. Once again listen. When a conductor is kept in contact with a closed metallic loop, so it forms a closed circuit. As it is a closed circuit, compulsory there is a current. Because of the motion of the conductor, EMF produces. When EMF produces, if the circuit is closed, current will be generated. That current again produces magnetic force. Why? Because every conductor, when it is placed in uniform magnetic field, experiences a magnetic force. Yesterday, that F is equal to BIL sin theta. BIL sin theta, that is a formula. Right now, but here what? This is the force direction. What? Forefinger gives the direction of the field and the central finger gives the direction of the current. Thumb gives what? Thumb gives direction of the, so that is a force expended. Therefore now what? This force acting this side. When the force acting this side, again the conductor is opposed. Therefore, to move the conductor with constant velocity, we have to apply another external force. So, to move the conductor with compulsory constant velocity, net force is equal to 0 means what? So, compulsory to oppose this one, we have to apply another equal amount of the force. That force they will ask now. What force we have to apply? In the direction of the velocity, so that it has to move in the with the same constant velocity. Clear? Therefore, here when the current passes through the conductor, according to Fleming left hand rule, magnetic field force is acting in the opposite direction of velocity. Means the conductor is not moving freely. Conductor is not moving freely with constant velocity means what? This force is opposing. To move this conductor with constant velocity, net force must be 0. Net force must be 0 means what? One force acting this side, so other force must be acting on that side. That force also must be equal to the, so magnetic force. When both are equal and opposite, net force is equal to 0. The conductor is moving with constant velocity. Therefore, now what? The external force requires to move the conductor with constant velocity. With constant velocity, what? That external force F is equal to magnetic force only. Magnetic force in what? That is equal to B into I into L. BIL sin theta, but here, so theta is equal to 90. So again you are getting that what? BIL only. Therefore, F is equal to now BL into I value what we have taken, I value we have taken. So what that is the, so I value B L, I is equal to what? B L V by, so what that is equal to R plus R. Correct? Because the EMF by current, EMF by resistance, no. Therefore, what is the current formula? I is equal to E by R plus R. Motional EMF what? That is equal to BL by R plus R. BLV by R plus R we can find out. Therefore, now what? Here, but in most of the cases, they will give the negligence of resistance of that conductor. Therefore, now, if you take the R value 0, therefore, what you can get now? F is equal to B square L square V by R. This is the external force to be applied to move the conductor with a constant velocity. Okay, na? Therefore, now let us solve one problem. A conductor of length L is equal to 2 meter, moving with velocity V is equal to 100 centimeter. In a magnetic field B is equal to 2 Tesla. Right now? So, now if what is that, then the resistance of the metallic loop R is equal to, for example, that is I am taking that 4 ohms, then what is the force required to move the conductor with constant velocity? So, that direct formula only, na? So, what BLV I have given, R value given, F value I am asking what? Just now we have discussed formula what? So, the force formula F is equal to B square L square V by R only, because I am not giving the conductor which produces the EMF in this case. So, this one is produces EMF, that internal resistance I have not given, only metallic loop resistance or external resistance I have given. So, what that is equal to, you substitute there, you can get the answer. B square, so nothing but that is equal to 4. So, L square that is equal to also 4. Velocity V is equal to 100 centimeter, nothing but 1 meter. Therefore, now what? So, meter per second, and R is equal to, we have given what? 4. Therefore, 4 cancel is equal to 4 Newton. Therefore, in the motional EMF concept, so the other two important, because we should not concentrate only on BLV every time. So, they may ask the current, they may ask the power produced in the external resistance, they may ask what force we have to apply to move the conductor with the same velocity, I mean constant velocity. So, these are the procedures only, right now. So, EMF, so current, I mean motional EMF and its current, and also power and also force with which it has to move with constant velocity. So, all these are important, and in that if they will give the internal resistance, means what? The conductor which generates the EMF having some resistance, that resistance can be taken as what? Internal resistance, but in most of the cases if they won't give, take small r is equal to 0. Next, motional EMF in case of the falling rods, right? For example, let me take, so your sight, in what direction I am watching? So, that is I am taking the north, this is the south, then this is the west, this is the east. So, this is the north, south, so east and west, right? No, for example, west and east with respect to me. With respect to you, so it may change the direction. With respect to me, north, south, west, and it is the east. Now, so earth has two components of the magnetic field. So, one is the vertical component that can be taken as the, so BV, and one is horizontal component, that is the BH. With respect to the place on the earth surface, what these values are going to be changed. So, the magnetic field of the earth is not uniform, it is the non-uniform. Place to place, the two components values will change. So, automatically, so magnetic field also change. And so, BV and BH. Now, so here BH plays important role for the falling bodies. For example, when I will drop a rod like this, therefore, in this rod also induced EMF will be produced, I mean motional EMF is produced. But in which condition? For example, now as I told you, this is the east-west, and so BH direction of earth magnetic field is always acting from south to north. So, south to north means what? So, in this direction the earth's magnetic field will be act. For example, if this is the conductor, this chalk base is a conductor. So now if I will drop the conductor like this, now what is that? The length of the conductor and magnetic field both are in the same direction, means what? So if I will hold the conductor along the north-south direction, the length and the field both are coincided, theta is equal to 0, EMF is equal to 0. But if you drop the conductor, so this is the direction of magnetic field acting from south to north, therefore this is the line list, and this is the if I will take the rod like this, therefore length of the conductor and magnetic field both are perpendicular to each other. When I will drop like this, the velocity direction is towards, therefore now what? Velocity is downward and length is along the east-west and field is along the south-north. Therefore in this case, so what? The three, length, velocity, magnetic field, three are mutually perpendicular to each other. Therefore when a rod of length along the east-west is dropped, so from a certain height, therefore now the motional EMF in that case is given by E is equal to, so BH into LV nana. That is the formula. And this is what? This is the instantaneous EMF. Instantaneous EMF. Why I am saying that? Because at the starting, when I will drop, initial velocity V is equal to 0. Therefore, between the ends of the conductor, there is no any motional EMF. Therefore, now what? So initially V is equal to 0, so E is equal to 0. But with respect to the time, so you know that what is the velocity formula? Velocity for the free fall body, V is equal to G into D. So after 1 second, velocity becomes what? 10 meter per second. And after 2 seconds, so G into 2, so 2 into G, nothing but 2 into 10, that is equal to 20 meter per second and 30 meter per second. Therefore, for every 1 second, so there is an increase of 10 meter per second. Therefore, now what? So here E is equal to, at any time you can say that is equal to BH L into GT is the expression for that. So sometimes at any velocity, they won't give the time. After 3 seconds, 4 seconds, at any velocity 5 meter per second, find out the motional EMF produced in the conductor. And so at any time t is equal to 2 seconds. T is equal to 2 seconds means what? Velocity becomes what? 4 meter per second. Therefore, sometimes they will give the velocity directly or sometimes they will give the time directly. Therefore, now you can use any one of the formula. Therefore, this is not a constant motional EMF, it is the variable EMF. Why? Because when the rod comes down, the time changes. When the time changes, motional EMF also changes, and in this case the motional EMF is directly proportional to time. BH constant, L constant, G constant, so what? E is directly proportional to T, and one more thing is G is constant only for smaller heights. If you drop from a larger heights, G value also changes according to, so GH formula, GH is equal to G into 1 minus 2H by R, therefore G value is different. Therefore, for the smaller values we can take G is almost constant, therefore E directly proportional to T nana. Therefore, now what? It is applicable when the rod is like this. But so this is produced only, the length of the rod must and should be along what? Along the east-west direction. When the length of the rod is along the east-west, then and only then length, velocity and magnetic field, all three are mutually perpendicular to each other. Next, for example, when an aeroplane is traveling in the air or when a train is traveling on the earth's surface, now in that case, so along the axis of, across the axis of the, so train or aeroplane or across the wings of the aeroplane, across the wings of the aeroplane or across the ends of the axle of the train. Now the motional EMF is given by what? E is equal to, you can say that is equal to BV into L into V, where BV is the vertical component of magnetic field, L is the length and V is the velocity. Here BH is parallel to the earth surface, that's why, so here BH does not play the role, only BV. And when the rod is dropped, vertical component velocity always in the same direction. Therefore, when the rod is dropped from certain height, by keeping this length along the east-west direction, so BH plays the role, because BV, vertical component of the magnetic field of the earth, always parallel to the velocity, that's why BV does not play the role. But in case of a train moving on the earth surface or an aeroplane traveling in the air, in that BV plays the role. For that BH is parallel to that condition number. Therefore, now what BV is the vertical component, and these are also just like same problem they will give like that. At any place the vertical component of magnetic field of the earth is BV, they will give length of the, so axial they will give and V they will give. You can find out the problem from this also. Next, self-inductance. What is the self-inductance? So, let us suppose a coil, let us take. What is the meaning of a coil? It is a, so a circular coil or square coil, whatever it is the number of turns, right? No, the number of turns with some current passes through is called, can be taken what one coil I have taken. So, a coil can be represented like this, right? No, so a conductor in the form of number of turns, right? No, which produces, which having some amount of the current through it is called as a coil. Therefore, this is one coil I have taken. So, this coil I am connecting to one variable voltage source. One variable voltage source, nothing but you can take one alternating voltage source, alternating source I am taking that. Therefore, now this is not a constant potential difference. Now tell me, when this is the alternating source, automatically the current in the circuit also changes. What? Alternately changes, means what? Voltage changes. When the current passes through the chain, this one is changes. So what? Magnetic flux changes. Because, so according to our step, when the current passes through a conductor, magnetic field will be produced. If the current is constant, magnetic field through this coil is also constant, but this is the alternating source, current is variable. When the current is variable, magnetic field through this one is variable. When the magnetic field through this one is variable, magnetic flux changes. When the magnetic field flux changes, now what? Some induced EMF will be so generated. So in this coil, that phenomena is called self-induction. Self means what? Current changes in the same coil. Correct now, this is the coil I have taken. Current actually changes in the coil, in the same coil. So what? EMF will be so induced. Therefore, the phenomenon of generation of an induced EMF in a coil when the current changes in the same coil. Right? In which coil EMF is generated. So, in the same coil current has to change. Therefore, now what? That phenomenon is called as the self-induction, and here what we have taken self-inductance. So, self-inductance is the physical quantity, self-induction is a process. Therefore, what is the meaning of self-inductance? Let us say. Now, for example, now what? The current at any instant of the time, for example, I have taken right now. So, here what I am taking that the total 1, 2, 3, 4, 5, 6, 7, the total number of the turns I have taken that n, and the flux linked with each turn is equal to pi. Therefore, the total flux how much n into pi. If pi is the flux through the each turn, then through n number of the turns, the total flux linked how much? The total flux linked is n pi. Therefore, the flux linkage with the coil is directly proportional to current at any moment in that coil. Right now, so as per the practical observation, n pi, the total number of the turns is directly proportional to the current. Therefore, the total flux linked with any coil is directly proportional to current. And by removing proportionality, you are getting one constant, that is equal to n pi is equal to L into I. Therefore, this L is only called as the self-inductance n pi by Im. One expression, first expression for that. L is equal to n pi by I, and the SI unit of this, so flux is what? Flux, so magnetic flux is Weber per ampere. So Weber per ampere is also called what? Henry. HE, and there is what? This is the Weber per ampere. Weber per ampere, so we can take as what? Weber per ampere can be taken as what? That is a Henry. Henry is the SI unit of what? So this is the self-inductance. Right. Therefore, now one more expression. So, what is that? So, according to Faraday's law, According to Faraday's law, so you can say what, one more expression for the self inductance. So E is equal to given by what? E is equal to minus N into d pi by dt we have taken, so in the yesterday discussion. And if you take the N inside, therefore now what? So d by dt of N into pi. In place of the N pi, if you substitute L into I, we can get what? So E is equal to, so what that is equal to, so minus d by dt into what, that is equal to L into I have taken. Therefore now what? E is equal to, if you take the L outside, you can get a minus L into, so di by dt, di by dt. Again here the minus is according to Lenz law we have taken. Therefore E is equal to what? Minus L into di by dt. There are the, so one formula, self inductance L is equal to N pi by I, and so here the motional EMF, sorry, the induced EMF in this case is given by E is equal to minus L into di by dt. Therefore now what, tell me if the current is constant, for example in this constant current is passing. When the current is constant, di change in current is equal to 0. When the change in current is equal to 0, EMF is equal to 0. Therefore this inductor, this instrument is called as the inductor or coil. Right now, now this inductor works when there is a current changes in the coil. So if the constant current passes through this inductor, it is just acting as a connecting wire or conducting wire only, right now. But whenever there is a change in current, either to increase or the decrease, that is not a matter, current has to change. So when the current has to change, then what? Then there is a induced EMF, then and only then the conductor can work some. Therefore this is the, so what, that is the two formulas. One is L is equal to N pi by I, and that is equal to what? E is equal to minus L into di by dt, right now. Now let us solve one problem from this one. For example, the current in a solenoid changes according to formula, so T square minus 4T plus 1. Current in a coil changes according to formula what? I is equal to T square minus 4T plus 1, and the self inductance of the solenoid or coil is given by, for example, 4 Henry I am taking that. Then find out the induced EMF at a time t is equal to 1 second. At t is equal to 1 second, what is the induced EMF we want? Therefore, at the t is equal to 1 second of the time, induced EMF E value is equal to how much? E is equal to we want. Therefore, how to find out the E value? Just we have one expression, what we have now. So first of all, I am finding that di by dt value, because the formula what? The formula used in this problem is minus L into di by dt. First of all, we have to find out rate of flow of current. Rate of flow of current, rate of change of current we have to find out. Therefore, di by dt is equal to, here what we have taken, I is equal to t square minus 4t plus 1. Therefore, that is nothing but 2t minus 4 plus what? 0. Therefore, di by dt at what? At t is equal to 1 second is given by, so 2 into 1 minus 4, that is equal to what? Minus, so 2 ampere per second. Right now, current is decreasing actually, minus 2 ampere per second we have taken. Therefore, now you substitute that, we can get the answer what? That is equal to E is equal to minus 4, L value how much we have been? 4 into, this is what? Minus 2 you got it. Therefore, E is equal to minus into minus plus 8 volts. Therefore, at the time of t is equal to 1 second we got what? That is equal to, so 8 volts we got it. This is one model problems like that. Next, now for example, one or two cases for this, so just one formulas type models. Therefore, now for example, if you take this is one solenoid, and So if you take the solenoid and the total number of the turns, for example, n I am taking that. Now the length of the solenoid, for example, small l I will take, and the area of cross section, here I am not representing that area. If you take the area of cross section of the solenoid is the A, then what is the self inductance of the solenoid? That self inductance of the solenoid is given by what? So L is equal to, so mu naught, so n square A by L expression. In this case, so in many problems they will ask that, so how the self inductance varies with the number of turns. So the self inductance is of not only solenoid, anything. So self inductance L is directly proportional to square of the number of turns. Otherwise, if you take one circular coil if you take, and here this circular coil consisting of number of turns n. So if you take n number of the turns of the circular coil and the radius of the circular coil, for example, r I will take, then what? So in this case the self inductance of any circular coil is given by, so mu naught pi into, so n square, so r by 2. Therefore now this is the expression for that. Therefore now, so in this case, so L is directly proportional to n square, and in this case also L is directly proportional to n square irrespective of nature of the coil. So what? So you can find out self inductance of the coil. Therefore L is directly proportional to n square. Here also L is directly proportional to n square, and 90% of the cases they will ask that how the self inductance varies with the number of turns. They will give, so number of turns in the one coil, and they will ask what is the self inductance of the, so another coil if the number of turns becomes double, triple, like that. And here, so it also depends upon the medium. For example, here what is the mu naught, Nana? Mu naught is the permeability of the free space, but inside if the gap is filled with, in any another medium, then the self inductance, you take this better, you L naught, this is the L naught. Therefore now if you fill the gap of the solenoid with any another magnetic material, now you can becomes what, that is equal to mu can be replaced what now, that is a mu, so mu n square A by L. Therefore where mu can be written as what, so mu naught into mu r into n square, so A by L, and again you can take what, therefore that is equal to mu r into what, that is equal to L naught. I am taking that. Therefore whenever any material is filled in between the, so ends of the solenoid, therefore now what, the self inductance increases by how many times? Mu r times. Okay. So therefore this is the, so self inductance, and again mutual induction formulas also there, and once again you prepare them. Those are also what is the meaning of mutual induction, and then after, so what mutual induction for some problems, and very simple mutual inductance direct formula only. So for that mutual induction formula what, so you have to take the two coils. When you take the two coils, now what, the total flux linked with the secondary coil Ns pi s is equal to m into Ip we have to take. Means what, two coils at a time we have to take. When the current in the primary coil is the Ip, therefore now what, the mutual inductance, what, that is the total flux linked with the secondary coil is directly proportional to current passes to the primary coil. Therefore after removing, you are getting that what, m is equal to Ns pi s by, so that is what, Ip we have taken. Now so the induced EMF in the secondary coil is given by Es is equal to minus m into rate of change of current in the primary coil, so di by dt, and same formulas just here. So the induced EMF will be generated in the secondary coil and the current is passing in the primary coil. That is the only difference. And here also for the any two solenoids or for any two circular arcs, they will ask the mutual inductance. And tomorrow let us discuss about alternating current. Thank you.
Okay, ma. Good morning, all of you. Today, I am going to discuss about remaining part of the carbonyl compounds. Right, second day this one. Here also we will discuss. Yesterday we discussed some named reactions. Now here also we will discuss some named reactions. That is very important. Right. Before going to the named reactions, some of the compound is there. One of the time they are asking the match the following. Not only one of the time, every time they are asking the match the following questions. Those are ammonia and ammonia derivatives. Ammonia and ammonia derivatives. Ammonia and ammonia derivatives. That's why those reactions are called addition elimination reaction. Ammonia and ammonia derivatives are called addition and elimination. That means one reaction will take place both at a time, addition and elimination. Addition followed by elimination. Right? Observe now. What are those ammonia and ammonia derivatives? What do you call this one? This is called aldehyde. This is called ketone. Both at a time I am writing now. RC11A, that is called aldehyde. RC11R is called ketone, either aldehyde or ketone. Reacts with ammonia, first one. Right? Otherwise, react with primary amine, that is what? RNH2. Direct I am writing the product. First addition, then followed by elimination. So, now you don't want no direct answer they are asking now. Match the following time. Like this they are giving. So, aldehyde or ketone reacting with this ammonia and ammonia derivatives. This side product they are giving. Match the following. Right? So, whatever the ammonia derivative is there, then what we have to remove? Direct water molecule you have to remove. Remaining product you have to add. Observe now. In this carbonyl compound, either aldehyde or ketone is there, your oxygen, your hydrogen, H2, water eliminate. This is only now hint. Any ammonia and ammonia derivative they eliminate water molecule, just remaining you have to add. Then what I can get? R C double bond H2 HO and H2 water eliminate, remaining what is there now? NH. Remaining as it is. Here only will be changed. So oxygen removal by remaining product you have to add. That means water you have to eliminate. This is called as carbon getting double bond with NH. This is called imine. So names also they will give you. Instead of product they are giving names. That's why you should know the names. Aldehyde or ketone reacting with ammonia by the elimination of water to form a carbon with double bond NH, that is called imine. Next one. Same as it is. This is called amine. Which amine? Primary amine. Primary amine with aldehyde first. Later ketone. So same as it is. Here H2 and oxygen water you have to eliminate. Then what I can get the product? RC double bond N R. What is there now? H is there now. Just I am writing aldehyde. So what happened now? This one. Aldehyde with, I didn't say ketone. Aldehyde with primary amine. This is called primary amine. Aldehyde with primary amine by the elimination of water to form a, this is called imine we know. With one extra what is there now? Alkyl is there. That is called substituted. Substituted imine. Substituted imine is called as Skipp's base. This is one of the time they ask the question. Not ketone. Aldehyde with primary amine. Any aldehyde with primary amine to form a substituted imine is called as Skipp's base. So other one, ketone also has this product A, but that is not a called substituted imine. That is also called substituted imine, but you should not call Skipp's base. In case of aldehyde with primary amine to form a substituted imine is called as Skipp's base. Next one. Same aldehyde or ketone with NH2OH, that is called hydroxylamine. This is called hydroxylamine. Right, as it is product. Next one is this one. hydrazine. NH2 NH2 is called hydrazine. Next one is this one. This one 2,4 DNP. 2,4 means 2,4 dinitro. DN means dinitro. P means phenyl hydrazine. NH2 is called what? Hydrazine. NH2 attached with phenyl. That's why phenyl hydrazine. 2,4 nitro is there, that is called 2,4 DNP. The name is called 2,4 dinitrophenyl hydrazine. Is called Brody's reagent. This is called Brody's reagent. This one using to identify that given compounds are carbonyl compounds or not. The given compound is carbonyl compounds or not. How to identify? Those compounds are treated with the treated with the Brody's reagent. Brody's reagent. Right? Right. Next one. Last one is this one. NH2, NH, C double bond O, NH2. That is called semicarbazide. These are the very, very important. So many times they ask the match the following question. These only know. These are called ammonia and ammonia derivative. Still one is there, that is called hydrazine. That is called simply phenyl hydrazine. That is not required now. This is only main. Ammonia, primary amine, hydroxylamine, hydrazine, 2,4 dinitrophenyl hydrazine. That means 2,4 DNP. That is called semicarbazide. With aldehyde or ketone. Any aldehyde or ketone. Just general equation I was given. General formula I was given. Right. Same as it is. In this what you have to remove, water you have to remove. Here O, here NH2, means here H2, water eliminate, remaining product R, C, H, R, that is called RC, this R, C, O and H2, water eliminate, double bond, N, extra what is there now, OH, either H or R, H is there, aldehyde, R is there, ketone. This is called double bond, C double bond, N is called imine, but N with what is there now? OH there, that is called oxime. What is the name? Oxime. This is called oxime. Next one, hydrazine with aldehyde or ketone. Then what I can get? Same, water eliminate. Now double bond is there. Your double bond is there. Your double bond O and H2, water eliminate on that. Then what is the remaining? Here H2 eliminate, N is there now, next NH2 is there now. This is the only product. This is called, this is coming from hydrazine, that is called hydrazone. This is called hydrazone. Next one, 2,4 dinitrophenyl hydrazine. So what I can get the product? This one as it is, NO2, NO2, NH, here water, here H2 and there O, eliminate. That means you will get double bond with C, R, H or R, R, C double bond, OH, C double bond means O and H2 water eliminate, otherwise R, C double bond R. This is the either aldehyde or ketone. This is what? 2,4 dinitrophenyl hydrazine. That means the product is 2,4 dinitrophenyl hydrazone. Wait, some other one is there. Product is wrong. NH, here N is there. Double bond, C, R, H or R. This is only now. 2,4 dinitrophenyl hydrazone. Last one, semicarbazide. Observe now. Semicarbazide, one important point is there. Once I will write again once again here. Either aldehyde or ketone with NH2, NH, C double bond O, NH2. Right. Aldehyde or ketone, what you have to remove? Oxygen. Here what you have to remove? H2. Right. This side also NH2 is there, this side also NH2 is there. Which side H2, which side nitrogen contain hydrogen we have to remove? That means which side I have to remove hydrogen? That is only important point. Right to left. Which side? Left side only we have to remove, but not right side. Why? Because right side containing nitrogen is having nitrogen atom is attached to carbonyl group is there, carbonyl group, direct attached. Here indirectly attached, that means when N followed by again N, again CO, that means indirectly attached. This is directly attached. That time what will happen here? It is having the conjugation. How sir, how you know that the conjugation? Conjugation means already here heteroatom is there, heteroatom having compulsory lone pair of electron. You go, lone pair of electron, that means double bond here, oxygen double bond, single bond, lone pair. Double bond, single bond, lone pair. That means conjugation. Conjugation is there means involving in resonance. Which side is involving resonance? Right side. That's why this lone pair is involving resonance means this hydrogen will not be removed. That means this hydrogen will not involve in the reaction. This hydrogen will be involved in the reaction. That means here there is no conjugation. That's why this H2 and O, very very important. This H2 and O water eliminate. Remaining product is what? R double bond H or R C double bond. Here O and H, H2 what eliminate, then what is there now? N, NH, C double bond O, NH2. This is the one of the time they ask the question separately. Match the following one of the time, one or two times. This separately they ask. This is called semicarbazone. This is coming from semicarbazide. That is called semicarbazone. These are called ammonia and ammonia derivative. Just simply what I did, just I taken reactant means reagent, what both are called reactant, reagent I taken, then directly I written product by the elimination of water molecule. Right. Next one. What is the next one? Distinguish test for both aldehyde and ketone. Distinguish. Distinguish test, that means I am giving mixture of aldehyde and ketone. Which one is aldehyde, which one is ketone? How to identify? By using distinguish test. Those are there. Those two are there now here in this chapter. So what are those? One is Tollens reagent. Second one is Fehling's reagent. Fehling's reagent. These two, right? So one of the time, not one of the last 2025 exam, this question they ask. Which of the following option is correct for the Fehling's reagent? 4 options they are given. Direct Fehling's reagent, a definition what they are asked now. Now observe now. First, what is meant by Tollens reagent? Tollens reagent is called ammonical silver nitrate. Ammonical silver nitrate or freshly prepared ammonical silver nitrate test. Silver nitrate is called as Tollens reagent. Fehling's reagent. Fehling's reagent means two solutions are there. That is what Fehling's solution A and B. Fehling's solution A is what? Aqueous copper sulfate. Aqueous copper sulfate. Aqueous. This one is alkaline sodium potassium tartarate. What is that? One is mixture of aqueous copper sulfate. Fehling's solution B is alkaline sodium potassium and sodium potassium tartarate is called Rochely salt. Is called Rochely salt. This equimolar mixture of A and B is called as Fehling's reagent. This is the question they are asked. The 4 options they are given. One of the option is aqueous copper sulfate and alkaline sodium potassium tartarate. That is the first option. Second option is alkaline copper sulfate and alkaline sodium potassium tartarate. Third option aqueous copper sulfate. Fourth aqueous copper sulfate, aqueous sodium potassium tartarate. So there only know all are same options. The small changes they were given. So the small changes you need to identify means compulsory. You should know this one mixture. First one is aqueous copper sulfate. Second one is alkaline sodium potassium tartarate. This is called Rochely salt. That mixture is called as Fehling's reagent. These two tests using you can distinguish distinguish between aldehyde and ketone. These two are called mild oxidizing agents. Already we know mild oxidizing agents. Mild oxidizing agents already you know, PCC, PDC, CrO3 anhydride. Those are called mild oxidizing agent, including these two. These two specially for distinguished test for aldehydes and ketones. Mild oxidizing agents, tolerance reagent and Palin's reagent. These two other point, these two reactions will take place in alkaline medium. Alkaline medium. Alkaline means basic medium. Observe here. So, this one how to identify aldehyde and ketones are there. Aldehydes will give the positive test. It is giving positive. Positive means it will give. Negative means it is not giving. That is the meaning, identification. So, aldehydes, different types of aldehydes I am giving to you. So, how do you identify that? First one, I am giving aldehyde this one. What is this one? Formaldehyde. Second one is CH3 C double bond OH, acetaldehyde. Third one is benzaldehyde. Fourth one is ketone. Fifth one is acetophenone. These names you should know. What is aldehyde? Methanol, also called formaldehyde. Ethanol, acetaldehyde. Benzaldehyde, acetone or propanone, acetophenone. So, I am giving tolerance reagent and Palin's reagent. Which one is give the positive, which one is give the negative. So, aldehydes and ketones can be separated by using tolerance reagent, distinguish. So, aldehyde is there, positive, ketone is there, negative. You observe now, this aldehyde, aldehyde means this is positive, positive means just I am writing right mark, positive, this is also positive. This is what? Again aldehyde, positive, positive. What is this? Benzaldehyde. Benzaldehyde means aromatic aldehyde. These two are aliphatic aldehyde. This is called aromatic aldehyde. Aromatic aldehyde with tolerance reagent is positive. Aromatic aldehyde with Paling reagent is negative, because that means in these two comparison, tolerance reagent also mild oxidizing agent, this also mild oxidizing agent, but in these two very weak, very mild is what you call, which one? Paling's reagent. That's why in case of benzaldehyde, this aldehyde also in case of aromatic compound, Paling reagent will not give. That is called positive. That is called negative. Why? Because sometimes one of the factor we can say one of the factor is resonance. Other factor is it is very mild oxidizing agent compared to tolerance reagent. Next one, ketone. Ketone means this is only differentiation. Distinguish aldehyde and ketone. Aldehyde is there positive, ketone is there will not give. That is what negative in case of tolerance reagent, in case of Paling reagent. Next one, this is called acetophenone. This also, this acetophenone means what there no ketone. So negative. This is the information. Like this question they are asking now. How many of the following compound is giving tolerant test? How many of the following compounds are giving what you call Paling test, like that they are asking. One of the time they ask the question. If it is giving what is the product, that product you should know first. Sometime that reagent they are giving, that reagent with observe here, I am taking aldehyde. Okay, general exam is that exam, just a direct example I am taking now. CH3CHO, aldehyde. This I am taking CH3C double bond OCH, that is called ketone. With your tolerance reagent. Tolerance reagent means what I told, ammonical silver nitrate. That means like this. AgNH3 twice plus 1. They are giving me, that is the meaning of ammonical silver nitrate. That means ammonium hydroxide and silver chloride, AgCl, that mixture. This one you are getting one complex, that is what, AgNH3 twice plus. In this Ag oxidation state is plus 1. Here plus 1 oxidation state. That is given mean, that is the meaning of identification tolerance reagent. Here what they will give you, here also same thing, that means AgNH3 plus 2 they are given. This reaction will take place which medium I told? Basic medium, that means alkaline medium. So alkaline medium. Then what the product I can get? This is what I told, mild oxidizing agent I told. Mild oxidizing agent means any oxidizing agent is there, final product is actually carboxylic acid. Right? Alcohol to aldehyde, aldehyde to acid. But this is mild oxidizing agent. Mild oxidizing agent and strong oxidizing agent is difference is, already we know, strong oxidizing agent is there means single step to multi steps will take place. Mild oxidizing agent is there means it will take place only single step. That is only difference, main difference, identification. But that once again I am saying now, strong oxidizing agent is there, reaction will take place single step to multi steps. But in case of mild oxidizing agent is there, only one single step only will take place. Single step means here what is there now? Aldehyde. Aldehyde to, this is oxidizing agent means compulsory converted to acid. Aldehyde to next step is acid only now. So that's what? CH3COO minus. But you will not get the acid. That means salts of carboxylic acid you will get it you. This you know. From here it is what happened, observe clearly. Then it will release Ag metal. That means it will release Ag. Ag metal due to the formation of Ag, it will give the silver mirror. Silver mirror is formed when aldehyde reacting with Tollens reagent to form a silver mirror. Silver mirror because of Ag metal. Because of Ag metal, right? Now what happened? Aldehyde to acid, what happened? Here addition of oxygen from here to it is called oxidation. Oxidation, this process is called oxidation. This oxidation means this aldehyde acting as a reducing agent. This reducing agent means this is acting as a oxidizing agent. That means silver nitrate. That means ammonical silver nitrate is acting as a oxidizing agent. Which oxidizing agent? Mild oxidizing agent. Otherwise, here one of the time, here silver oxidation state is how much here? Silver Ag is +1. The complex ammonia is 0. Neutral complex, neutral ligand 0. Ag is +1. Here +1 to here Ag how much here? 0. +1 to 0. That means oxidation state is decreases. +1 to 0. Oxidation state decrease means what you call reduction. Which is undergo reduction? Ammonia complex undergo reduction. Reduction means this is called oxidizing agent. Here oxidation state is changes from +1 to 0. It is from silver mirror. It is forming silver mirror means because of Ag. Silver mirror is forming means that given compound must be aldehyde, not a ketone. Same observe here. If you want acid means this compulsory done by acidification H+. Directly you will not get the acid. So salts of acid you will get. If you want acid means compulsory it can be done by acidification H+. Right, next one. This is ketone. Ketone with same reagent. What is the product? No product. That means no reaction. No reaction means it is negative, it is positive. That is the meaning. Next one. Same reaction with the Fehling's reagent. Fehling's reagent means how to know that? Copper sulfate plus sodium potassium tartarate. That means here copper in the form of +2 oxidation, like this they will give Cu +2 or Cu2 plus followed by OH minus. That OH minus meaning alkaline medium. This is called as Fehling's reagent. Direct means the total they will not mention. Aqueous copper sulfate, sodium potassium tartarate they will not mention. What they will mention? Cu +2. This Cu +2 coming from that mixture. CuSO for already there. That means Cu +2. Here copper in this oxidation is +2. Right? Then what happened? Aldehyde. Aldehyde is converted to again same as it is salts of carboxylic acid. If you want acid means can be done by acidification, but it release Cu2O. It forms Cu2O. Cu2O means cuprous oxide. Here copper oxidation state is here copper 2x minus 2 equal to 0, x equal to +1. That means here copper oxidation state is +1. Here copper oxidation state is +2. +2 to +1. That means oxidation state decreases. Oxidation state decreases means what you call reduction. This is reduction means which is undergo reduction? Cu +2 undergo reduction. That means it is acting as a oxidizing agent. Which oxidizing agent? Mild oxidizing agent. It is from sorry, what is correct only? Cuprous oxide is color is called reddish brown. Reddish brown color. You are getting reddish brown color means that given compound must be aldehyde. Given compound must be what? Aldehyde. Right? In case of ketone with Cu plus 2, then what is the product? No product. So that's why based on this tolerance reagent and what you call failing reagent using, you can distinguish both aldehyde and ketone. So here oxidation state changes from +1 to 0. Here oxidation state changes from +2 to +1. Is reddish brown. Here silver mirror. Right? This is a distinguished test for aldehyde and ketones. Next one. Haloform reaction, named reaction. Three named reactions are there now. Today I will discuss. One is haloform reaction, other one is aldol reaction, next one is Cannizzaro reaction. Observe here. Haloform, clearly observe Amma. Haloform, direct aldol, Cannizzaro. Right? Which one is give the positive, which one is give the negative? Direct I am writing now. So before going that, we should know the condition here. In case of haloform, either aldehydes or ketone want to haloform reaction means what is the condition we need? This is the condition. Methyl keto. This is called CH3CO is called methyl keto. Aldol condensation means presence of alpha hydrogen. Carbonyl compound containing presence of alpha hydrogen. Cannizzaro reaction means absence of alpha hydrogen. Some other condition, right? This is the condition. This condition will satisfy in case of this one. This carbonyl compound satisfy this condition. It will give the haloform reaction. Haloform means most of that is what they are giving most of the questions. Iodoform is forming that is called which color? Yellow color. Yellow PPT. Yellow PPT indicates that is called iodoform. That is meaning CHI3. Okay. Presence of alpha hydrogen. That again reaction will take place at dilute alkali or dilute base. Dilute alkali means what is the meaning? NaOH, dilute NaOH, KOH. Dilute means water is present here. KOH, BaOH twice. Right? Like that, anyone. These are the bases. It's dilute. But here, absence of alpha is not concentrated alkali. Concentrated alkali means what? Concentrated KOH, concentrated NaOH, concentrated BaOH twice. Otherwise, instead of that, they will give you concentrated OH minus. That means OH is coming from KOH or NaOH or BaOH, anyone. Here also dilute OH minus, like that they will give you. These are the conditions. In case of aldol means presence of alpha is compulsory. Again, dilute base required. Second one, absence of alpha and concentrated alkali. In case of Cannizzaro. Haloform, methyl keto. For carb, this is for carbonyl compound. So, these conditions satisfy any question. So, it will give the positive, that is called satisfy, that will give that reaction. Right? Some of the time they ask the question, how many of the following compounds are giving haloform reaction? How many of the following compounds are giving aldol reaction? How many of the following reactions giving Cannizzaro reaction? So, observe now. Same as it is questions. What? This is what? Methanol or formaldehyde. This is what? Ethanol. This is what? Ketone. This is what? Benzaldehyde. This is what? Acetophenone. This is what? Benzophenone. This is only main. Maximum question they are asking. These only maximum chances. What are those? 1, 2, 3, 4, 5, 6 total 5. 6 are there now. Right? Observe now. One is formaldehyde, also called methanol. Ethanol, also called acetaldehyde. Acetone, also called propanone. Benzaldehyde, that is called acetophenone. This is called benzophenone. Right? Observe. First one, haloform reaction. This one, positive or negative? Negative. Why? What is the requirement? Methyl keto. Here keto is there, methyl is not there, that's why it will not give. Presence of alpha hydrogen. First we should know what we have to know. For example, I will take this one. This is called functional group. Functional group adjacent carbon is called, functional group directly attached to first carbon is called what? Alpha carbon. Alpha carbon attached hydrogens are called alpha hydrogen. So observe now. Here functional group. Functional group attached direct hydrogen. Functional group attached adjacent carbon alpha. Here alpha carbon is not there. Alpha carbon not there means alpha hydrogens are not there. That means we need alpha hydrogen. That means it will not give. Now here absence of alpha hydrogen. Absence of alpha means alpha hydrogens are absent. That's why it will give the positive. That means haloform reaction, aldol reaction is negative. Which one? Formaldehyde. Positive is Cannizzaro. Next. Observe here. Next one. Haloform reaction. Yes. Methyl keto. Methyl keto is there. Yes. Positive. Now here. Presence of alpha hydrogen. Observe. This is the functional group. Functional group first carbon is called alpha. Alpha carbon containing hydrogens are called alpha hydrogens are there. Yes. 3 hydrogens are there. We need 1. It is also positive. Next. Here alpha hydrogens are there. But here absence of alpha hydrogen. That's why it is negative. Next. Ketone. Observe here. First one haloform. Methyl keto. Any side you can take. Methyl keto. Right side or methyl keto. Left side. 2 sides are there. Okay, no problem. That's why it will give positive. Now, aldol reaction. Yes. CH3 C11 means functional group. Functional group first carbon alpha. This also alpha. Alpha hydrogens are there. Positive. This one is negative. Observe again. Haloform reaction. Haloform reaction methyl keto. Okay, C11 that means benzaldehyde means meaning like this. C double bond OH. Keto is there, but methyl is not. This is carbon. Carbon having only, there is no hydrogen. That means methyl we need. CH is not there. That's why it will not give negative. What about this? Presence of alpha hydrogen. Observe now. Functional group. Functional group first carbon is called alpha. This is alpha. Alpha carbon containing hydrogen, that is called alpha hydrogen. There is no alpha hydrogen. That means no alpha hydrogen because carbonate tetravalence already satisfied. So no alpha hydrogen means absence of alpha hydrogen. Absence of alpha hydrogen means Cannizzaro is positive, aldol is negative. Next one. Next, methyl keto is there. Methyl with keto. This is called estophenone. So haloform positive. This is the functional group. Functional group first carbon alpha. Alpha carbon containing hydrogens are alpha hydrogen. So that's why aldol also positive. What about Cannizzaro? Cannizzaro is negative. Next one observe now. This one. This one is methyl keto is not there. Absence. So again functional group first carbon is called alpha. This is alpha. This is alpha. Absence of alpha hydrogen. So it will not give positive. That means again it will give the positive. But it is somewhat little bit, not exactly because more bulkier groups are there, more steric hindrance is there. That's why it will give, but most of the cases it will not give. So this also will not give because of bulkier groups, more steric hindrance. So this is the information about what you call aldol Cannizzaro. So by using this, I am going to explain about first haloform reaction. How to identify that the haloform reaction or not? First methyl keto is there. Yes, methyl keto is there. That means it will give the haloform and also it give the aldol also. Why? Presence of alpha. That means this will give the both what you call aldol and haloform reaction but not Cannizzaro. So now this one is aldol or haloform. How to identify? Reagent. A reagent is NaOH plus X2. NaOH plus X2. NaOH plus X2 means sodium hydroxide, sodium or potassium hydroxide, any hydroxide, any halogen, any base with halogen. Halogen may be chlorine, bromine, iodine. Sometimes they will give you, observe here, NaOH with X2, then what I can get? H and X, HX eliminate, NaO and X, NaOX. Sometimes they will give you. plus HX. This is called sodium hypohalite. Sodium hypohalite. If I will take chlorine, sodium hypochlorite. If I will take bromide, sodium hypobromite. If I will take iodine, sodium hypoiodite. Right? Based on that, which halogen you are taking now? Observe now. Sometimes they will be like, this one is coming from this one only. That is the meaning of that meaning, what you call alloform reaction. Right. Now what is the observation? Clearly observe now. This methyl keto is there. This is called alloform reaction. Here methyl keto is there. Methyl keto. In that methyl keto, methyl group is converted to haloform. That means CHI3. That means CHX3. CH3, these three, two hydrogens are replaced by what I can get? Halogen. That means CHX3. That is called haloform. This one. Remaining group is there. Remaining group is oxidized to salts of carboxylic acid. Observe now. H, C double bond O. Remaining what is there now here? ONA. ONA. This one we have to add. This is called sodium salts of carboxylic acid. This is the product you can get. Sodium salt of carboxylic acid. This is a haloform. If haloform is maybe chlorine, chloroform. Halogen may be bromine, bromoform. Halogen may be iodine, iodoform. If I will take iodine means I can get CHI3. This iodoform is a which color? Yellow color. Yellow color PPT. Next one. Same question I am giving to you. CH3, C double bond O, CH3. Instead of that, I am giving some other question. Simple, instead of simple question, I will give some other different question. Acetophenone with KOH with I2. KOH with I2. Potassium hydroxide followed by iodine. That means potassium hypoiodite. This reagent is given means we should know what we have to know. That is alloform reaction. Otherwise, this iodoform reaction. Otherwise, iodoform reaction means alloform reaction means it required condition. What is the condition? Methyl keto. Yes, methyl keto is there. Methyl keto is there. Methyl keto is there means what happened now? Methyl group. This is methyl group. This is methyl group. Methyl group is converted to haloform. Here iodine means iodoform. That means CHI3. That means yellow form, yellow PPT. This is over now. This is eliminated. Remaining group is there. Remaining group is oxidized. This one benzene C double bond O. Benzene C double bond O is there extra. Then what you have to add? This one OK. Here OK, here ONA. OK. O minus K plus. This is called potassium salts of benzoate. Potassium salts of benzoate means this is what? Salts of carboxylic acid. This is called iodoform. This is the product. Like this, you have to write the products for this. What do you call? Alloform reaction. Here again, methyl keto is there, double bond is there, double bond will not be oxidized. Next one. These are called carbonyl compound. If alcohol also want to give the haloform reaction, alcohol also will give the haloform reaction. Observe here, alcohols. CH3, CH2OH. CH3, CH, OH, CH3. CH3, C, CH3, OH, CH. This is called primary alcohol, secondary alcohol, tertiary alcohol. So aldehydes already I told. Aldehydes means carbonyl compound I told. Carbonyl compound haloform reaction want to give means methyl keto is the condition. But in case of alcohol, alcohol also there, alcohol also will give the haloform reaction. How to identify? Same. What is the condition here? One condition is there now. What is the condition? First condition in case of alcohol, alpha hydrogen and beta methyl group is present. In case of alcohol, those alcohols will give the haloform reaction. Once again you check it. What is the condition? Alpha hydrogen, at least one alpha hydrogen with beta methyl group is present in case of alcohol. Those alcohols will give the haloform reaction. Observe here. First one is the functional group. Functional group attached to first carbon, alpha. The next carbon, beta. What is the condition we need? Alpha hydrogen. Yes, alpha hydrogen is there. Alpha carbon containing hydrogens are called alpha hydrogen. Yes, alpha hydrogens are there. Again, beta methyl. Yes, beta methyl is there now. That means this primary alcohol is satisfying these two conditions. That's why this will give haloform reaction. That is called positive. Next, observe this one. Secondary alcohol, OH. OH group attached to first carbon, alpha. This is the alpha. That means functional group attached to first carbon, alpha. This is beta. This is beta. That means what we need? Alpha hydrogen we need. Yes, alpha hydrogen is there. Alpha carbon, alpha, at least one alpha yes, is there. Beta methyl is there. Beta methyl. That means two conditions is satisfied. That means secondary alcohol also will give the ketone. Second alcohol also will give the what you call haloform reaction. Now tertiary alcohol, observe now. Tertiary alcohol. Functional group. First carbon is called what? Alpha. This is the alpha. These are called beta, beta, beta. How many beta carbons are there? 3 beta carbons. That means 3 beta carbons are there. Those are called 3 beta methyl groups are there. Okay, beta methyl is there. What about alpha hydrogen? Alpha carbon is there, but no alpha hydrogen. That means absence of alpha hydrogen. That's why it will not give the what? Haloform reaction. That means primary alcohol, secondary alcohol, tertiary alcohols are there. Which alcohols are will give the, which of the following alcohols are will give the haloform reaction? Primary and secondary, but not tertiary. Reason is absence of alpha hydrogen. Okay. Just that one example I will give you, next followed by some other named reaction, that is called aldol condensation. Observe here. Which alcohol? Primary alcohol. What I told, primary alcohol and secondary alcohol will give. Yes. With which reagent? NaOH followed by X2. X2 may be chlorine or bromine or iodine. Okay, Cl2. Followed by heating. Same reagent I am giving to you. NaOH Cl2 means that is meaning haloform reaction. Primary alcohol, second alcohol will give or not? Yes, already I told you. It will give means what will happen first? Products I want now. First what will happen? Primary alcohol with chlorine, halogen. What happened? Primary alcohol first, primary alcohol with halogen, first step, what will happen? It is converted to oxidation. It is alcohol is converted to aldehyde. That means it is undergo oxidation. Why? Chlorine is the role is here. In this case is what is called oxidizing agent. That means alcohol is converted to aldehyde. That means which alcohol? Primary alcohol. In case of secondary alcohol with this reagent only, first it is converted to ketone. That means alcohol, primary alcohol, secondary alcohol, first NaOH to halogen, what will happen? It is undergo halogenation. It converted to carbonyl compound. That is the first step. That is the reason it is giving haloform reaction. That is the reason I told it satisfies those conditions. What happened? Primary alcohol converted to what? Aldehyde. Secondary alcohol converted to what? Ketone. Both are oxidized. That means here chlorine role is oxidizing agent in this case. After that reagent I am using here, aldehyde, methyl keto is there. Keto, methyl keto is there. Methyl group is converted to a haloform, remaining group is converted to what? Sodium salts of carboxylic acid. That's the step you should know. Then followed by remaining reaction. This is the information about what you call haloform reaction. Next one. Aldol condensation. Aldol condensation reaction. Right. Direct I am writing now product. In reaction they will give you how to write the product. So we need here already I told condition presence of alpha hydrogen then again it is reaction will takes place in dilute alkali, okay, that is what. So there also alpha Cannizzaro reaction, absence of alpha hydrogen and concentrated alkali. But in these two cases, 2 moles of carbonyl compounds we need. How many moles? 2 moles of carbonyl compounds we need. For example, I am giving like this, question I am giving like this. Otherwise I am giving compound like this. Wait. C11O CH3. Otherwise I am giving the compound like this. CH3 CHO plus CH3 CH2 CH2. This is direct. These are the NCERT questions. So many times they ask. With, they will mention like this, dilute alkali followed by heating, like that they will give you. What is the product I can expect? Here also same reagent. That means dilute alkali means what you have to remember, that is compulsory aldol. Aldol means what is the requirement? Presence of alpha hydrogen. Yes. Functional group aldehyde. Functional group aldehyde that means first carbon. Functional group attached first carbon is called alpha. Alpha carbon containing hydrogens are called alpha hydrogen. Yes, it is there. That means how many moles of all carbonyl compounds we need? 2 moles. Then what will happen? Observe direct product I am writing now. CH3 C double bond OH. Arrangement observe now. How I am arranging? Direct I am writing the product. If this is 1 mole. Same mole. They are not mentioning anything, means that is only you have to take same mole. Next one. CH3 CHO. This is 1 mole of aldehyde, this second mole of aldehyde. With which one? Dilute NaOH. So dilute alkali. Why sir you are taking 2 moles? We need 2 moles here. Yes, what happened? In this aldol condensation direct product observe now. In the first mole, clearly observe. First mole, carbonyl oxygen we have to remove. Hint I am saying directly. First mole what you have to remove? Carbonyl oxygen. Oxygen you have to remove. Second mole is the main role. Second mole is what? Functional group. Functional group first carbon is called what? Alpha. Second mole alpha carbon containing H2. H2 hydrogen, H2 we have to remove. Here H2, here oxygen. First mole is oxygen. Second mole is H2. That H2 from which carbon? Alpha carbon. You remove, then write the product. You will get the product. That product is our requirement product. Remaining observe CH3, CH. What is there now? Double bond here. Here what is eliminated? H2. H2 and O. What is the remaining? CH only there. Remaining what? CHO. Like this. This is our product. What is the product? This product is called aldol condensation product. Condensation means elimination of water. So water is eliminated, direct water is eliminated. Oxygen from first mole, H2 from second mole containing alpha carbon. Alpha carbon. So water eliminated, direct product. This is called aldol condensation product. Aldol condensation product means functional group. This is called alpha. This is called beta. Alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound. It is coming from aldehyde means aldol. It is coming from ketone means ketol. Water is eliminated, that is called aldol with water eliminated, that is called condensation. This total process is called what? Aldol condensation. This is called aldol condensation product. What is the name? 1, 2, 3, 4. But. 2 in, second position double bond. 2 in, 1 all. 2 enol. 2 enol. But 2 enol is the product. Right? Sir, sometimes they will ask aldol product, sir. How to write? This aldol condensation product. So in the trick using, otherwise hint using, you are getting direct product is aldol condensation product. Sometimes the question they will ask aldol products are how to write. Aldol products means nothing will be there. Simple. Alpha beta. Alpha beta. What happened here? Alpha beta double bond you remove. Double bond you remove now. Because we got double bond, no? The double bond you remove. Okay, removed. Then what you have to write? So double bond you remove. What you are removed now? Here water is eliminated. Whatever the water is eliminated, that water you have to add. You have to where you have to add, where the double bond is there now. That means OH is compulsory beta position, hydrogen from compulsory alpha position. This is the product. This is called aldol product. OH and H what? Water. In this first step, what I removed? Water. Water I remove, then I got aldol condensation product. Again condensation product, I am adding water, I am getting aldol product. This is the aldol product. This is aldol. What is aldol product? Functional group. This is alpha, this is beta. What do you call? Alpha, beta. Otherwise, beta hydroxy. Beta position what is there? OH group. Beta hydroxy aldehyde. Otherwise, beta hydroxy ketone. Beta hydroxy aldehyde is called aldol. Beta hydroxy ketone is called ketol. Right? This is the aldol product. What happened to aldol product? Double bond I removed. Removing a double bond, what I added? Water. Why? Because what you removed? Water. Water I am added. OH where I have added? Alpha carbon, beta carbon. Beta carbon. Beta carbon is OH. Remaining H compulsory you have to add H only now. Alpha only now. That is called aldol product. Right? This is only information about what you call aldol condensation. Some other product observe now. That means this aldol condensation will take place 2 moles of aldehyde. That means same molar, different molar. That means same molecule of aldehydes or ketones, same molecule, either same A, 2 moles I taken same A. Same molecules of aldehydes or ketone also. Either same molecules of aldehyde or ketone undergo aldol condensation is called as self-aldol. Self-aldol, that point you have to know. What is that? Same molecule of aldehyde or ketone undergo aldol reaction, that is called as self-aldol. Next one. Ketone observe no? Ketone. They are not mentioned nothing, that they are not mentioned 2 mole, they are mentioned just 1 mole. But we should know how many moles we have to take, 2 moles, right? With which base? Dilute base. So compulsory this also undergo aldol reaction. How to know? Dilute base they are given. Presence of alpha hydrogens are there. Yes. That means how many moles? Observe now, 2 moles. That means like this we have to arrange. Carbonyl group compulsory this side, right side, like this. Remaining any group is there, observe clearly. CH3, C double bond O, CH3. What we need here? Carbonyl oxygen. So oxygen that side. Remaining group, left side this, left side group, left side only now. Right side groups are there here. Right side groups you have to write and substituent. Substituent like this you have to arrange. Right side, left side as it is in this. Right side group is there because ketone group you have to keep right side. Right side groups are there, you have to write it down. Down means substituent like this. That is the first ketone. Second ketone. Go second ketone. CH3, C double bond O, CH3. The second ketone what we need? Left side alpha or alpha hydrogens we need. Because this is the functional group. Functional group ka first carbon alpha. This is also called alpha. That's why this is alpha. Right? Only alpha carbon you have to keep left side only. Alpha carbon attached some other groups are there, then you have to write down only now, substituent. Right, observe now. Then what you have to remove? Oxygen from first mole, hydrogen from, not hydrogen, H2 from second mole. Second mole of which carbon? Alpha carbon. Then you remove and write the answer. CH3, C double bond. Now substituent CH3, here what will be there? H2 eliminate, remaining what is there? CH, remaining CO, CH3. What is this? What is this one? This is called as aldol condensation product. Aldol condensation product. Right? How you know? Functional group alpha beta. Alpha beta unsaturated ketone. Otherwise alpha beta unsaturated carbonyl compound. That is called aldol condensation. I want aldol. Then what you have to remove? What you have to do? Here I removed water. I have to add water. Double bond you remove. CH3, C, CH3, single bond, CH, C double bond O, CH3 as it is. Then what you have to remove? What you have to do? Water you have to add, and that water OH where you have to add? Beta carbon. This is the functional group. First carbon alpha, this is called beta. So this beta, here what you have to add? OH. Here what you have to add? Hydrogen. This is only know. This is called what? Aldol condensation product. Right? Now this also called what? What do you call? Self-aldol. Why you call self-aldol? Same molecules of ketones undergo aldol condensation is called self-aldol. Now this one observe now. This aldehyde. Yes. Ethanol. This is propanol. Ethanol, propanol undergo ethanol, propanol undergo aldol condensation in the presence of dilute NaOH. That means two different types of aldehyde. Two different types of aldehydes or two different types of ketone, either one type of one aldehyde, one ketone, different anyway. One aldehyde, one ketone, either way two aldehydes, that means two aldehydes are different, either two ketones are different, undergo aldol condensation. That aldol condensation is called as cross aldol. What do you call? Cross aldol condensation. Different types of aldehydes or ketones undergo aldol condensation is called cross aldol condensation. Observe here. Cross aldol condensation means observe here. Okay? Different types. Clearly observe now. This one, different types first. CH3CHO, CH3CH2CHO. This also having alpha carbon. This also having alpha carbon. This one, not this one. This is beta. Arrangement like that. Observe now. First aldol. This one okay. CH3 C double bond OH. Products I am writing now. Plus this one CHO, CH2, CH3 is down, means substituent. Why I written substituent? Second mole what we need? Alpha carbon. So alpha carbon left side. Remaining any group is there, extra group is there, that group you have to write substituent. This is beta. Functional group alpha beta. That's a beta I written down. Observe. Then what you can remove? Oh, like this. Oxygen from first mole, H2 from second mole. Then write the product. CH3, CH, that means CH, double bond. What is there now? C, CH3, CHO. This is the one of the cross aldol. That means two different types. Right? That means first mole this one I taken. Now reverse I am taking now. Reverse also possible. Reverse. CH3, CH2, C double bond way. That means before case oxygen removed from ethanol. Now this case, second case, oxygen removed from where? Propanol, hydrogen removed from ethanol. Reverse. CH3, CHO. This is the functional group, this is alpha. So extra not there. Now oxygen from, then what you have to remove? Water you remove. Oxygen from first mole, second mole is what you have to remove? H2. Second mole of which carbon? Alpha. Product is CH3, CH2, CH, double bond. Here what is there? CH, CHO. This is also one of the cross aldol product. That means how many cross aldol product? Two. Two different types of aldehydes or two different types of ketone or one aldehyde, one ketone is there. How many cross aldol product you are getting? Both are having the alpha hydrogen. Yes. This also having the alpha, this also having the alpha hydrogen. That time how many cross aldol? Two cross aldol. So total product I am observing now. So different types of aldehydes are ketone, either one aldehyde or one ketone. Both are having the alpha hydrogen. Both are having alpha hydrogen. We will get two cross aldol. That means this is one cross, this is one cross. Again two self aldol. Total 2 plus 2, 4 products you will get it now. Sir, how to know, sir? Already written. These are called two cross aldol. This mole again same mole of this one only now. Same mole of this one. One mole of this is one cross aldol. One mole of this is called other cross aldol. That means that one two cross aldol I written. Now one mole of this, that means same again other mole, 1 plus 1. Same mole, that is self aldol. Here also 1 plus 1. This is one mole, again that one mole. This also, these two are called self aldol. How many self aldol? 2. How many cross aldol? 2. Total how many aldol product? 2 plus 2, 4. When 4 products will get it you? Different types of aldehyde, different types of ketone, either one aldehyde or one ketone is different. Both are having the alpha hydrogen. That time total number of products are 4. What are those? 2 self aldol and 2 crossed aldol. Different types of aldehyde or ketone undergo aldol reaction, that is called what you call crossed aldol. Same molecule of aldehydes or ketone undergo aldol reaction, that is called self aldol. So, one of the time they ask the question is this one only now. Ethanol, propanol undergo aldol reaction, otherwise dilute NaOH. Total how many number of products are aldol products are possible? Option different option they are given. One of the option is 4. So, answer is 4 only. At the time now. Okay, ma. Remaining concept I will discuss. One named reaction is there. One is Canniger reaction. Second one is HVZ reaction, named reaction. Later acidification is there. Tomorrow I will discuss. Okay. Thank you.
Good morning, everyone. Welcome back. Yesterday, we have learnt about excretory products and elimination chapter salient features in detail. So today, we are going to discuss about skeletal system. Skeletal system. Dear students, human skeletal system includes 206 bones. Human skeletal system includes 206 bones and few cartilages. Got it? Bones and cartilages both constitute a skeletal system. Human skeletal system is composed of 206 bones and a few cartilages. Dear students, the matrix of bone, the matrix of bone is hard. Matrix of bone is hard and non-pliable. Non-pliable means non-flexible. Non-pliable or non-flexible. The matrix of bone is hard and non-pliable or non-flexible because the matrix of bone contains calcium salts. The matrix of bone contains calcium salts and strong collagen fibers. The matrix of bone contains calcium salts and strong collagen fibers. Here, calcium salts and strong collagen fibers provide hard and non-pliable or non-flexible nature to the matrix of bone. Understood? The matrix of bone is hard and non-pliable or non-flexible because the matrix of bone contains calcium salts and strong collagen fibers. Both calcium salts and strong collagen fibers provide hard and non-pliable or non-flexible nature to the matrix of bone. At the same time, the matrix of cartilage, the matrix of cartilage is soft and pliable. Pliable means flexible. The matrix of cartilage is soft and pliable or flexible because the matrix of cartilage contains chondroitin salts. The matrix of cartilage contains chondroitin salts and delicate collagen fibers. Delicate collagen fibers. Here both chondroitin salts and delicate collagen fibers provide soft and pliable or flexible nature to the matrix of cartilage. Just you people have to enumerate the difference between both matrix of bone and matrix of cartilage. So once recapitulate what we have learnt. Human skeletal system is composed of 206 bones and few cartilages. Matrix of bone is hard and non-pliable or non-flexible because the matrix of bone contains calcium salts and strong collagen fibers. Both calcium salts and strong collagen fibers provide hard and non-pliable or non-flexible nature to the matrix of bone. At the same time, the matrix of cartilage is soft and pliable or flexible because the matrix of cartilage contains chondroitin salts and delicate collagen fibers. Both chondroitin salts and delicate collagen fibers provide soft and pliable or flexible nature to the matrix of cartilage. We can see strong collagen fibers in the matrix of bone. We can see delicate collagen fibers in the matrix of cartilage. We can see calcium salts in the matrix of bone. We can see chondroitin salts in the matrix of cartilage. Got it? Okay? Just focus on matrix of bone and matrix of cartilage. I hope you people have understood this. So discuss individually. First bones. Later we will discuss regarding cartilages. So human skeletal system includes 206 bones and few cartilages. Here 206 bones. Just a minute. 206 bones and few cartilages constitute skeletal system. 206 bones are arranged in two categories. 206 bones are arranged in two categories. Category number 1, axial skeleton. Axial skeleton. Category number 2, appendicular skeleton. Appendicular skeleton. 206 bones are arranged in two sets or two categories. Category number 1, axial skeleton. Category number 2, appendicular skeleton. Here, axial skeleton includes 80 bones. Axial skeleton includes 80 bones. And appendicular skeleton includes 126 bones. Total number of bones in axial skeleton 80. And the total number of bones in appendicular skeleton 126. So 126 and 80 both come under skeletal system. Total number of bones in axial skeleton 80 and total number of bones in appendicular skeleton 126. So we will discuss individually. First one, axial skeleton. Total number of bones in axial skeleton 80. Dear students, 80 bones of axial skeleton, 80 bones of axial skeleton are arranged in 6 categories. 80 bones of axial skeleton are arranged in 6 categories. Category number 1, skull bones. Skull bones. Total number of skull bones 22. Total number of skull bones 22. And the next one, hide bone. Number of hide bones 1. And the next one, ear ossicles. Total number of ear ossicles 6. Ossicles andre bones. Ear ossicles are located in the middle ear of each ear. In the middle ear of left ear, 3 ear ossicles are present. And in the middle ear of right ear, 3 ear ossicles are present. 3 plus 3, 6 ear ossicles. And the next one, bones of vertebral column. Bones of vertebral column. Total number of bones in vertebral column 26. Those bones, the bones which are situated in vertebral column are scientifically called vertebrae. We will discuss regarding that later. Vertebral column is composed of 26 bones. And the next one, sternum. Sternum is otherwise known as breastbone. Total number of sternum or breastbones 1. And the next one, ribs. Total number of ribs 12 pairs or 24. All these come under axial skeleton. Don't confuse, my dear students. 206 bones are arranged in 2 categories. Number 1, axial skeleton. Second one, appendicular skeleton. Total number of bones in axial skeleton 80. Very clear. And total number of bones in appendicular skeleton 126. 80 bones of axial skeleton. 80 bones of axial skeleton are arranged in 6 categories. Namely, number 1, skull bones. Second one, hide bone. Third one, ear ossicles. Fourth one, bones of vertebral column or vertebrae of vertebral column. Fifth one, sternum or breastbone. And last one, ribs. Total number of skull bones 22. Number of hide bones 1. Number of ear ossicles 6. Number of bones or number of vertebrae of vertebral column 26. Number of sternum or breastbones 1. Number of ribs 12 pairs or 24. My dear students, according to new NCERT textbook or according to updated 2025-26 academic year textbook, hide bone and ear ossicles both do not come under skull. Understood? Hide bone and ear ossicles both do not come under skull. So we should write hide bone, ear ossicles and skull bones individually. According to new NCERT book, hide bone and ear ossicles both do not come under skull. Okay? Just keep focus on this classification, everyone. Later we will discuss skull bones individually. Just you have 1 minute time to focus here to analyze this. Very simple. Skull bones 22, hide bones 1, ear ossicles 6, and bones of vertebral column 26. Sternum or breastbones 1, and a number of ribs 12 pairs are 24. Right. See, first one, skull bones. Number of skull bones 22 are bones of skull. 22 skull bones are arranged in 2 categories. 22 skull bones are arranged in 2 categories. Number 1, bones of cranium. Bones of cranium are cranial bones. Bones of cranium are cranial bones. And next one, bones of face are facial bones. Clear? 22 skull bones are arranged in two sets or two categories. Number one, bones of cranium are cranial bones. Second one, bones of face are facial bones. Number of cranial bones, 8. Number of cranial bones, 8. And number of facial bones, 14. Number of cranial bones, 8. And number of facial bones, 14. Understood? So, 8 cranial bones are arranged in 5 to 6 categories. 8 cranial bones are arranged in 5 to 6 categories. Namely, number 1, frontal bone. Next, parietal bones. First one, frontal bone. Next, parietal bones. Next, temporal bones. Third one, temporal bones. Fourth one, occipital bone. Occipital bone. Next, fifth one, sphenoid bone. And last one, ethmoid bone. Okay? 8 cranial bones are arranged in 6 categories. Namely, number 1, frontal bone. Next, parietal bones. Next, temporal bones. Occipital bone. Sphenoid bone. And last one is a ethmoid bone. Dear students, number of frontal bones, 1. Number of parietal bones, 2. Number of temporal bones, 2. Number of occipital bone, 1. Number of sphenoid bones, 1. And number of ethmoid bones, 1. 2 plus 1, 3. 5, 6, 7, 8. Understood? Number of frontal bones, 1. Parietal bones, 2. Temporal bones, 2. Occipital bone, 1. Sphenoid bone, 1. And ethmoid bone, 1. So based on this we can conclude like frontal bone is unpaired. Frontal bone is unpaired. Parietal bones are paired. Parietal bones are paired. Again temporal bones are paired. Temporal bones are paired. And remaining occipital bone, sphenoid bone, ethmoid bone. All these are unpaired bones. Unpaired bones. Understood? Frontal bone, parietal bone and temporal bone. Both are paired. Remaining all are unpaired bones. Keep it in your mind. And one more important instruction. Number of sphenoid bones, 1. Sphenoid bone is the keystone bone of the cranium. Sphenoid bone is the keystone bone of the cranium. Already you know we have learned. ఎప్పుడైపోయింది సార్ నెట్ ఇప్పుడైనా లేకుంటే చాలాసేపు అవుతుందా ఎందుకంటే ఎక్కడ దాకా స్టాప్ చేసిందో Sorry for inconvenience, my dear students. Some technical issues have occurred. Right? So, once recapitulate what we have discussed. See, number of cranial bones 8. 8 cranial bones are arranged in 6 categories. Namely, number 1 frontal bone. Number of frontal bones 1. Next, parietal bones. Number of parietal bones 2. Temporal bones. Number of temporal bones 2. Next, occipital bone. Number of occipital bones 1. Number of sphenoid bones 1. And number of ethmoid bones 1. Here, frontal bone is unpaired. Parietal bones and temporal bones both are paired. Remaining occipital bone, sphenoid bone and ethmoid bone, these 3 are unpaired bones. Individually, sphenoid bone is considered as keystone bone of the cranium. All these 8 cranial bones form cranium. Cranium comes under skull, or cranium represents skull. Now, coming to the point, bones of face are facial bones. Number of facial bones are 14. 14 facial bones are arranged in 8 categories. 14 facial bones are arranged in 8 categories. Number 1, nasal bones. Number of nasal bones 2. Number of zygomatic bones 2. And third one, palatine bones. Number of palatine bones 2. And fourth one, lacrimal bones. Number of lacrimal bones are 2. Number of maxillae are 2. Number of conchae are 2. And number of vomer bones 1. Number of mandible bones 1. Here, conchae plural. Concha singular. Conchae are of 2 types, namely number 1, superior nasal concha, and second one is inferior nasal concha. Both superior nasal concha and inferior nasal concha both constitute conchae. So conclusion is, nasal bones, zygomatic bones, palatine bones, lacrimal bones, maxillae, conchae. All these are paired. Just vomer and mandible bones, both are unpaired. Both are unpaired. And one more, 14 facial bones form face, or 14 facial bones form front portion of the skull. 14 facial bones form front portion of the skull, nothing but face. Got it? Okay. So 22 skull bones are successfully completed. I hope you people have understood this. So everyone should remember 14 facial bones, number of nasal bones 2, zygomatic bones 2, palatine bones 2, lacrimal bones 2, maxillae 2, conchae 2, vomer 1, mandible 1. Nasal bones, zygomatic bones, palatine bones, lacrimal bones, maxillae and conchae are paired. Remaining vomer and mandible, both are unpaired. Okay. So according to given classification, skull bones successfully completed, or cranial bones and facial bones successfully completed, and next category, hide bone. See, next, hide bone. Number of hide bones 1. Number of hide bones 1. Here, hide bone comes under axial skeleton. Hide bone comes under axial skeleton. But hide bone does not come under skull. Understood? hide bone comes under axial skeleton, but hide bone does not come under skull. Hide bone is a U-shaped bone. Hide bone is U-shaped bone. Hide bone is located at the base of the buccal cavity. Hide bone is located at the base of the buccal cavity. Moreover, hide bone is unpaired. Hide bone is unpaired. These are the salient characteristic features of hide bone. Listen again. Number of hide bones 1. Hide bone comes under axial skeleton, but hide bone does not come under skull. And hide bone is U-shaped bone, and hide bone is located at the base of the buccal cavity. Understood? According to new NCERT 2025-26 academic year textbook, hide bone does not come under skull. Once go through 2025-26 updated NCERT textbook, you will get a clarity regarding this. As per given classification, next one, ear ossicles. Ear ossicles. Number of ear ossicles 6. Basically, ear ossicles are located in middle ear. Ear ossicles are located in middle ear. In the middle ear of left ear, 3 ear ossicles are present. In the middle ear of left ear, 3 ear ossicles are present. And in the middle ear of right ear, again 3 ear ossicles are present. 3 plus 3, 6. Ear ossicles are situated in each middle ear. Understood? In the middle ear of left ear, 3 ear ossicles, and in the middle ear of right ear, 3 ear ossicles are present. So 3 plus 3, total number of ear ossicles 6. Understood? Okay? So in each middle ear, 3 ear ossicles are present, namely number 1 malleus, second one incus, third one stapes. First one malleus, second one incus, third one stapes. Malleus is otherwise known as hammer bone. Malleus is otherwise known as hammer bone. Incus is otherwise known as anvil bone. Stapes is also known as stirrup bone. Understood? Malleus or hammer bone. Incus or anvil bone. Stapes or stirrup bone. Number of malleus 1. Number of incus 1. Number of stapes 1. I am talking about each middle ear. In each middle ear, number of malleus 1. In each middle ear, number of incus 1. In each middle ear, number of stapes 1. But if we focus on both the ears, total number of malleus 1 plus 1, 2. Total number of incus 1 plus 1, 2. Total number of stapes 1 plus 1, 2. 2, 2, 2, 6. Understood? Don't confuse. In the middle ear of left ear, 3 ear ossicles are present. And in the middle ear of right ear, 3 ear ossicles are present. 3 plus 3, total number of ear ossicles 6. In the middle ear of left ear, 1 malleus, 1 incus, 1 stapes are present. And in the middle ear of right ear, 1 malleus, 1 incus, 1 stapes are present. So if we focus on both the middle ears, total number of malleus 2, total number of incus 2, total number of stapes 2, 2 plus 2 plus 2, total number of ear ossicles 6. Here, stapes is the smallest bone in our body. Stapes is the smallest bone in our body. And one more important updation, my dear students. Again, according to updated 2025-26 new NCERT textbook, even ear ossicles do not come under skull. Ear ossicles do not come under skull. Final conclusion, hide bone and ear ossicles. Hide bone and ear ossicles do not come under skull. Understood? So once recapitulate what we have learnt. Number of hide bones, 1. It is unpaired. Hide bone comes under axial skeleton, but hide bone does not come under skull. And hide bone is U-shaped bone, and hide bone is located at the base of the buccal cavity. So in the middle ear of each ear, 3 ear ossicles are present. So 3 plus 3, 6. Namely, number 1, malleus or hammer bone, incus or anvil bone, stapes or stirrup bone. Total number of malleus bones in both the ears, 2. Total number of incus bones in both the middle ears, 2. Total number of stapes in both the middle ears, 2. So ultimate 6 ear ossicles are present. Ear stapes is the smallest bone in our body. Okay, na? Right. Only 3 bones, 3 categories representing axial skeleton are remained. Understood? Skull bones, individually cranial bones and facial bones successfully completed. Understood? And next one, hide bone completed. Ear ossicles successfully completed. Hide bone and ear ossicles both do not come under skull. Keep it in your mind. Thank you. Right. Next. Bones of vertebral column. Bones of vertebral column, dear students. Vertebral column includes 26 bones. Vertebral column includes 26 bones. The bones which are present in vertebral column are scientifically called vertebrae. Understood? Our vertebral column includes 26 bones. The bones which are embedded in vertebral column are scientifically called vertebrae. Here vertebrae plural, vertebra singular. Vertebrae plural, vertebra singular. Understood? See, 26 vertebrae or 26 bones of vertebral column or 26 vertebrae of vertebral column are arranged in 5 categories. 26 bones or 26 vertebrae of vertebral column are arranged in 5 categories, namely number 1, cervical vertebrae. First one, cervical vertebrae. Next, thoracic vertebrae. Thoracic vertebrae. Next, lumbar vertebrae. Lumbar vertebrae. And next one, sacrum. And next one, coccyx. Got it? 26 vertebrae of vertebral column are arranged in 5 categories, namely number 1, cervical vertebrae. second one thoracic vertebrae, third one lumbar vertebrae, fourth one sacrum, and fifth one is coccyx. My dear students, in most of the mammals, including human beings, number of cervical vertebrae are 7. Understood? In most of the mammals, including human beings, total number of cervical vertebrae are 7. Understood? So, 7 cervical vertebrae are represented as C1, C2. C1 represents cervical vertebra 1. C2 represents cervical vertebra 2. C3 represents cervical vertebra 3. C4 represents cervical vertebra 4. C5 represents cervical vertebra 5. C6 represents cervical vertebra 6. C7 represents cervical vertebra 7. Understood? Total number of cervical vertebrae 7. It is represented as C1, C2, C3, C4, C5, C6 and C7. Dear students, here C1 represents cervical vertebra 1. C1 represents cervical vertebra 1. Cervical vertebra 1 is scientifically called atlas. Cervical vertebra 1 or C1 is scientifically considered as atlas. Atlas is also known as superior portion of vertebral column. Superior portion of vertebral column. And C2 represents cervical vertebra 2. Cervical vertebra 2 is scientifically called axis. Cervical vertebra 2 is scientifically called axis. See, C1 represents cervical vertebra 1. Cervical vertebra 1 is scientifically called atlas. Atlas is also known as superior portion of vertebral column. Cervical vertebra 2 is scientifically called axis. Understood? Right? See, dear students, this is skull and this is cervical vertebra 1 or atlas or superior portion of vertebral column. What I am saying is, skull is connected to atlas. Skull is connected to atlas, or skull is connected to cervical vertebra 1. Skull is connected to atlas, or skull is connected to superior portion of vertebral column through a pair of openings. Through a pair of openings. These two openings are scientifically called occipital condyles. Occipital condyles. Skull is connected to C1, or skull is connected to atlas, or skull is connected to superior portion of vertebral column through a pair of occipital condyles. Occipital condyle 1, occipital condyle 2. Total number of occipital condyles 2. These two occipital condyles are located adjacent to the skull. Two occipital condyles are situated very close proximity to the skull. Due to this reason, human skull is commonly considered as dicondylic skull. Dicondylic skull. Understood? In most of the mammals, including human beings, total number of cervical vertebrae 7. It is represented as C1, C2, C3, C4, C5, C6 and C7. C1 represents cervical vertebra 1 or atlas or superior portion of vertebral column. C2 represents cervical vertebra 2 or axis. Skull is connected to C1 or skull is connected to atlas or skull is connected to superior portion of vertebral column through two occipital condyles. These two occipital condyles are located very close to the skull. That is why human skull is commonly considered as dicondylic skull. Dicondylic skull. Okay, na? Right, Amma. Next one, don't confuse. Cervical vertebra 1 is atlas or superior portion of vertebral column, and cervical vertebra 2 is axis. Understood? Skull is connected to atlas or skull is connected to superior portion of vertebral column, or skull is connected to cervical vertebra 1 through occipital condyles. Number of occipital condyles 2. Two occipital condyles are located close to the skull. That is why human skull is commonly considered as dicondylic skull. Clear? And next, thoracic vertebrae. Number of thoracic vertebrae are 12. Number of thoracic vertebrae are 12. Represented as T1, T2, T3, T4. Andre, T1 means thoracic vertebra 1, T2. Thoracic vertebra 2, T3, thoracic vertebra 3, T4, thoracic vertebra 4, T5, thoracic vertebra 5, T6, thoracic vertebra 6, T7, thoracic vertebra 7, T8, thoracic vertebra 8, T9, thoracic vertebra 9, T10, thoracic vertebra 10, T11, thoracic vertebra 11, T12, thoracic vertebra 12. And next one, lumbar vertebrae. Total number of lumbar vertebrae 5, and it is represented as L1. L1 andre lumbar vertebra 1, L2 lumbar vertebra 2, L3 lumbar vertebra 3, L4 lumbar vertebra 4, L5 lumbar vertebra 5. Understood? Number of thoracic vertebrae 12, represented as T1, T2, T3, T4 up to T12. Number of lumbar vertebrae 5, represented as L1, L2, L3, L4 and L5. And next one, sacrum. Number of sacrum 1, or number of sacral bones 1. Understood? See, it is represented as S1. Represented as S1. My dear students, during embryonic development, 5 sacral vertebrae, during embryonic development, 5 sacral vertebrae fuse together to form sacrum. During embryonic development, 5 sacral vertebrae fuse together to form one sacrum. That is why sacrum is considered as fused vertebra. Fused vertebra. During embryonic development, 5 sacral vertebrae fuse together to form sacrum, one sacrum. That is why sacrum is said to be fused vertebra. And next one, coccyx. Number of coccyx bones 1. It is represented as CO1. Represented as CO1. Dear students, during embryonic development, 4 coccygeal vertebrae fuse together to form one coccyx. During embryonic development, 4 coccygeal vertebrae fuse together to form one coccyx. That is why coccyx is said to be fused vertebra. Final conclusion, total number of fused vertebrae 2, namely number 1 sacrum and second one coccyx. During embryonic development, 5 sacral vertebrae fuse together to form sacrum, hence the name fused vertebra. And during embryonic development, 4 coccygeal vertebrae fuse together to form one coccyx, hence the name fused vertebra. Understood? And ultimate formula of vertebrae of vertebral column are C7, T12. C7 andre number of cervical vertebrae 7, T12 number of thoracic vertebrae 12. Individual formula and main formula both are different aspects. Here C7 represents number of cervical vertebrae 7, T12 represents number of thoracic vertebrae 12, and comma L5 means number of lumbar vertebrae 5, and next one S1 means number of sacrum 1, and next one CO1 means number of coccyx 1. C7, T12, L5, S1, CO1. Understood? And moreover, my dear students, vertebral column supports head. Vertebral column supports head. And vertebral column protects spinal cord. Vertebral column supports head and vertebral column protects spinal cord. And vertebral column provides space for the attachment of ribs and back muscles. Vertebral column provides space for the attachment of ribs and back muscles. Keep it in your mind. Vertebral column supports head and vertebral column protects spinal cord, and vertebral column provides space for the attachment of ribs and back muscles. Back muscles. Understood? Next. And one more important instruction. In the middle of each vertebra, central canal or neural canal is present. In the middle of each vertebra, central canal or neural canal is present. Through central canal or through neural canal, spinal cord extends. Spinal cord travels or spinal cord extends. Understood? In the middle of each vertebra, in the middle of each vertebra, central canal or neural canal is present. Through central canal or through neural canal, spinal cord extends. Spinal cord extends. And vertebral column supports head. Vertebral column protects spinal cord. And vertebral column provides space for the attachment of ribs and back muscles. And in the middle of each vertebra, central canal or neural canal is present. Through central canal or through neural canal, spinal cord extends. Understood? Everyone should remember. And one more additional point. Between two adjacent vertebrae, intervertebral disc is present. Between two adjacent vertebrae, cartilage is present called intervertebral disc. Understood? And neat previous year question. In the middle of each vertebra, central canal or neural canal is present. Through central canal or through neural canal, spinal cord extends. And vertebral column supports head. Vertebral column protects the spinal cord. Vertebral column provides space for the attachment of ribs and back muscles. Okay? And between two adjacent vertebrae, cartilaginous intervertebral disc is present. As per given classification, vertebral column successfully completed, and next one sternum. number of fused vertebrae too, namely sacrum and coccyx. Okay. Next one, sternum. Number of sternal bones 1 means it is unpaired. Sternum is otherwise known as breastbone. Number of sternal bones 1. So sternum is unpaired. Sternum is also known as breastbone. Sternum comes under axial skeleton. Sternum comes under axial skeleton. Sternum is a flat bone. Sternum is a flat bone. Sternum is located on ventral midline of thorax. Sternum is located on ventral midline of thorax. Number of sternal bones 1. Hence it is unpaired. Sternum is otherwise known as breastbone. Sternum comes under axial skeleton. Sternum is a flat bone. And sternum is located on ventral midline of thorax. To be continued, my dear students. Thank you for your kind cooperation. Tomorrow we will discuss regarding ribs and rest of the bones of appendicular skeleton and bones and disorders of skeletal system. Thank you.
Good morning students. So yesterday we have started the new chapter, the fresh one, cell cycle and cell division part. Yesterday we have given the introduction related to this cell cycle, cell division. Today we are going to the deeper parts of it. First, let me complete the introductory discussion related to this cell cycle. See, cell cycle is a cyclic process. Cell undergo in its lifetime during this particular way, there are two particular phases in this entire cell cycle. The main phase is going to be the interphase and the secondary phase is going to be the M phase. See, this interphase occupies 95% of duration of the cell cycle, remaining less than 5% is occupied by the M phase. This interphase generally many people consider it as a resting phase, but actually this is a preparatory phase. So, the division, actual cell division happening within the M phase. For the division to happen, so much of preparations are required. Yesterday I told you, first cell undergo growth, I mean by increase in the amount of protoplasm and DNA replication, then only it is going to enter into divisional phase. So, for the cell to enter into divisional phase, it needs the preparation. The preparation going to happen within the interphase, so that this can be considered as a preparatory phase. Then why the name arises as resting phase? Because cell apparently not dividing in this particular region, not showing any division. Cell looks like that, it is not going to divide, but inside the cell there are many changes happening, that is why it is called as a resting phase, or actual correct name is going to be the preparatory phase. This preparatory or interphase will be divided into three subphases. One is going to be the G1, another one is S, another one is G2. Here G means gap phase. This is gap phase 1, gap phase 2, in the middle S phase. S means here synthesis. Why we are considering it as a gap phase? Actually the cell division is happening here. This is the ending of cell division, this is the starting of cell division. Between end to start of the cell division, whatever phase is there, that is called inter. Inter means between. In this the gap phases are there, G1, G2 and S. So, in this G1 phase, what is going on? Cell during the cell cycle undergo a process continuously, that is called cell growth. So, remember, cell growth is a process occurring in all phases of the cell cycle. It is a continuous process. Next, there is one particular point we have to remember here, which is related to the G1 phase. This particular point is not mentioned in the textbook statements, but can be found at the end of the chapter in the summary. What is that? Majority of the cell organelles. Majority of cell organelles are divided, are synthesized, are divided during this particular phase. This is the phase where majority of the cell organelles are produced. And whatever required for the DNA replication which is happening here are going to synthesize here. I mean by ATP, nucleotides, proteins, another enzymes, whatever required. All the requirements for the DNA replication which is happening in the S phase will be synthesized in the G1 phase. Next, there is a positional point here, where is the location of the G1 phase? So, G1 phase occurs between end of the cell division to initiation of DNA replication. Textbook statement, end of cell phase 1, cell after doing the preparation for the DNA replication, it is entering into the replicatory part, that is S phase. So, during this S phase, what is happening? Two particular things are going on. One is DNA replication, another one is duplication of the centrioles. Centriole duplication going to happen. So, this DNA replication happens within the nucleus, the centriole duplication occurs within the cytoplasm, and everyone has to remember one thing, this centriole duplication occurs only in the animal cells. In the plant cells, there is no such organelle called as centrosome or the centriole. This is exclusively found in the animal cells. That too, the division of the centriole happens within the S phase, that too in the cytoplasm. In the nucleus of any kind of cell, DNA replication going to happen during the S phase. So that, for example, let me take the DNA at the G1 phase. If the cell is 2n condition, two sets of chromosomes are there, amount of DNA is 2C. Generally DNA measures in picograms, Pg. For example, we are considering a variable 2C. At the end of the S phase, amount of DNA will be doubled. So 2C will become 4C. but number of chromosomes will be same, 2n. How this is possible? For our understanding, let we assume here 2n is equals to 2 sets of chromosomes. This is one chromosome, this is another chromosome. Assume this represents one set, this is another set. So 2 sets of chromosomes are there, we can consider it as a 2n. At the end of the S phase, same 2 sets of chromosomes are there. What changes? Amount of DNA changes, so that one chromatid containing chromosome will be replicated, become the 2 chromatids containing chromosome. I mean by each chromatid is doubled. We call them as sister chromatids. Generally, I am saying here itself, my interphase chromosomes are not visible, chromatin is there. For our understanding, we are considering it as like this. So, number of chromosomes will be same, but amount of DNA will be doubled during the S phase. Next, G2 phase. So, G2 phase is a preparatory phase for the division. Whatever the requirements of the division will be synthesized in the G2 phase. Many proteins are there. Simply as per our textbook is concerned, so proteins like tubulin is going to synthesize during the G2 phase. And the cell growth is a continuous process going on here itself. Another whatever enzymes are required, another proteins are required for the cell division, those are all will be synthesized in the G2 phase. So, the presence of G2 phase is between initiation of the mitosis or division and ending of the DNA replication. So, these are the 3 phases of the interphase where cell is showing cell growth, synthesizing in the constituents required for the M phase and DNA replication along with central duplication going to happen. Next, before entering into the divisional phase, there is another auxiliary phase is there, we can call it as a G0 phase. So, what is this G0 phase? G0 phase is actually inactive phase. The cells which are going to go out of the cell division. So, how we can connect this with related to plant growth and development chapter I told, after the cell growth either cell may continue to divide and remain it as a meristematic cell. But there are some cells loses the capacity to division and become the permanent cells. So, the cells which are going to lose the capacity to division, they will exit from this particular cycle and enter into a inactive phase. That inactive phase is called as the G0 phase. So, here everyone must and should has to remember G0 phase is metabolically active. Cell is living, metabolic activities are going on, everything was fine, but cell is not going to show any division. So, it is inactive for cell division, but active for metabolic activities. And then here these G0 phase, whatever cells are there, for example in the human cells, heart cells are there, nerve cells are there, once they form they can't going to be divided. But sometimes like our skin cells, in the plants there are some de-differentiated cells. Those cells, when there is a need, suppose body got an injury, need to replace the cells with the new cells. The permanent cells which are entered into the G0 phase, again they is coming back and enter into the G1 phase. So, the cells are going out of the cell cycle from the G1, entering into G0, again they are coming back into the cell cycle from the G1 itself, because this is a preparation for this, directly they cannot enter here. So, that is the logic. So, G0 phase is an inactive phase, we can call it as a quiescent phase for the cell division, but the cell is metabolically active. Some cells are temporarily going out, we can call them as a suspending the cell cycle, and some other cells are going to be permanently going out, we can call them as exiting the cell cycle. The cells which are permanently exiting, those are called as our nerve cells. Even in the heart cells, we can take the examples. In the plants, many cells are there, like our sclerenchyma cells. Once they came out of the cell cycle, they won't enter because they are dead cells. Dead cells, we can call the process as a differentiation process. Once differentiated, they are again entering into the cell cycle, we can consider it as a de-differentiation, reversal of the differentiation, which are going to form secondary meristematic cells. So, that is the logic here. Next. So, G0 to Z1, yes, G2, again they are entering into the M phase. But this M phase is considered as a cell division proper cell division going to happen within the cell cycle in case of the M phase. And this M phase, the M means here mitosis, generally we can consider it as a meiosis also, divisional phase. And it is a most dramatic phase of the cell cycle. Why it is called as most dramatic phase? Means this is the cycle, this is a step of the cycle where cell organelles will disappear at the starting, reappear at the ending. So, reorganization we call it. So, major reorganization of the cell organelles, textbook word, reorganization means they are organizing themselves again at the end of the cell cycle. So, initially they will disappear and again they are going to reappear. That is why it is called as, what do you say, most dramatic phase of the cell cycle. Next. This M phase will be divided into two parts. One is going to be the karyokinesis, that is going to be the division of the nucleus. Another one is a cytokinesis, which explains the division of the cytoplasm, and eventually cell divides into two. This karyokinesis is actually a progressive process, textbook word. Progressive process means it is a continuous process, there is no breaks in it. But for our understanding, we are dividing the karyokinesis into four different phases: prophase, metaphase, anaphase and telophase. So formula here is a PMAT. PMAT. Prophase, metaphase, anaphase and telophase. So this is a sequence. Again I am saying it is a progressive process, continuous process, cannot be divided into small steps, but still for our convenience we are dividing into four small steps. These are the part of the karyokinesis. And after telophase, cell is entering into the karyokinesis. By the end of the karyokinesis, suppose one cell is entered here, by undergoing many processes, it will be divided into two, as I am considering mitosis here. If I consider meiosis, 4 cells will be formed, and this is the direction of the cell cycle. Direction of the cell cycle. G1, S, G2, prophase, metaphase, anaphase, telophase, and finally it is going to be karyokinesis. So this is the logic. Then, after saying this, there are some points everyone has to remember, no need to much worry about them. Mitosis we are going to start. Mitosis happens in both plant cells and also animal cells. But mitosis in the plant cells can undergo both in diploid cells and also haploid cells. In plants, I am repeating, mitosis can happen in both haploid and also diploid cells, whereas in case of the animal cells, majorly diploid cells are undergoing mitosis. But there is one exception for this, that is a male honeybee, we have discussed in human genetics part. So in the male honeybees, it is going to produce the gametes by the help of the mitosis, because male honeybee itself is a haploid structure, 16 number of chromosomes are there. So male honeybee is the exception for this rule. What is the rule? Mitosis in the animal cells occurring in diploid, that too in the somatic cells, non-reproductive cells. So mitosis in animal cells occurring in diploid somatic cells, but still there is an exception. The exception is going to be the male honeybees, which are producing the gametes with the help of mitosis. So remember it, let we enter into the process of the cell division. We are going to start first mitosis. This mitosis is considered as an equational division. Why it is called equational? Because number of chromosomes will be same in the parent and also progeny cells. Suppose in my skin cell, a damage happened. My skin cells are there in our G0 phase now. A damage happened. After the damage, cell repair going to start. New cells are going to form. During the formation of the new cells, whatever chromosome number is there in my body, same chromosome number will be there in the newly formed cells. So parent and progeny will have same number of cells. That's why it is called as a equational division. Now, after saying this, let me discuss one by one points. First one is the prophase. So in the prophase, what is happening? First step is a condensation of the chromosomal material. Condensation of the chromosomal material, I mean by chromatin. So in this G1, S and G2, I already told you, DNA present in the form of chromatin. During the karyokinesis, that in the first step of the karyokinesis prophase, chromatin will be condensed into form of chromosomes. This process is called as a condensation. Chromatin will be reduced into a particular structure, that is called as a chromosome. Formation of the chromosome from the chromatin, we can call it as a condensation. Condensation is happening in the prophase. So that how can we explain this? This is a cell which is there at the, suppose I am taking first a cell in the interface, G1, S and G2. This is the nuclear envelope. In this nuclear envelope, the DNA present in the form of a long thread, we can consider it as a chromosome, chromatin. Now, during the prophase, what is happening? Early prophase, nuclear envelope inside, within the nuclear envelope, the chromosomes are just started going to appear. So, if the question comes, during which phase chromosome starts appear under the microscope, that is a prophase. If that is a reason, that is assertion, reason will be condensation is started. I didn't say completed, I am saying it is a started in case of the prophase. And the centrioles which are already duplicated during the S phase, centrioles which are already duplicated during the S phase, in the animal cell I am talking about within the cytoplasm, they started moving towards the opposite poles. They started their journey moving towards the opposite poles. This is happening in case of the early prophase. I am repeating, condensation started, centrioles started moving to opposite poles. Now, by the end of the prophase, what is the scenario? End of the prophase, the centrioles have reached the opposite poles by the end of the prophase and they form two kinds of structures. One are called as astids. These astids helps to binding of the centrioles towards the plasma membrane. Next, astids here also, and they are long thread like structures are there, hanging structure, those are called as spindle fibers. Spindle fibers. So these astids along with the spindle fibers, we can consider it as a mitotic apparatus. Mitotic apparatus. What does this mitotic apparatus contains? Two astids along with the spindle fibers. So astids of both poles and spindle fibers, consider it as a mitotic apparatus. And now in the middle what is going to happen? Chromosome condensation going on one side. It is a continuous process in the prophase, going on, step by step it is moving ahead. But by the end of the prophase, this is a late prophase, by the end of the prophase, nuclear envelope starts disappearing. Nuclear envelope stops disappearing. It is going to disappear slowly. And in the cytoplasm what is happening? Endoplasmic reticulum, Golgi apparatus, and within the nucleus nucleolus, nuclear envelope. Here Golgi, nucleolus and nuclear envelope starts disappearing one by one. So that by the end of the prophase, chromosomes are ready to enter into the cytoplasm. That is the thing. So you can ask me why they are only ER and Golgi apparatus are getting disappeared. They are the structures occupied majority of the space of the cell. So for the movement of the chromosome, space is required, that's why they are getting disappeared. They will reappear at the end. I told you this is the most dramatic phase. Cell organelles will disappear, again reappear at the end. So what are the cell organelles? ER, Golgi apparatus, nuclear envelope and nucleolus will be disappeared by the end of the prophase, that is a late prophase. Next, after the prophase, cell is entering into the next phase, that phase is going to be called as a metaphase. So during this metaphase, here also I am considering early metaphase and late metaphase. In the early metaphase, what is the scenario? Cell inside, nuclear envelope completely disintegrated and chromosomes are now freely floating in the cytoplasm. They are released into cytoplasm. Now, these spindle fibers from the opposite poles, let me draw it like this. Spindle fibers from the opposite poles they will arise and attach to the centromere. They will arise and attach to the centromere. So what can we say? Spindle fibers of the opposite poles are arised from this centrioles and they are attaching to the centromere. So observe here, in a mitotic chromosome, this is a chromosome which is formed. This is arm, both are considered as a chromatid. This is one chromatid. The point that is holding these two chromatids is going to be the primary constriction. The primary constriction here called as a centromere. So surrounding to the centromere, two disc-shaped structures are there. Those are called as a kinetochores. So centromere is a primary constriction. The disc-shaped structures present around the centromere is going to be called as a kinetochores. These kinetochores acts as a sites of attachment of the spindle fibers. Now observe here, the spindle fibers from the opposite poles, this is one pole and I am drawing here another pole, they are attached to kinetochores of centromere. So this is the first step. So this nuclear envelope completely disintegrated, chromosomes are released into the cytoplasm. After that, spindle fibers from the opposite poles attached to the sister chromatids at the point called as centromere having a disc, say a kinetochore. Now these chromosomes started aligning at the equator. Chromosomes started aligning at the equator. The alignment of chromosomes at the middle or the equatorial plate is called as metaphase plate. The chromosomes align at the equator going to be considered as metaphase plate. Metaphase plate. So this is the situation. And one more thing, metaphase is the best phase to study the morphology of the chromosomes. Why? By the time metaphase was started, chromosome condensation was completed. Here everyone has to remember, prophase is a place where condensation started, and metaphase is a place where condensation of the chromosomal material was completed. So best phase to study the morphology of the chromosome is metaphase. If that is assertion, reason will be condensation completed. Now chromosomes released, attachment of spindle fibers, and they are aligning at the equator. We can call it as a metaphase split. After that, the next phase is going to be called as a telophase. Not the telophase, actually it is anaphase. So anaphase is a phase where splitting of centromere will happen. Let me draw it. This is the cell. Here is going to be the centromeres, which are already there. These centromeres are attached to the plasma membrane by means of asters, and now the spindle fibers are attached to kinetochores of sister chromatids. During this anaphase, what is happening? Splitting of centromere. How can we understand this? Suppose this is an arm, this is an arm, this is the centromere. Imagine it as like that. This is another arm, this is another arm, total centromere. Total, what is a chromatid? The two chromatids are attached at the centromere. Now what is going to happen? From here, these removed, pulled. From here it is pulled. The two sister chromatids are pulled by the spindle fibers from opposite poles, so that this will be detached from the centromere. This will move to the one pole, this will move to opposite pole. So what is happening? Splitting of centromere is happening. Splitting of centromere is happening during the anaphase. You can observe here that sister chromatids are which are attached here, they are separated due to splitting of the centromere. After separation, very carefully how to catch this point, after splitting of centromere, here one centromere is there, here one centromere is there. Previously these two are considered here as a sister chromatids. After separation, each separated chromatid should be considered as a chromosome. We call it as a daughter chromosome. So after separation, each separated chromatid is considered as a chromosome. We can call it as a daughter chromosome. And why I am saying this much stressing is, there is a statement saying that number of chromosomes will be increased during the anaphase. I am repeating, number of chromosomes will be increased during the anaphase. How come? Because there is no multiplication here. Just whatever chromosomes are there having sister chromatids, the sister chromatids are separated, so that each separated sister chromatid is considered as a daughter chromosome. So that here, for example, here I have drawn 2 chromosomes, there they have been formed 4 chromosomes. Number will be doubled during the anaphase due to splitting of centromere. After this separation, length of the centromere slowly decreases. Length of the centromere slowly decreases. So that, not the centromere, sorry. Length of the spindle fiber will be decreased slowly. So that because of the length here is decreasing, this centromere attached this sister chromatid will be pulled towards this pole, its sister chromatids will be pulled towards this pole. So that what will happen? The two sister chromatids first separate, this will move to one pole, this will move to opposite pole. The logic here, while they are moving towards one pole, suppose this is the separated sister chromatid, here is going to be centromere, disc shaped structure kinetochore. Spindle fiber is attaching to this kinetochore and it is pulling the chromosome towards one pole. While it is pulling, it won't go like a rigid rod-like structure. How it goes? The pulling force is acted on the centromere. So that centromere is the leading edge. Centromere is the leading edge. Arms are trailing behind. Actually, it is a structure, spindle fiber attached. It is pulling like that, and arm is trailing behind. It is a trailing behind, but the leading edge is going to be the centromere. So observe here. Length is decreased, while it is pulling, centromere is going to be the leading edge because a force is acting on this and the arms are trailing behind like this. So this is happening during the anaphase. So during the early anaphase, what is happening? Splitting of centromere, separation of the sister chromatids, and they started moving towards opposite poles. At the late prophase, what is happening? While they are moving towards opposite poles, leading edge is a centromere and arms are trailing behind. By the end of the anaphase, these are reached to the opposite poles. So one set is going up, another set is going down. And finally, we are entering into the last phase, that is the telophase. That is the telophase. It is a terminal phase and we can consider it as a telophase. So what is happening in the telophase? Going to exactly opposite to the prophase. So what has happened in the prophase? Exact opposite will happen in telophase. So by the end of the anaphase, the sister chromatids have reached the opposite poles. At this point, here what happened? Condensation. Here what is going to happen? Decondensation. Means what? Here chromatin to chromosome happened. Decondensation is chromosome will lose its structure, ultimately it will become the structure of a chromatin. Chromatin structure will be formed at each pole. Chromatin structure is formed at each pole. So that here there is a beautiful point, chromosome loses their identity. During which phase? Telophase. Chromosomes gains their identity in prophase. Gaining the identity means they are getting the structure as a chromosome in case of the prophase. They are losing their individuality or losing their identity in case of what? Telophase. So here condensation in the prophase, here decondensation in the telophase. And in this telophase, whatever organelles lost has disappeared in the prophase, they will reappear. So during the reappearance process, nuclear envelope will be reappeared. Nuclear envelope will be reappeared, endoplasmic reticulum, Golgi apparatus and nucleolus, everything will be reappeared. So in this, if you observe, within one cell, two nucleus are there. Now the cell completed the karyokinesis. Condensation, alignment at the equator, separation and moving to opposite poles, it is decondensation, reformation of the cell organelles what have lost. Now finally cell is entering into the cytokinesis. But this cytokinesis is going to happen in two ways. In the plant cells it is different, in the animal cell it is going to be different. Why? Because how come the difference? Because of presence of cell wall. So cell wall is absent in the animal cells and present in the plant cells. So first let me complete it in the animal cell. In the animal cell, how the cell is going to be? There is a formation of a cleavage furrow, a small depression in the cell. This is called as a cleavage furrow. This cleavage furrow separates the two nucleus which are present in the opposite poles, which are already formed in the telophase. This cleavage furrow gradually deepens, divides the cell into two. So this is called as a centripetal division. Centripetal division. What do you mean by centripetal division? The force is acting towards the center. So cleavage furrow is started at the periphery and it is depressed, formed and meet at the center, dividing the two cells. One nucleus here, another nucleus here. So that is going to happen in case of the animal cells. So in animal cells, form of cell, cytokinesis is because of cell furrow. And this one is going to be called as a centripetal division. This word is not there in the textbook, competitive examination purpose I am saying here. And then in the plant cell, such kind of furrow is not there because plant cell is not flexible. They are having a rigid cell wall which is not going to be flexible like this. Because of inextensible cell wall, it is not going to extend. The process of cytokinesis is different in case of the plant cell. How come? First, in this plant cell, after telophase what was completed, two kinds of nucleus are there. One is above, another one is below. Two nucleus are there. The cell division not going to occur at the periphery. The cell division will be started in the middle. In the middle, what is going to form? The Golgi apparatus forms some vesicles here. Golgi apparatus releases some vesicles. These vesicles are accumulated at the center. We call this is going to form a structure called as a cell plate. This cell plate is formed by Golgi bodies and the cell plate extends towards periphery. and will extend towards periphery. It will be extended and reaches the periphery. After reaching that, the cell will be divided into two. Cell will be divided into two, that contains the chromatin within the nucleus. So, because of this cell plate, the division is happening. Why this kind of cell furrow method is not applicable to the plant cells? Because in the plant cells there is an inextensible cell wall. It is not going to depress like this. So, the cell division is going to happen in the middle. This is formed by Golgi apparatus. This structure is going to be called as a cell plate. Cell plate is extended towards the periphery and eventually dividing the cells into two. So, this cell plate having two important things. This cell plate going to be acts as a precursor of cell wall. It is going to be act as a precursor. Initial material that is going to form the cell wall in between these two cells is the cell plate. After formation, this is going to represent the middle lamella. Middle lamella. What is this middle lamella? Middle lamella is a cementing material between two plant cells. So, cell plate is formed from Golgi apparatus, and future it is going to form the cell wall. We can call it as a cell plate is a precursor of cell wall, and this cell plate after the formation of the two daughter cells, it is going to act as a cementing material. That is why cell plate represents the middle lamella. Generally in the examination they may confuse you. Which represents cell plate represents dash, cell plate is a precursor of dash. So, cell plate is a precursor of cell wall and it is a representation of the middle lamella. That is a thing. So, cell furrow method is happening in animal cells because of absence of cell wall. Cell plate method is happening in the plant cells because of presence of cell wall. If you consider it as a centripetal, it is going to be centrifugal. The force is acting against from the middle. That is the logic. Then there is a situation in sometimes the cell may lead to polyploidy condition. Not the polyploidy, even we can consider it as a, it is not the thing, you can consider it as a multinucleate condition. This multinucleate condition, sometimes we can consider it as a syncytium, where we can see this endosperm of the coconut. What will happen? Karyokinesis, after that cytokinesis is going to happen generally, but karyokinesis is not followed by cytokinesis. I am repeating, karyokinesis is not followed by cytokinesis. So, that what will happen within the cell, two nuclei are there. Again these two nuclei divide, continuously dividing, that leads to a multinucleate state. So, this multinucleate state in the second PUC syllabus, sexual reproduction in flowering plants, we have seen, especially during the embryo sac formation. In the embryo sac formation, one megaspore cell undergo only karyokinesis. First it will produce 2 nucleate stage, again 4 nucleate, again 8 nucleate. Until 8 nucleate stage there is no cell wall formation. That is in the embryo sac, megasporogenesis after that. So, multinucleate condition arises because of failure of cytokinesis after the karyokinesis. Here what is the example they had given? Coconut, liquid endosperm of coconut. In this coconut, the liquid endosperm is a multinucleate condition, we can consider it as a syncytium. So, this is about the mitosis process. Mitosis process having the significance that you can consider it off, you can read it off on your own. It is helps in cell repair, which are whatever cells are there, used up cells, dead cells, that will be replaced by mitosis. And mitosis maintains the chromosome number because it is a equational division. Number of chromosomes will be same in the parent and the progeny cells. And mitosis is going to be maintains the size of the cell, and it is very useful for the growth also. Growth of a multicellular organism is because of mitosis. How come? Connected with again plant growth and development, we said plant growth is open. What is meant by this open form of growth? New cells are always being added. How come? Because of presence of meristems at certain locations. Suppose in a plant at the tip shoot apical meristem is there, at the root tip root apical meristem is there. These cells are continuously dividing, producing new cells that increases the height of the plant. In the middle vascular cambium is there, it increases the girth of the organism. So, because of presence of meristems, continuous cell division, growth of an organism is arising, especially in the plants. This growth is because of which division? Mitosis. So, mitosis is useful for cell repair, growth, even maintains the size of the cell and maintains the chromosome number, that you can read it off. So this is about the process of mitosis and everything. So say in which phase chromosomes are clearly visible? Metaphase. In which phase chromosome number will be increased? Anaphase. In which phase chromosomes are going to lose their individuality? That is the telophase. In which phase chromosomes are going to gain their individuality? That is prophase. So in which phase centromere splitting is happening? That is telophase. And which phase chromosomes align at the equator? It is going to be the metaphase. So this is the logic entirely. After the mitosis process, let we enter into the process of meiosis. So mitosis is called as an equational division because number of chromosomes will be same in the parent and also the progeny. But as we are looking after this meiosis, meiosis is a reductional division. What is mean by this? Number of chromosomes will be reduced to half. So meiosis is not going to happen in the somatic cells, it is going to happen in the reproductive cells. We can call them as a germ cells, reproductive cells, and it is going to form the gametes. So in an organism, meiosis will happen during the gametogenesis, whether it is a male gamete or it is a female gamete. So the cells which are going to involve in the meiosis, those cells are going to be called as meiocytes. The question here is, what is the ploidy of meiocytes? Meiocytes are generally 2n in ploidy. Understand the logic, mitosis can occur in haploid cells and also diploid cells, because it is an equational division, number of chromosomes not going to change. But meiosis not going to occur in the haploid cells, because it is a reductional division, chromosome number has to be reduced. 1 by 2 is not possible in the nature. Haploid number of chromosomes cannot going to involve in the meiosis. So remember, the cell which is going to involve in the meiosis is called as a meiocyte. The meiocyte is always 2n in situation. Generally these meiocytes are germ cells, and the process of meiosis is going to happen during the formation of the gametes. We can consider it as a gametogenesis. Sexual cells or reproductive cells going to involve in this process. Somatic cells not going to involve in the meiosis. I told you male honeybee going to produce the gametes by the process of mitosis, but when you look after the female honeybee, 2n, 32 chromosomes are there that will undergo meiosis to produce the eggs. So now these meiosis are a bit complicated than process of mitosis. How the cell cycle of meiosis, if you consider, it is going to be, here also G1, yes, G2 is happening, everything was normal. In this DNA replication going to happen and all, everything was normal, but the division happens in two different phases. That is a meiosis 1, another one is a meiosis 2. So in the meiosis, 2 times karyokinesis happens, 2 times cytokinesis happens. I mean by 2 times nuclear division and 2 times cell division, but only 1 time DNA replication. So DNA replication happening in one phase, that is S phase, only 1 time, but karyokinesis and cytokinesis occurring in 2 different phases, 2 times. We can consider it as a first karyokinesis and first cytokinesis will be considered as meiosis 1, second karyokinesis and second cytokinesis will be considered as a meiosis 2. Between meiosis 1 and meiosis 2, there is an intermediate phase is there. This phase is going to be called as interkinesis. So the phase between 2 mitosis, we can call it as an interphase. Between meiosis 1 and meiosis 2, we can consider it as an interkinesis. In this, let me consider it as like this. Suppose 2n, 2 sets of chromosomes are there involved in this process. Its amount of DNA is 2c. 2c amount of DNA is there. Once it enter into the S phase, same number of chromosomes is not going to change here also, but 2c amount of DNA will become 4c and number of chromatids will be increased. Now this cell entering into the G2 phase. In the G2 phase also, cell is having 2 sets of chromosomes, each chromosome containing 2 chromatids, and amount of DNA is going to be 4c. And the cell after entering into the meiosis 1, at the end of meiosis 1, 1 cell will become 2 cells, At the end of meiosis 2, 2 cells will become 4 cells. 2 cells will become 4 cells. How this is going to be possible? Observe. After the G2 phase, cell once enter into meiosis 1, meiosis 1 is considered as a true meiosis. True meiosis. Why it is called as a true meiosis? Because reduction in the number of chromosomes happening in the meiosis 1. Whereas meiosis 2 is not a complete meiosis, it is same like mitosis. Whatever the events happening in the mitosis, same is going to happen in meiosis 2. So the actual reduction of chromosome number will be happening in the meiosis 1. So that meiosis 1 is considered as a true meiosis because of the reduction. Now one cell after entry into the, let me consider it as like this. One cell after entry into the meiosis 1, it will produce 2 cells. In these 2 cells, 2n number of chromosomes will become n. So reduction of chromosome number 2n will become n plus n is happening in the meiosis 1. And amount of DNA here 4C, here is going to be 2C at each cell. 2C at each cell. So by the end of meiosis 1, 2 haploid cells form or 2 diploid cells. So 2 haploid cells are formed at the end of the meiosis 1. Into the meiosis 2, 4 haploid cells are formed. 4 haploid cells. How come the difference here? Here these two are pair of chromosomes. We can call them as homologous chromosomes. During meiosis 1, homologous chromosomes are separated. Each will be entered into 1 different cells. But during the meiosis 2, sister chromatids are separated. So that number of chromatids will be decreased in the meiosis 2. We can observe it here. Sister chromatids are separated during anaphase. Same in this anaphase, sister chromatids are separated. So that here the situation is going to be like this. These cells are haploid cells. Haploid cells, all are haploid cells. 4 haploid cells are formed at the end of the meiosis. Amount of DNA, whatever 2C is there here, that will be split into C. Andre 4C amount of DNA will be split into C. 2n number of chromosomes will be split into n plus n. That is the logic. So totally this is the overall outlook about the meiosis. So what is the textbook statement saying? In the meiosis, 2 sets of karyokinesis and 2 sets of cytokinesis is happening and only 1 set of DNA replication, that is in the S phase. Remember it. And what happens during this interkinesis? Interkinesis is a phase where there is no DNA replication. Just it is a very short minute gap. Centrioles duplication happen here, whatever other requirements are there, they will be produced, cell growth will happen, but there is no DNA replication happens in the interface. So that is the logic here. Now after that, let me discuss about the meiosis 1 first. And meiosis 2, you can compare it with the mitosis concept. Mitosis concept. So meiosis 1. This meiosis 1, based on the behavior of chromosomes, the meiosis 1, not this one. First, it is divided into prophase, metaphase, anaphase and telophase. Prophase, as to make the differentiation, we are considering it as a prophase 1. This prophase 1, based on behavior of chromosomes, it is divided into 5 subphases. First phase is going to be called as a leptotin. Second phase is going to be called as a zygotin. Third phase will be called as a pachytin. Fourth phase is going to be considered as diplotin. And the last phase is going to be considered as a diakinesis. So based on the behavior of chromosomes, prophase 1, I mean by prophase occurring in the meiosis 1, will be divided into 5 subphases. What is happening in these subphases? Remember, in these subphases, what is happening? All the events belongs to prophase. Whatever happened in the prophase, in the mitosis, what you have seen, same thing happening here. I am repeating, prophase of mitosis, whatever happens, same events will happen here, repeat here, but additional some other events are there. Now, in this leptotin, condensation is started. Chromosomes starts visible under the microscope. Chromosomes starts visible under the microscope. Here I am drawing 2 chromosomes to represent 2 sets of chromosomes, because 2n is going to enter into the meiosis. So, in the leptotin, condensation started, chromosomes start visible under the light microscope. In the cytoplasm, what is happening? The centriole started moving to opposite poles. Now, in the zygote, what is happening? In this zygote, chromosome starts pairing. These chromosomes are similar in shape, size and the arrangement of genes. Those are called as homologous chromosomes. Homologous chromosomes. During the zygote, homologous chromosomes starts pairing. This process of pairing of homologous chromosomes is called as synapsis. Synapsis. Pairing of homologous chromosomes is called synapsis. This synapsis is arised because of there is a cementing material between them. This material is going to be called as synaptonemal complex. Which complex? The complex is called synaptonemal complex is there. Because of this, the paired chromosomes is going to be called as a bivalents. Paired chromosomes are called bivalents, pair of chromosomes. Or we can call them as a tetrads. Bivalents or tetrads. So, the process of pairing of homologous chromosomes is called synapsis. This synapsis is accompanied because of the cementing material called synaptonemal complex. After pairing, the paired chromosomes is called bivalents. Why it is called as a bivalent? 2 chromosomes are there. And it is called as a tetrads. Why it is called as tetrad? Each chromosome contains 2 chromatids. So, the total 4 chromatids are combined, we can call it as a tetrad. And everyone related to numerical point of questions has to remember that number of bivalents equals to number of tetrads. Number of bivalents equals to number of tetrads. Suppose in a human being 46 chromosomes are there. How many pairs are possible? 23. So, pair is considered as a bivalent. So, how many bivalents are possible within the human being? 23 bivalents. How many tetrads are possible? One tetrad means one bivalent. So, that if the number of bivalents are 23, number of tetrads also 23. So, why bi and tetra? Bi means in the perspective of chromosomes, tetra means in the perspective of chromatids. So, bivalent equals to tetrad. 2 bivalents means 2 tetrads, 44 bivalents means 44 tetrads, like that. Remember. So, still nuclear envelope is there. So, these are the things happening during the zygote. In the packaging, what are the events happening here? The sister chromatids undergo crossing over. Non-sister chromatids undergo crossing over. These are paired already. Now, this is a homologous chromosome pair. These 2 are sister chromatids, these 2 are sister chromatids because they belong to same chromosome. Now, what is happening? There are some points called as recombination nodules. Points called as recombination nodules. These are the places where sister chromatids undergo crossing over. How the process of crossing over going to happen here? Observe. So, one non-sister chromatid, another non-sister chromatids are going to cross over. And this leads to exchange of genetic material. We can call this process as a crossing over. So, crossing over is occur at some specific points called as recombination nodules. At the recombination nodules between homologous chromosomes and non-sister chromatids. Textbook statement is crossing over is the exchange of genetic material occurs between non-sister chromatids of homologous chromosomes. This leads to this chromatid will attach here, this chromatid will attach here. This leads to new combination. That combination we can consider it as like this, ma'am. Are able to observe the color here, ma'am. This pink color one was attached to this, and so this is going to happen. Crossing over occurs between non-sister chromatids of homologous chromosomes that leads to exchange of genetic material, formation of a new combination. That combination is called as recombination. that is going to be considered as a recombination. Still the synaptonymal complex is there. Now during the packeting, what is happening? At some point called as recombination nodules, exchange of genetic material that leads to new combination called as recombination. This entire process was mediated by the enzyme called as recombinase. Enzyme is called recombinase. Next, let me enter into the next phase, that is called as a packeting. During this packeting, dissolution of synaptonymal complex. Dissolution of synaptonymal complex. So that the paired chromosome started getting started separation, except at the sites of crossing over. Let me make it larger. So now initially this is the situation, between them synaptonymal complex was gone, so that except at the sites of crossing over, these homologous chromosomes started separation. You can observe the gap here. So initially what is here? Synaptonymal complex, that complex was gone, dissolution of the synaptonymal complex. Because of dissolution of synaptonymal complex, the paired homologous chromosome started separation except at the point of crossing over. At this point, an X-shaped structure is formed. This X-shaped structure is going to be called as a chiasmata. So chiasmata is an X-shaped structure. Assertion will be like this. Diplotin is a phase where X-shaped structure called chiasmata is formed. Reason, there is a dissolution of synaptonymal complex. Now the cell will enter into slowly next phase called as diakinesis. During this diakinesis, still the nuclear envelope is there. During this diakinesis, there is a process going on called as a terminalization of chiasmata. So what is this terminalization of chiasmata? Means people, this is, many people consider this is a chiasmata. Okay, chiasmata, X-shaped structure. Terminalization means this chiasmata has to be separated, but it is not going to like that separated. Specific word is terminalization. Means what? The X-shaped structure is going to be open like a zip-like fashion. Slowly it will open, and end it is going to be attached. How the zip will be opened, separating the two things except at the end. End will be still attached. Same way, terminalization of the chiasmata means this X-shaped structure which is present is not going to separate like that. It will be separated and will be still attached at the end. So that particular process is called as a chiasmata. So in this particular thing, this is the chromosome. Like this. Here chromosomes are fully attached. Here because of synaptonymal complex gone, they are also getting separated, started under in the diakinesis, terminalization of chiasmata happening, except at the end remaining structures are free. So this is the terminalization of the chiasmata, and this diakinesis is the end of the prophase, late prophase. I mean by nuclear envelope starts disappearing, Golgi, endoplasmic reticulum, nucleolus all will be disappeared. So this is early prophase, this is late prophase. So what is happening? Observe, condensation started here, pairing of homologous chromosomes, formation of bivalent tetrads, crossing over, recombination, the exchange of genetic material, everything is going on, and here dissolution of synaptonymal complex and getting separation of the paired homologous chromosomes, formation of X-shaped structure, terminalization of the structure, and disappearance of nuclear envelope, nucleolus, ER and the Golgi. That is the diakinesis. Among this, in oocytes of some vertebrates, my important point, neat point also, already it came. Oocytes of some vertebrates, this diplotin lasts for months to years, several years it is going to last. So longest phase my diplotin in oocytes of some vertebrates, not all, remember that. So this is about the meiosis, that is a prophase 1. Next it is going to be, okay, time was completed. So tomorrow we will continue with the remaining parts of this meiosis. I mean by metaphase 1, anaphase 1, telophase 1. Within 5-10 minutes we will complete that, we will wind up and we will continue to the cell unit of life. Thank you for today, it's all.
Good afternoon all of you students. So today topic thermodynamics. Today topic thermodynamics. So compulsory one or two questions and every year 2 questions are given and 2026 1 question is given this chapter. Right. Before going to the some important models, we can explain the some important formulas. First point, first law of thermodynamics. First law of thermodynamics. What is the first law of thermodynamics? dq is equal to du plus dw. dq, heat is supplied to the gas, heat is supplied to the gas is equal to sum of the first one is the total internal energy, other one is work done. So the heat supplied to the gas is equal to the sum of the internal energy and work done by the gas. That is dq is equal to du plus dw. So first law of thermodynamics is explains on the concept of and explained on the basis of law of conservation of energy. This one is law of conservation of energy. It works on the principle of law of conservation of energy. dq is equal to du plus dw. Important formula. Here work done. So work is done by the gas. Work is done by the gas. It can be taken as a positive. Work is done on the gas, negative. Work is done on the gas, negative. Now dq, heat is supplied. Heat is supplied to the gas, positive. Heat is released or rejected. So heat is released or rejected, that dq value can be taken as negative. Here du is nothing but a change in internal energy, like final minus initial. Final minus initial. So du is equal to uf minus ui, final internal energy minus initial internal energy. Work done by the gas positive, on the gas is negative. Heat is supplied to the gas, positive, and released or rejected, that is nothing but taken as negative. So these all are the important points. Now on the previous questions, 2 questions are given. Not only on the previous era, on May 3rd, 2026 is the given on this formula. dq is equal to du plus dw. What is that question in 2026 question What is that 2026 question? Now listen. An electric heater supplied to a heat to the system is at the rate of heat given to the system at the rate of power value 100 watts. If the system performs the work at the rate like dw by dt is nothing but 75 joules by second. First one heat is supplied by the rate dq by dt is 100. That's why what is the rate of internal energy? What is the value of du by dt? Is asking this question. 2026 question. Already we know that dq is equal to du plus dw. Now taking the differentiation amma, like dt nega, take them dt on both sides. Taking the differentiation with respect to time on both sides. Now problem over. What is the value of dq by dt? 100. Is asking the du by dt value. dw by dt 75. Therefore, du by dt is equal to 100 minus 75, 25 joules by second. 25 joules by second. This is the simple question amma, like first law of thermodynamics. Now another important point. Work done. Already we know that work is done by the gas amma, that is nothing but a positive. Work is done on the gas amma, the work done can be taken as a negative. Like what is the PV graph amma? The area of the PV graph gives work done. Already we know that. The area of PV graph gives work done. So that is the one of the important point amma. How to solve that work done? We can explain the some models later. First important points. The area of the PV graph gives work done. So that is the important point. This work done is depends upon the path. Work done depends on path of the gas. Work done is depends upon the path of the gas. Internal energy independent of path. Internal energy is independent of the path. Only internal energy is depends upon the initial and final temperatures of the gas amma. It is not depends upon the path. Okay, only depends upon the initial and final temperature. So it is independent of the path. These points are the very, very important. Okay, right. Next point. Now listen, the very, very important points. Specific heat of the gas. Specific heat of the gas. Specific heat of the gases are two types. One is the specific heat of the gas at a constant volume. Another one is the specific heat of the gas at a constant pressure. Now listen. Now dq of V. What is the meaning of dq of V amma? The heat supplied to the gas at a constant volume. That value ra n Cv d theta. N Cv d theta. Next dq of P. dq of P, the heat supplied to the gas at a constant pressure. What is the formula? Ncp d theta. And dw, like work done. Work done is nothing but nr d theta rp dv. These all are the important formulas. dq is equal to, at a constant volume ncv d theta. At a constant pressure ncp d theta. Like work done is nothing but P dv or nr d theta. These three formulas are important. At a constant volume ga, now listen amma, already we know that dq is equal to du plus dw ga. At a constant volume work done is 0. Already we know that. At a constant volume work done is 0. That's why what is the expression amma? dq is equal to du nega at a constant volume. So here amma dq of V or du both are same. Because of at a constant volume, here I am writing as V. At a constant volume work done is 0. And dq is equal to du nega. And this dq value and du value both are same. What is the expression? Ncv d theta. Now at a constant pressure ncp d theta. Work done P dv or nr d theta. These all are the important formulas. Now another important formulas. Cp minus Cv is equal to R. Cp minus Cv is equal to R. Cp, molar specific heat of the gas at a constant pressure. Cv, molar specific heat of the gas at a constant volume. That difference is nothing but capital R. And gamma is equal to Cp by Cv. Gamma is equal to Cp by Cv. Ratio of the specific heat of the two gases is nothing but gamma. Next, another point. Cv is equal to R by gamma minus 1. Cv is equal to R by gamma minus 1. Cp is equal to gamma into Cv ga. Gamma into Cv means R by gamma minus 1. R by gamma minus 1. These all are the important formulas. Derivations already we know that in our notebook. But here only just one time I am reminding the total formulas. Cp minus Cv is equal to R. Gamma is equal to Cp by Cv. Cv is equal to R by gamma minus 1, important formula. And Cp is equal to gamma R by gamma minus 1. So these all are the important formulas. Now another point. Next one is, two gases are mixed. Now listen, first, two gases are mixed. What is the expression of the gamma mixer? Two gases, N1 moles of the monoatomic gas, like gamma 1, like mono or di or tri, any one of the gas whose gamma 1 is the ratio of the specific heat of the gas. Here N1 moles. N2 moles gamma 2 like diatomic gas. Now these two gases are mixed. What is the gamma mixer? Gamma mixer. Now N1 plus N2 by gamma mixer minus 1 is equal to N1 by gamma 1 minus 1 plus N2 by gamma 2 minus 1. So this is the important formula. The two gases are mixed. What is the gamma mixer? N1 plus N2 by gamma mixer minus 1 is equal to N1 by gamma 1 minus 1 plus N2 by gamma 2 minus 1, or gamma mixer is equal to, gamma means Cp by Cv nega, like Cp mixer by Cv mixer. What is the value of N1 Cp1 plus N2 Cp2 by N1 Cv1 plus N2 Cv2. So any formula, in these two any formula we can use them, we get the same answer. But very, very important formulas. Gamma mixer. Two gases are mixed, then what is the effective gamma? Like these two are the important formulas. Now, next point. Different thermodynamic process, one of the important point. So many thermodynamic processes are there, and that first one is, what is that? Isobaric process. In isobaric process, which one is constant? Isobaric process, pressure is constant. Pressure is constant. Second one is isochoric process. In isochoric process, which one is constant? Volume is constant. Volume is constant. Third one is isothermal process. In isothermal process, which one is constant? Temperature is constant. Temperature is constant. In case of the temperature is constant, what is the relation between pressure and volume? Pressure is inversely proportional to volume, like PV is equal to constant. PV is equal to constant in isothermal process. That's why what is the work done by the gas in isothermal process? In board point of view, 5 marks question derivation is there. What is the work done formula? That work done is equal to 2.3026 nRT log V2 by V1 base 10. Sometimes nRT ln V2 by V1 and like base E. So this is the work done by the gas in isothermal process. So nRT log of V2 by V1 base E. In case of the base 10 amma 2.3026. These three are the important formulas amma in isothermal process. Now next one is adiabatic process. Adiabatic process. In adiabatic process, which one is constant amma? Q is constant. Amount of the heat energy is constant. Next, so what is the relation between the pressure and the volume? PV power gamma is equal to constant. PV power gamma is equal to constant. Like another one, P power 1 minus gamma, T power gamma is equal to constant. Or TV power gamma minus 1 is equal to constant. Very, very important formulas. PV power gamma, P power 1 minus gamma, T power gamma is equal to constant. Okay, next, TV power gamma minus 1 is equal to constant. Very, very important formula samma. Number of the times are given this model samma. Next, other one. What is the work done by the gas in adiabatic process? That work done is equal to P2 V2 minus P1 V1 by 1 minus gamma, or N or T2 minus T1 by 1 minus gamma. This is the another important formula, work done by the gas in adiabatic process. Work done by the gas in isothermal process. Important formula, some direct one. Next, PV power gamma is equal to constant. P power 1 minus gamma, T power gamma is equal to constant. TV power gamma minus 1 is equal to constant. Only T power 1 number. Work done by the gas in adiabatic process. All are the very, very important formulas. Next, another one is polytropic process. Polytropic process. In polytropic process, PV power n is equal to constant. PV power n, PV power n or PV power x, anyone, take them different letter x. Where x value except 1 comma gamma. Where x value except 1 comma gamma. Why x value 1 like is nothing but x value 1 means isothermal ga. X value gamma in case of the gamma it is nothing but adiabatic ka. So 1 and x except 1 and gamma it is nothing but polytropic. Another important formula. Next, another important point. Molar heat capacity of the gas. Molar heat capacity of the gas is C is equal to R by gamma minus 1 by. This is the another important formula. Now listen. What is the molar heat capacity of the gas in polytropic process? That C is equal to R by gamma minus 1 plus R by 1 minus x. X and like this one. Where gamma means already we know that for monoatomic gas, gamma value 5 by 3. For a diatomic gas, 7 by 5. For a triatomic gas, 4 by 3. Values are already we know that by that gas are given when substituting the gamma values. Relation is given that x value substituting here. We get the molar heat capacity of the gas in a polytropic process. So that's why these 1, 2, 3, 4, 5, that 5 are the different process very, very important formulas. Okay, right. Now, next another important point, heat engine. Heat engine. So, simple points, now listen carefully. This one is the source, T1 kelvins. This one is the sink, like T2 kelvins. This is the working substance like fuel. Working substance. They having the some connection is there, amma? Right. Heat engine. So heat engine, amma, it is a convert the heat energy into mechanical energy. It is a converted into heat energy into mechanical energy. Like simple the final simple rough diagram like this one. This is the source, amma, is nothing but hot reservoir. This is the sink, cold reservoir. Now listen, some amount of the heat is taken from the source is like Q1. Some amount of the heat is taken from the source is Q1. So some work is done, amma. What is the remaining heat, amma? Like Q2. So how much of the work is done, amma? W. How much of the heat is rejected to the sink, Q2. How much of the heat is absorbed from the source, amma? Like Q1. What is the formula for efficiency? Output by input. Output W is also known as Q1 minus Q2 by Q1. That value is also equal to 1 minus T2 by T1. Now listen, amma, I am only remind the formulas, amma. Only remind the formulas, say that concept of each and every pointer we have the idea. In this time, amma, we can just idea about the formula and how to solve the numericals. That enough. Okay. What is the meaning of efficiency? Output energy by input energy. Output is W, input is Q1. What is the work done, amma? Q1 minus Q2 by Q1. That value is also equal to 1 minus T2 by T1. That is one of the concept, amma, in heat engine. Now other one is refrigerator. Refrigerator, same diagram. Like source, like T1 kelvins, sink, like T2 kelvins. Now this is the fuel. There is a connection between the source and the sink. This is the refrigerator means, amma, sink is nothing but refrigerator. Sink is nothing but fridge. Like fridge, amma. So here, amma, source is nothing but a room. Because of freezes can be placed in a room. So in fridge, the amount of the heat can be taken from the sink like Q2. So by that Q2 compulsory we can apply the power supply. Power supply is nothing but W. So that refrigerator, some amount of the heat can be absorbed. That amount of the heat is rejected to room like this one, Q1. Here, amma, what is the meaning of Q2, amma? Amount of the heat absorbed from the sink. Amount of the heat absorbed from the sink. What is the meaning of Q1, amma? Amount of the heat is rejected to the source. Amount of the heat is rejected to the source or room. Here, amma, power supply. Like work done is W. So here, amma, one of the important term is beta, coefficient of the performance. Coefficient of the performance is nothing but Q2 by W. So Q2 by W means, amma, Q1 minus Q2. That value is also equal to T2 by T1 minus T2. T2 by T1 minus T2. Another important formula. What is the relation between the beta and the eta? What is the relation between the beta and the eta? Eta is equal to 1 by 1 plus beta. The relation between the efficiency and the coefficient of the performance is eta is equal to 1 by 1 plus beta. So these all are the important, just we can remind the only formulas. But we can just we can observe the points, the meanings are the important one. What is the meaning of Q2? Like the total diagram reverse, some arrow marks are reverse, we can observe them, this diagram, that diagram. Here Q2 is not like this one, and amount of the heat is absorbed from the refrigerator. What is the meaning of Q2? Amount of the heat is rejected to the room. Okay, here what is the meaning of Q1? Amount of the heat is absorbed from the source. What is the meaning of Q2? Amount of the heat is rejected to the sink. So that meanings are the very, very important one, because of in the numerical sum is asking the Q1 na Q2 na. That is the important one. Because of meanings of the idea, problems are is very, very simple. Amma. Number of the questions are given on the previous years on the heat engine and the refrigerator. Only formulas, we can practice the formulas only 1 or 2 times. After that, we can do the previous year questions. Only PYQ, only PYQ 1 or 2 times we can practice them is enough. So, now previous PYQs means including AAPMT questions up to the last 10 years, 10 or 15 years we can practice them is enough. All models are we have the idea. Okay, right. Okay, now we can explain the some models, Sir, Master. Okay. Now, in a 2024 question, now we can explain the one by one. Now listen carefully. Take them on rough paper, we can practice them one by one. So in 2024, one graph is given, pressure and volume graph like this. Pressure volume graph A, this is the B, C, this is the D, A. Here 300 kilopascals. This one 100 kilopascals. Here value 100 centimeter cube. This value 400 centimeter cube. That's why what is the work done by the gas along the process of BC? Is asking work done by the gas along the BC is asking. Right. So what is the work done by the gas along the BC? Like BC, like this one. In BC, which one is constant? Volume is constant. And at the point B, volume 400, at the point C, and like 400. Like work done means PdV. Change in volume, final volume, initial volume, both are same. Work done is 0. Work done is 0. Now problem is over. The work done by the gas along the BC is equal to 0. Sometimes, what is the work done by the gas in a cyclic process? And in a total cyclic, how much of the work is done? The total work done for a cycle. What is this shape? Rectangle shape. Rectangle shape got a length into breadth. What is the length? Like this one. What is this one? Final minus initial. 400 minus 100. 300. Centimeter cube. 10 power minus 6. Breadth like this one. What is this one? This value is 300 minus 100. Like 200. Kilo. 10 cube. Kilo means 10 cube. How much value this one? 3 zeros. 4, 5, 6. 10 power 6. This minus 6 cancel. 30 into 2 like 60. Joules. 60 joules. But here we can see them very carefully. This graph is clockwise or anti-clockwise. Like this one is nothing but anti-clockwise. Anti-clockwise. In case of the anti-clockwise, the work done is negative. So the answer is minus 60 joules. Minus 60 joules. Because of graph in anti-clockwise, the graph value can be taken as a negative. In case of the clockwise, the work done value positive. So PV graph, anti-clockwise dW is positive. Sorry, work done is negative. Clockwise, work done is positive. So in option minus 60 and plus 60, both options are there. That case we can observe them clockwise and anti-clockwise. So in case of the PV graph, pressure is on the y-axis, volume is on x-axis. That case anti-clockwise direction, the work done is negative, like this one. In case of the clockwise, work done is positive. Okay. So this is the 2024 question. Next one, 2023 question. Again, a PV graph is given. Volume, this one pressure. Graph shape like this one. A, B, C. Here 3 into 10 power 10 square root. Here 2 10 square root, only 10 square root. Middle one 2 into 10 square root. Here volume 1, middle one 2, ending one is 3 meter cube. This one Newton per meter square. What is asking the question? What is the work done by the gas during the isobaric process? What is the work done by the gas in isobaric process? Find work done in isobaric process. Find the work done in isobaric process. That is the question. What is the meaning of isobaric process? Pressure value constant. Pressure value constant on which line? A, B or B, C or CD? Sorry, CA. Like pressure constant AB. And simply is asking the work done AB. Problem is over. On A to B, pressure value constant. Gas is starting from the point here, initial volume 1, final volume 3. Therefore, pressure P into change in volume. What is the value of pressure? 3 into 10 square root. What is the change in volume? Final minus initial, 3 minus 1. Like 2. 2 into 3, 600. 600 joules. 600 joules. So that is the work done in isobaric process. So that is another important point. For example, what is the total work done by the gas? What is the total work done by the gas in a cycle? Total work done in a cycle. What is the graph shape? Triangle. Half into base into height. Half into base. And like this one, like this one, 3 minus 1, 2. Height, like this one, no. 3 into, like 300 minus 100. Like 200. How much value? This 2 value cancel 200 joules. But in options plus 200 minus 200, both are there. What is the correct one? This is the PV graph. Clockwise or anti-clockwise? This is the clockwise. This is the clockwise. In case of the clockwise, the work done value plus 200 joules. Anti-clockwise minus. So sometimes may be possibility. What is the total work done by the gas? So this is the total work done, but on the previous need only asking the work done in AB. So one of the model. Next one. In 2023 question, a Carnot engine has an efficiency 50%. Efficiency 50%. And when the source is at a temperature, 327 degrees centigrade, what is the temperature of the sink? What is the temperature of the sink? So, is the given Carnot engine. Actually, Carnot engine is syllabus is deleted now in 2026 or 25. But Carnot engine and heat engine can be taken as the same formula. Say. What is the main difference? Carnot engine is nothing but a reversible process. Reversible process. Heat engine is nothing but a irreversible process. But both having the same formulas. Don't confuse Carnot engine or heat engine having the same formulas. Like eta is equal to 1 minus T2 by T1. What is the efficiency value? 50%. Like 50 by 100. 1 minus T2 value we don't know. What is the value of T1 amma? 327 degrees centigrade. But our temperature is always in kelvins because of it is the SI unit. Plus 273 and like 600. This value amma 1 by 2. T2 by 600 is equal to 1 minus 1 by 2. 1 no. This 1 by 2 taken another side amma. Therefore, T2 value amma 600 by 2. 300 Kelvin or 27 degrees centigrade. 300 Kelvin or 27 degrees centigrade, we get the we get the T2. Now another model. Sir, ఎంతమంది ఉన్నారు? 9 members. Next one amma, question number 4. Like this is the 2022 question. 2022 question. Like amma is the given amma PV graph is given, pressure and volume graph is given amma like this one. So 1, 2, 3, 4. So that's why which of the following the adiabatic process in 1, 2, 3, 4. In 1, 2, 3, 4 amma which one having the adiabatic process? Now listen. Already we know that in PV graph amma like this one is the pressure constant amma. Pressure is a constant amma, this one is isobaric process. Next, this one amma we can observe the amma volume constant. Like this one is isochoric process. Like 3 and 2. We can observe the amma second one having the more slope amma. Second one having the more angle with x-axis amma. More slope is there amma, this one is the adiabatic process. Small slope is there amma, this one is the isothermal process. So that's why what is the question is the given amma, which of the following them 1, 2, 3, 4 graph which one is the adiabatic? Like second one is the adiabatic process. This question is the given amma number of times like. Next amma, in 2020 in 2020 amma one question is there amma, pressure and volume, like this is the line. This is the line when gas is starting and ending like this process. What is this process? In that graph amma which process is there amma? We can observe the amma line is along the x-axis parallel to the x-axis which one is a constant pressure value constant pressure value constant is nothing but isobaric process amma. So the answer is nothing but isobaric. So direct questions are given amma in 2020. Next one is in 2020 another question. In 2020 another question. The efficiency of the Carnot engine is depends upon. What is the meaning of efficiency amma? 1 minus T2 by T1 So the efficiency of the Carnot engine is depends upon the what are the values amma? T1 and T2 So T1 is the temperature of the source, T2 is the temperature of the sink. So it depends upon the temperature of the source and the sink amma, now problem over. Is the given the basic questions amma on the previous years. Already we can see them in 2026 only dq is equal du plus dw formula that's why again amma same models are given. Simple questions. So only we can revise the formulas amma 1 or 2 times. Next one amma. In 2019 question. In 2019 question. In which of the following process heat is neither be absorbed nor be released, then the system is known as heat is neither be absorbed nor be released. like heat energy value constant. Heat energy value is constant. Then that process is known as adiabatic process. Adiabatic process. That is the 2019 question. Next, 2018 question. In 2018, amma, now listen carefully, amma. A sample 0.1 grams of water. 0.1 grams of water. 0.1 grams of water requires 54 calories. Requires the 54 calories, amma, is converted into steam. Is converted into steam, amma, at 100 degrees centigrade. So finally the volume of the steam is nothing but 671.1 cc. That's why what is the internal energy? What is the change in internal energy? What is the change in internal energy? Now listen carefully, important model, amma. Two times is the given same question. So I am explaining the in 2018 problem, amma. But another one is there, amma. 2019 Odisha problem. 2019 Odisha problem. Same model, amma. That's why this model, amma, we can try it, amma. I will explain the 2018 problem. Now listen. Mass value, amma, 0.1 grams of the water, amma. 0.1 grams of the water. Like water, amma, is there, amma. 54 calories of the heat is given, amma, is converted into steam at 100 degrees centigrade. Now listen, that 0.1 grams of the water is also at 100 degrees centigrade. Is the clearly given. Is converted into steam, amma, by 54 calories of the heat energy. By that converting the steam, amma, 671.1 centimeter cube of the volume is there. What is the internal energy? Now listen, what is the heat supplied, amma? 54 calories. Calories are like converted into joules. 54 calories, amma, converted into joules. That is the value. Next, now listen. Initial 0.1 grams of water gara, what is the initial volume, amma? Initial volume is nothing but mass by density nega. What is the mass value, amma? 0.1 gram gada. Gram, CGS unit gada. What is the density of the water in CGS unit? Like 1 nega, like 0.1 centimeter cube. Final volume 677.1 centimeter cube. What is the change in volume? dV. 671 minus 1 minus 0.1, like only 671 centimeter cube. What is the work done formula? Work done formula, pressure into change in volume. This process is done at the normal pressure, like atmospheric pressure. What is the atmospheric pressure, amma? 1.01 into 10 power 5. What is the change in volume, amma? 671 centimeter cube, like 10 power minus 6. Okay, like 1.01 and approximately 1, leave it. 10 power 5, 10 power minus 16. Or multiple them 10 power minus 1, like 16.7 joules. So heat energy value already is given, amma. We can find the work done value. How to find the internal energy? By the first law of thermodynamics. dq is equal to du plus dw. Therefore du is equal to dq minus dw. What is the value of dq, amma? 54 into 42. So for 54 into 42, what is the value? So generally we can calculation by simple calculation 54 into 4.2, 226.8 minus 16.7 minus 16.7 210. So approximately we get the 210 joules. That is the previous question amma. Actually, this problem is our NCERT solved problem. This is the total NCERT solved problem. Very, very important amma, because 2018 this question is the given. In 2019 Odisha paper is also given the same question. That's why very, very important model amma. 2 times already given amma. Now again 1 or 2 times you can practice this problem. Okay. Now what is the given amma? 0.1 grams of water at 100 degrees centigrade amma. Now converted into steam at 100 degrees centigrade, whose volume is 671.1 cc. How much of the heat is supplied amma? 54 calories. What is the internal energy? Already heat is given how much amma? 54 amma. Calorie means 4.2 joules. Like this value. What is the initial volume amma? Initial mass value given gara volume mass by density. Mass value is 0.1 gram, density value is 0.1 centimeter cube. What is the final volume amma? 167 minus 1 centimeter cube. Change in volume 167 centimeter cube. Work done means amma PdV. What is the pressure amma? This process is done at the normal pressure. 1.01 into 10 power 5. Change in volume 167 centimeter cube gamma 10 power minus 6 meter cube. Like 16.7 joules. What is the formula for first law of thermodynamics? dq is equal to du plus dw. Therefore, du means dq minus dw. We get 210 joules. Important model. Now another model. In a 2018 question. 2018 question. Now this is the VT graph. Volume or temperature graph is a straight line passing through the origin. The heat absorbed to the gas when it undergoes the change in state from A to B, the ratio of, now listen amma, find the ratio of work done to the heat supplied to the gas. Work done to heat supplied to the gas amma. Work done by dq is asking. Now listen carefully. Volume temperature amma, a straight line passing through the origin means which one is a constant amma? Pressure value is a constant. When pressure is a constant amma, that straight line is passing through the origin. Pressure is a constant. Right, already we know that. Pressure is a constant amma. What is the work done formula? P dV r n r d theta. Next, what is the pressure value constant gamma? What is the value of dq of P? N Cp d theta. So that's why what is the value of R by Cp? R by Cp. But in a given question amma, it is the monoatomic gas is given. So this is for monoatomic gas. R by, for monoatomic gas, what is the value of Cp amma? Cp value 5 by 2 R. 5 by 2 R. So that's why R value cancel amma, we get 2 by 5. We get 2 by 5. So in a given question amma, VT graph amma, a straight line passing through the origin, like pressure value constant. Pressure value constant gara is asking the work done by heat energy. Work done formula amma P dV or nr d theta. dq amma ncp d theta. N d theta cancel, R by Cp. But the given question amma, it is the monoatomic gas. Monoatomic gas amma 5 by 2 R. R value cancel amma, we get the 2 by 5. Now another question. (2018) question. Again 2018 question amma, another question is there. The efficiency of an ideal heat engine is working between the freezing point and boiling point of the water. Is asking the efficiency amma, having the source and sink gara, one point boiling point, other one freezing point. What is the meaning of freezing point? 0 degree centigrade. What is the boiling point? 100 degree centigrade. That's why is asking the efficiency. So 0 degree centigrade means 273 kelvins. 100 degree centigrade 373 kelvins. What is the formula? Efficiency is equal to 1 minus T2 by T1. Okay, 1 minus T2, 273 by 373. LCM 373. 373 minus 273, 100. But his answer in a percentage 100 by 373 into 100. So that's why we get the approximate 26.8. We get approximately 26.8%. So 2018 is also given the same model 2 times are given the direct formula based. Now another one. In 2016, one mole of an ideal monoatomic gas, 1 mole of an ideal monoatomic gas is following the relation PV power 3 is equal to PV power cube is equal to constant. What is the heat capacity of the gas in the process? What is the heat capacity? What is the heat capacity of the gas in the process? 1 mole of an monoatomic gas following the relation PV cube is equal to constant. Already we know that PV power 1 ante isothermal. PV power gamma is nothing but ratio of the specific heat of the gas ga. For mono kemo 5 by 3, dia ki 7 by 5, tri ki 4 by 3. But here only 3 value gara, except 1 gamma it is nothing but polytropic. And like this one is the polytropic process. In a polytropic process, PV power x value is equal to constant. What is the x value? Here 3. What is the value of gamma for monoatomic gas? 5 by 3. That's why what is the heat capacity of the gas? R by gamma minus 1 plus R by 1 minus x. So R by gamma 5 by 3 minus 1 R by 1 minus x value 3. Here LCM 3 5 minus 3 and 2 reverse 3R by 2. Here minus R by 2. LCM is 2. 3R minus R, 2R, like R. So the molar heat capacity of the gas in the process is nothing but only R. 2016 question amma. Now in a 2016 question, again, now listen, 2016, the temperature inside the refrigerator is 2 degrees centigrade. Inside the refrigerator T2 degrees centigrade. And the room temperature is T1 degree centigrade. So the amount of the heat delivered to the room for each joule of electrical energy is amount of heat delivered to room for each joule of electrical energy. Is asking this value amma. Now listen, This one amma clearly given ra, this is the refrigerator temperature. This one amma room temperature is given. That's why ra, what is the amount of or find the amount of heat delivered to the room for each joule of the electrical energy. Now listen, what is the in refrigerator concept amma? Heat delivered to the room, Q1 na Q2 na? Q1. The heat delivered to the room is nothing but Q1. Per each joule of the electrical energy. Each joule of electrical energy and like work done ega, power supply is the work done ega, like Q1 by W. Is asking the Q1 by W value amma. So is asking the Q1 by W value. How to solve this model? Ra? Now listen, already we know that coefficient of the performance beta is equal to Q2 by W is equal to T2 by T1 minus T2 nega, or Q2 by W means like Q1 minus Q2 nega. Q2 by Q1 minus Q2 is equal to T2 by T1 minus T2. But is asking Q1 by W. How to solve this one amma? Now listen carefully ra. Here amma take the minus 1, no, here amma take the minus. Q2 by Q1 minus Q2 kada minus 1 no. T2 by T1 minus T2 take the minus 1 no. What happens ra? What is the LCM here? Q1 minus Q2. Here Q2. This total term is multiple ega. Minus Q1 minus or minus plus Q1. Here also what is the LCM amma? T1 minus T2 nega. T2 same multiple them minus T1 no minus of minus plus T2. Here amma plus Q1 no minus Q1 no cancel ga. What is the remaining value? Q2 by Q1 minus Q2. Q1 minus Q2 like W nega is equal to what is the remaining value? Minus T1 no. What is the remaining value ra? Q2 by T2, Q2 by W, T1 minus T2, minus T1 no plus T2 like what is the value ra? T1 by T1 minus T2. Era is asking the Q1 by W value ega, Q1 by W value ega, T1 actually value in Kelvin amma, Kelvin gara plus 273 by difference kadamma, in difference amma degree centigrade or Kelvin both are same like T1 by T2, like this one amma. So this is the 2016 question. So actually what is the amount of the heat delivered to the room? Amount of the heat delivered to the room is nothing but what is the value of Q1 by per each joule of the electrical energy W is asking the Q1 by W. But what is the coefficient of the performance Q2 by W? Q2 by W value like this formula. So that's why I take the minus 1 on both sides then simplifying we get. Okay? Sorry ra. Q2 minus Q1 no minus of minus plus Q2. That's why plus Q2 and these are cancelled gamma. That's why Q1 by W. We get the answer. Okay, Namma. So this is the one of the important another model. Next question. Now listen another question. In 2013 question amma. In 2013 question. Now listen. During an adiabatic process, the pressure of the gas is found to be is proportional to cube of the temperature. What is the value of Cp by Cv? What is this gas amma? Pressure of gas is found to be fourth cube of the temperature. That's where what is the value of Cp by Cv? Okay, now. In adiabatic process, pressure is directly proportional to cube of the temperature. That's where what is the value of Cp by Cv. So already we know that in adiabatic process, what is the relation between pressure and temperature? P power 1 minus gamma, T power gamma is equal to constant. But here only on LH side only pressure is there ga, only pressure. This T value take them another side minus gamma. This value take them another side minus gamma. Here only P power 1 ga, but here P power 1 minus gamma ga, like power value divided with 1 minus gamma. Like power value 1 minus gamma divided gara only 1. Here power value divided with 1 minus gamma. Now we can comparison P directly proportional to T cube. P directly proportional to T cube. That's why in 3 place which value is there? That 3 value is equal to minus gamma by 1 minus gamma. So on cross multiplying 3 minus 3 gamma is equal to minus gamma. So 3 gamma taken that side 3 gamma minus gamma 2 gamma. Like gamma is equal to 3 by 2. But he is asking the Cp by Cv ga. Cp by Cv is nothing but gamma, ratio of the specific heat of the gas. That value 3 by 2. So that is the 2013 question. Okay. One more also. Right, last problem. Now listen, in a last problem, in a 2013 question, another question. Volume temperature graph is given. There are the 2 different gases, like this one P1, this one P2. Right. What is the relation between the pressure and what is the relation between their pressures? Now this is the Vt graph. In case of the Vt graph, what is the slope? Slope is nothing but tan theta. Opposite side by adjacent side, like V by T. V by T. From ideal gas equation, V by T is nothing but Nr by P nega. You can cross multiply them. PV is equal to Nr T nega. So slope is nothing but V by T. That V by T value is nothing but Nr by P. So directly tan theta value or slope value is inversely proportional to pressure because of V by T or Nr by P both are same NR value constant and slope is inversely proportional to pressure. So this one less angle, this one more angle. More angle is nothing but more slope. For more slope like this one for more slope pressure value less and this value pressure value less. Less slope like this one more pressure. That's why P1 is greater than P2. So the relation between the P1 and the P2 are P1 greater than P2. Okay, right, so these all the models are on the thermodynamics. And tomorrow class kinetic theory of gas. So that chapter is also important one. Right, we can continue on next class. Thank you. Let's.
Hello all. Today we are continuing the same chapter D and F block. Here are the next set of questions that we need to discuss from this chapter. The first question, I had sent a document just 5 minutes or 10 minutes ago. In that we are discussing 51st question. The first question is, the observed and calculated spin only magnetic moments of cobalt plus 2 are same. Looks like this question was already, the statement was already discussed yesterday, but yet I will just emphasize on it. The observed and calculated spin only magnetic moments of cobalt plus 2 are same. It is not just cobalt plus 2 alone, but when we consider iron, cobalt and nickel, copper, among these 4 elements, the observed and calculated magnetic moments deviate. Therefore, the first statement is not correct. The most acidic oxide of manganese is Mn2O3 is the second statement, but when we consider a most acidic oxide of manganese, it is Mn2O7. ಯಾವ ತರಹ ಎಸಿಡಿಕ್ ನೇಚರನ್ನು ನಾವು ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ ಎಸಿಡಿಕ್ ನೇಚರ್ ಆಫ್ ಆಕ್ಸೈಡ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಚಾರ್ಜ್ ಆನ್ ದ ಮೆಟಲ್, ಈವನ್ ಆನ್ ದ ನಾನ್ ಮೆಟಲ್. ಚಾರ್ಜ್ ಆನ್ ದ ಮೆಟಲ್ ಆರ್ ನಾನ್ ಮೆಟಲ್, ಎಷ್ಟು ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಇದ್ದರೆ ಅಷ್ಟು ಕೋವಲೆಂಟ್ ಅಷ್ಟು ಎಲೆಕ್ಟ್ರೋನೆಗೇಟಿವಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರೋನೆಗೇಟಿವಿಟಿ ಜಾಸ್ತಿ ಆದರೆ ಅಷ್ಟು ನಾನ್ ಮೆಟಾಲಿಕ್ ನೇಚರ್ ಪಡೆಯುತ್ತೆ. ಎಷ್ಟು ನಾನ್ ಮೆಟಾಲಿಕ್ ನೇಚರ್ ಇದ್ದರೆ ಅಷ್ಟು ಎಸಿಡಿಕ್ ಸ್ಟ್ರೆಂಗ್ತ್ ಇರುತ್ತೆ ಅದಕ್ಕೆ. ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್, V2O5 being amphoteric forms VO4 minus 3 in bases and VO2 plus in acids. ಸೊ V2O5 ಅನ್ನೋದು ಆಂಫೋಟೆರಿಕ್ ಆಗಿರೋದ್ರಿಂದ ಆಂಫೋಟೆರಿಕ್ ಆಗಿರೋದ್ರಿಂದ ವೆನೆಡೇಟ್ ಮತ್ತು VO2 ಪ್ಲಸ್ ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದು. ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೂಡ ನಿನ್ನೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದಾಗ ನಮಗೆ ಬಂದಿದೆ. V2O5 ಆಂಫೋಟೆರಿಕ್ಕೆ, ಇದಷ್ಟೇ ಅಲ್ಲ, Cr2O3 ಕೂಡ ಆಂಫೋಟೆರಿಕ್ಕೆ, ಎರಡೂ ಕೂಡ ನೆನಪಿಟ್ಕೋಬೇಕು. ಸೊ ಇದು ಬೇಸಿಸ್ನಲ್ಲಿ ಹಾಕಿದ್ದಾಗ ವೆನೆಡೇಟ್ ಅಯಾನನ್ನು, ಇದು ಆಸಿಡ್ಸ್ನಲ್ಲಿ ಹಾಕಿದ್ದಾಗ VO2 ಪ್ಲಸ್ ಅನ್ನು ಕೊಡ್ತಾ ಇದೆ. ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಫೋರ್ತ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಕಂಪೌಂಡ್ಸ್ ಆರ್ ಹೈಲಿ ರಿಯಾಕ್ಟಿವ್ ಅನ್ನೋದು ಇಲ್ಲಿ ಸ್ಟೇಟ್ಮೆಂಟ್. ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಕಂಪೌಂಡ್ಸ್ ಆರ್ ಇನರ್ಟ್, ದೇ ಆರ್ ನಾಟ್ ರಿಯಾಕ್ಟಿವ್. Their reactivity gets decreased due to the formation of interstitial compound. Therefore, that statement is a false statement. So, correct option is option number 3. Let's move to the next question. ಒಂದು ಸ್ಟ್ರಕ್ಚರನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಇದರಲ್ಲಿ CrO, CrOO. ಈ ಸ್ಟ್ರಕ್ಚರ್ನಲ್ಲಿ we have X and Y. ಅಂದರೆ ಎಕ್ಸ್ ಆ್ಯಂಡ್ ವೈ ಆರ್ ಬಾಂಡ್ ಲೆಂಗ್ತ್ಸ್. ಈ ಬಾಂಡ್ ಲೆಂಗ್ತ್ಸ್ನಲ್ಲಿ ಯಾವುದು ಜಾಸ್ತಿ ಯಾವುದು ಕಮ್ಮಿ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್ ಇಲ್ಲಿ. ಇದು ಡೈಕ್ರೋಮೇಟಿನ ಸ್ಟ್ರಕ್ಚರ್. ಈ ಡೈಕ್ರೋಮೇಟಿನ ಸ್ಟ್ರಕ್ಚರ್ನಲ್ಲಿ CrOO -2. ಇದರಲ್ಲಿ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದಾಗ ಇದು 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 3 ಬಾಂಡ್ಸ್, ಈ 3 ಬಾಂಡ್ಸ್ ಕೂಡ ರೆಸೊನೆನ್ಸ್ನಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗ್ತವೆ. ಅವು ಪಾರ್ಷಿಯಲ್ ಡಬಲ್ ಬಾಂಡ್ ಕ್ಯಾರೆಕ್ಟರ್ನ ಹೊಂದಿರ್ತವೆ ಅವೆಲ್ಲ. ಸೊ 2 ಡಬಲ್ ಬಾಂಡ್ಸ್ ಇಲ್ಲೆಲ್ಲ ರೆಸೊನೇಟ್ ಆಗ್ತವೆ. ಈ ಥರ. ಸೊ ಈ ರೆಸೊನೇಟ್ ಆಗೋದ್ರಿಂದ ನಮಗೆ ಡಬಲ್ ಬಾಂಡ್ಸ್ ಅನ್ನೋವು 3ಕ್ಕೂ ಬರ್ತವೆ, ಇಲ್ಲಿ ಕೂಡ ಬರುತ್ತೆ. ಬಟ್ ಇದು ಸಿಂಗಲ್ ಬಾಂಡ್, ಇದು ರೆಸೊನೆನ್ಸ್ನಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಅದರಿಗೋಸ್ಕರ ಸಿಂಗಲ್ ಬಾಂಡ್ ಲೆಂಗ್ತ್ ಯಾವಾಗಲೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಡಬಲ್ ಬಾಂಡ್ಗಿಂತ, ಅಂದರೆ ಎಕ್ಸ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ವೈ. ಸೊ ಇಟ್ ಈಸ್ ಆಪ್ಷನ್ ನಂಬರ್ 1. Next question. Identify the incorrect statement. ಇದರಲ್ಲಿ ಸ್ಟೇಟ್ಮೆಂಟ್ನಲ್ಲಿ ಫಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಏನು ಅಂತ ಅಂದರೆ, ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ MnO4-2 undergoes disproportionation. ಮ್ಯಾಂಗನೀಸ್ ನಮಗೆ ಏನು ಮಾಡ್ತಾ ಇದೆ, Mn+2 ರಿಂದ +7 ವರೆಗೂ ಕೂಡ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸನ್ನು ಇಲ್ಲಿ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತಾ ಇದೆ. ಇದರಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಏನಿದೆ ಅದು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. ಲೋವೆಸ್ಟ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಇದು ಲೋವೆಸ್ಟ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. ಉಳಿದಿದ್ದ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಏನದಾವೆ ಇವೆಲ್ಲ ಕೂಡ ದೇ ಆಕ್ಚುಲಿ ವರ್ಕ್ ಆಸ್ ಬೋತ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ and reducing agents. So, ಇವು ಏನಾಗ್ತವೆ, they can undergo disproportionation. So, disproportionation ಅಂದರೆ ಅರ್ಥ ಏನು, it should undergo, the substance should undergo, a single oxidation state should undergo both oxidation and reduction. That can happen for the intermediate oxidation states. Where in the manganate ion, the oxidation state is +6. ಅಂದರೆ the intermediate of +2 and +7. So it definitely can undergo disproportionation reaction. So ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಯಾವಾಗಾದರೂ ಒಂದು ಎಲಿಮೆಂಟ್ ಮಲ್ಟಿಪಲ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತಿರೋದಾಗ ಹೈಯೆಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಯಾವುದಿರುತ್ತೆ ಅದು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗುತ್ತೆ. ಲೋವೆಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಏನಿರುತ್ತೆ ಅದು ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗುತ್ತೆ. ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಎಲ್ಲ ಕೂಡ ದೇ ಕ್ಯಾನ್ ಆಕ್ಟ್ ಎಸ್ ಬೋತ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಆ್ಯಂಡ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ಸ್, therefore they can undergo disproportionation. So ಮ್ಯಾಂಗನೇಟ್ ಕೂಡ ಅದೇ ಥರ ನ್ಯೂಟ್ರಲ್ ಮೀಡಿಯಮ್ದಲ್ಲಿ it can undergo oxidation as well as reduction. So it definitely can undergo disproportionation. Next one, second statement. The oxidizing ability of permanganate changes when pH of the medium is changed. Definitely. ಯಾಕಂದರೆ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಅನ್ನೋದು ಎಸಿಡಿಕ್ ಮೀಡಿಯಮ್ನಲ್ಲಿ Mn+2 ಆಗುತ್ತೆ. ಸ್ಟ್ರಾಂಗ್ಲಿ ಆಲ್ಕಲೈನ್ ಮೀಡಿಯಮ್ನಲ್ಲಿ MnO4-2 ಆಗುತ್ತೆ. ವೀಕ್ಲಿ ಆಲ್ಕಲೈನ್ ಮೀಡಿಯಮ್ದಲ್ಲಿ MnO2 ಆಗುತ್ತೆ. ದೇರ್ಫೋರ್ ಡೆಫಿನೆಟ್ಲಿ pH ಚೇಂಜ್ ಆದರೆ ಖಂಡಿತ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಬಿಹೇವಿಯರ್ನಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಬರುತ್ತೆ. ಸೊ ದೇರ್ಫೋರ್ ಆಕ್ಸಿಡೇಷನ್ ಎಬಿಲಿಟಿ ಆಫ್ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ pH ಅನ್ನೋದರಲ್ಲಿ ಏನೇ ತಪ್ಪಿಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್, KMnO4 when heated decomposes to give K2MnO4, MnO2 and O2. ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟನ್ನು 513 ಕೆಲ್ವಿನ್ ಹತ್ತಿರ ನಾವು ಹೀಟ್ ಮಾಡಿದಾಗ ಪೊಟ್ಯಾಷಿಯಂ ಮ್ಯಾಂಗನೇಟ್, ಮ್ಯಾಂಗನೀಸ್ ಡೈಆಕ್ಸೈಡ್, ಆಕ್ಸಿಜನ್ ಇವು ಎಲ್ಲ ಕೂಡ ನಮಗೆ ಕೊಡ್ತಾ ಇದೆ. ಈ ಹೀಟಿಂಗ್ನಲ್ಲಿ ಇವೆಲ್ಲ ಬಂದಿದ್ದಾಗ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್ ಇಸ್ ಡೆಫಿನೆಟ್ಲಿ K2MnO4, MnO2, O2 ಬರ್ತವೆ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಸೊ ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೂಡ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟೇ. ನೆಕ್ಸ್ಟ್ ಒನ್, HCl is better medium for oxidizing action of potassium permanganate. ಸೊ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಅನ್ನು ತಗೊಂಡಿದ್ದಾಗ ಇದಕ್ಕೆ ಮೀಡಿಯಮ್ ಎಸಿಡಿಕ್ ಮೀಡಿಯಮ್ನಲ್ಲಿ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡನ್ನು ಮಾತ್ರ ಹಾಕಬೇಕು, HCl ಅನ್ನು ಹಾಕಬಾರ್ದು. ಯಾಕಂದರೆ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಏನಿದೆ ಇದಕ್ಕೆ ನಾನು HCl ಅನ್ನು ಹಾಕಿದರೆ HClನಲ್ಲಿರುವ ಕ್ಲೋರೈಡನ್ನು ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಅನ್ನೋದು ಕ್ಲೋರಿನ್ ಆಗಿ ಆಕ್ಸಿಡೈಸ್ ಮಾಡುತ್ತೆ. ಮೀಡಿಯಮ್ ಆಗಿ ಯಾವುದು ಇನ್ವಾಲ್ವ್ ಆಗ್ತಾ ಇದೆ ಅದು ರಿಯಾಕ್ಟ್ ಆಗಲೇಬಾರದು, ಮೀಡಿಯಮ್ ರಿಯಾಕ್ಟ್ ಆಗಬಾರ್ದು. ಇಲ್ಲಿ ಮೀಡಿಯಮ್ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಅದಕ್ಕೆ HCl ಕ್ಯಾನ್ ನಾಟ್ ಬಿ ಅ ಬೆಟರ್ ಮೀಡಿಯಮ್ ಫಾರ್ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್, ರಾದರ್ H2SO4 ವುಡ್ ಬಿ. Therefore the false statement is a fourth statement. Fourth statement is a false statement. And let's go to the next question. The next question is, study of actinoids is complicated. Assertion A, ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? Study of actinoids is complicated ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Yes, it is a true statement. Reasons ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? Actinoids exhibit variable oxidation states. ಇದು ಕೂಡ ಒಂದು ರೀಸನ್ನೇ ಅದಕ್ಕೆ. ಇನ್ನೊಂದು ರೀಸನ್ ಏನು? Actinoids have very short half lives. They are all radioactive in nature. ಅವು ರೇಡಿಯೋ ಆ್ಯಕ್ಟಿವ್ ಇರ್ತವೆ, ಅವುಗಳಕ್ಕೆ ಶಾರ್ಟ್ ಹಾಫ್ ಲೈಫ್ಸ್ ಅದಾವೆ. ಈ ಕಾರಣಗಳಿಂದ ಅವುಗಳನ್ನು ಡಿಟೆಕ್ಟ್ ಮಾಡೋದು, ಅದರ ಮೇಲೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ಮಾಡೋದು ತುಂಬ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ. ಕಾರಣ ಏನಂದರೆ ಅವು ಮೆಷರ್ ಮಾಡಿ ನಾವು ಅದರ ಮೇಲೆ ಇನ್ವೆಸ್ಟಿಗೇಷನ್ ಮಾಡೋ ತಲಕೆ ಹಾಫ್ ಲೈಫ್ಸ್ ಆಗ್ತಾ ಆಗ್ತಾ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನೋದು ತುಂಬ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಅವು ಸಿಗೋದೇ ನ್ಯಾನೋಗ್ರಾಮ್ ಕ್ವಾಂಟಿಟೀಸ್ನಲ್ಲಿ ಸಿಗ್ತವೆ. ಈ ಕಾರಣಗಳಿಂದ ಅಸರ್ಷನ್ ಇಸ್ ಟ್ರೂ, reason is also true because actinoids exhibit variable oxidation states, and reason also explains assertion. But main reason adalla. Main reason bandbittu radioactivity. Second reason oxidation states variable irodu. Let's go to the next one. Ytterbium plus 2 is a reducing agent while europium plus 2 is an oxidizing agent. Another statement kottidare. Idu tappu. When we consider the reducing and oxidizing agents in the list of lanthanides, plus 4 oxidation states annu torsuva ella kuda, they all become oxidizing agents. So cerium plus 4, praseodymium plus 4, neodymium plus 4, terbium plus 4, dysprosium plus 4. ಈ 4 ಎಲಿಮೆಂಟ್ಸು ಕೂಡ ಪ್ರಸಿಡಿಮಿಯಂ, ನಿಯೋಡಿಮಿಯಂ, ಟರ್ಬಿಯಂ, ಡಿಸ್ಪ್ರಾಷಿಯಂ ಈ 4 ಕೂಡ +4 ಸ್ಟೇಟನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತವೆ ಎಲಾಂಗ್ ವಿತ್ ಸೀರಿಯಂ +4. ಆದರೆ ಇದರಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಏನಂತಂದರೆ ಸೀರಿಯಂ +4 ಈಸ್ ಓನ್ಲಿ ಎಕ್ಸಿಬಿಟೆಡ್ ಇನ್ ವಿಚ್ ಮೀಡಿಯಂ? ಐ ಮೀನ್ ಇನ್ aqueous solutions and also in solid state, but in all or many compounds of it. Many compounds of cerium dalli ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ. ವೆರಾಸ್ ಪ್ರಾಸಿಡಿಮಿಯಂ, ನಿಯೋಡಿಮಿಯಂ, ಟರ್ಬಿಯಂ, ಡಿಸ್ಪ್ರಾಷಿಯಂ ಈ 4 ಎಲಿಮೆಂಟ್ಸ್ ಏನದಾವೆ, ಈ 4 ಎಲಿಮೆಂಟ್ಸ್ ಕೂಡ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಇವುಗಳು ಮಾತ್ರ ದೇ ಓನ್ಲಿ ಆರ್ ಎಕ್ಸಿಬಿಟೆಡ್ ಇನ್ ದೇರ್ ಆಕ್ಸೈಡ್ಸ್ ಫಾರ್ಮ್ನಲ್ಲಿ ಮಾತ್ರ ಇವು ಈ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟನ್ನು ತೋರಿಸ್ತವೆ. ಈ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟನ್ನು ಯಾವುದು ತೋರಿಸ್ತಾ ಇದೆ? ಅದು ಖಂಡಿತ +3ಗೆ ರಿವರ್ಟ್ ಆಗುತ್ತೆ. ಆ ಥರ ರಿವರ್ಟ್ ಆಗಬೇಕು ಅಂತಂದರೆ ಅದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಗೈನ್ ಮಾಡಿ ಇರಬೇಕು. ಎಲೆಕ್ಟ್ರಾನನ್ನು ಗೈನ್ ಮಾಡ್ತಾ ಇದೆ ಅಂತಂದರೆ ಅದು ಖಂಡಿತ ರಿಡಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ. ಅದು ರಿಡಕ್ಷನ್ ಆಗಬೇಕಂದ್ರೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಬೇಕು. ಸೊ ಇವು ಮಾತ್ರ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ವರ್ಕ್ ಆಗ್ತವೆ. ವೆರಾಸ್ ಯುರೋಪಿಯಂ +2, ಸಮೇರಿಯಂ +2, ಇಟರ್ಬಿಯಂ +2, ಯುರೋಪಿಯಂ, ಸಮೇರಿಯಂ, ಇಟರ್ಬಿಯಂ ಈ 3 ಎಲಿಮೆಂಟ್ಸ್ ಮಾತ್ರ ದೇ ಆ್ಯಕ್ಚುಲಿ ಬಿಕಮ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಬಿಕಾಸ್ they convert themselves to +3. While doing so, they lose an electron. ಆ ಥರ ಒಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಕಳ್ಕೊಳ್ತಾ ಇರೋದ್ರಿಂದ we have to understand that all of these 3 elements, they actually lose electron, so they undergo oxidation and hence they become reducing agents. So ಯಾವ ಲ್ಯಾಂಥನೈಡ್ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ಈ ಥರ ಬಿಹೇವ್ ಮಾಡ್ತಿರೋದಂದರೆ ಪ್ರಾಸಿಡಿಮಿಯಂ, ನಿಯೋಡಿಮಿಯಂ, ಟರ್ಬಿಯಂ, ಡಿಸ್ಪ್ರಾಷಿಯಂ, ಸೀರಿಯಂ +4 ಸ್ಟೇಟ್ನಲ್ಲಿ they actually act as oxidizing agents. Samarium, ytterbium, europium ಈ 3 ಎಲಿಮೆಂಟ್ಸ್ ಮಾತ್ರ they behave as reducing agents. ಇವು ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿದ್ದ ವಿಷಯ. ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಗೆ ಹೋಗೋಣ. Next statement. Cerium plus 4 is blue. So first statement ಏನಾಯಿತು, ytterbium plus 2 is reducing agent, correct. Europium plus 2 is oxidizing agent ಅನ್ನೋದು ತಪ್ಪು ಸ್ಟೇಟ್ಮೆಂಟ್. therefore ಓವರಾಲ್ ಆಗಿ ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ ತಪ್ಪಂತ ಹೇಳಬೇಕಾಗತ್ತೆ. ಈವನ್ ಪಾರ್ಷಿಯಲಿ ಕರೆಕ್ಟ್ ಆದರೂ ಅದು ತಪ್ಪೇ ಆಗುತ್ತೆ. Cerium plus 4 is blue while lutetium plus 3 is colorless. ಇದು ಸ್ಟೇಟ್ಮೆಂಟ್. ಇದನ್ನು ಅನಲೈಸ್ ಮಾಡೋಣ. Cerium plus 4 ಅನ್ನೋದು ಆ್ಯಕ್ಚುಲಿ ಬ್ಲೂ ಅಲ್ಲ. Cerium plus 4 compounds are orange. ಆ್ಯಕ್ಚುಲಿ ಅದಕ್ಕೆ ಯಾವುದೇ ಕಲರ್ ಇರಬಾರ್ದು. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ Cerium plus 4ಗೆ ಯಾವುದೇ ಕಲರ್ ಇರಬಾರ್ದು. ಯಾಕೆ ಇರಬಾರ್ದು ಅಂತಂದರೆ ಇದರದ್ದು xenon ಕಾನ್ಫಿಗರೇಷನ್ ಅಂದರೆ ನೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಎಫ್ ಆರ್ ಡಿ ಆರ್ ಎಸ್. ಮತ್ತು ಯಾವುದೇ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಲಾರ್ದಾಗ ಇದು ಕಲರ್ ಹೇಗಾಯಿತು ಅಂತಂದರೆ ಇಟ್ ಈಸ್ ಡ್ಯೂ ಟು ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಸ್ಪೆಕ್ಟ್ರಮ್. Okay, therefore cerium plus 4 is not blue in color. That is a false statement. While lutetium plus 3 is colorless. Lutetium plus 3 is anyway colorless. That's the correct statement. ಯಾಕಂದರೆ lutetium plus 3 electronic configuration ಬಂದ್ಬಿಟ್ಟು xenon 4f14. 5D ಮತ್ತು 6sಗಳಲ್ಲಿ ಯಾವುದೇ ತರಹದ ಚಾರ್ಜ್ ಇಲ್ಲ, ಅಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲ. ಹಾಗಾಗಿ xenon 4f14 ಅನ್ನೋದು ಕಲರ್ಲೆಸ್ ಅಂತ ಹೇಳಬೇಕಾಗ್ತಾ ಇದೆ. ಇದು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿತ್ತು. ಲೆಟ್ಸ್ ಗೋ ಅಹೆಡ್ ವಿತ್ ದ ನೆಕ್ಸ್ಟ್ ಒನ್. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ 2 ಈಸ್ ಆ್ಯಕ್ಚುಲಿ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬಿಕಾಸ್ ಪಾರ್ಷಿಯಲಿ ಇಟ್ ಈಸ್ ಟ್ರೂ, ಪಾರ್ಷಿಯಲಿ ಇಟ್ ಈಸ್ ಫಾಲ್ಸ್. ಪಾರ್ಷಿಯಲಿ ಫಾಲ್ಸ್ ಅಂದರೆ ಫಾಲ್ಸೇ ಅದು. ಎಕ್ಸ್ಕ್ಯೂಸ್ ಮಿ. ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್. Mixed oxides of lanthanides are catalysts for petroleum cracking. ಇದು ಕರೆಕ್ಟ್. ಮಿಕ್ಸ್ಡ್ ಆಕ್ಸೈಡ್ಸ್ ಆಫ್ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಏನದಾವೆ ಅಂದರೆ ನಾನು 56th ಕ್ವೆಶ್ಚನ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಮಿಕ್ಸ್ಡ್ ಆಕ್ಸೈಡ್ಸ್ ಆಫ್ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಆರ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಫಾರ್ ಪೆಟ್ರೋಲಿಯಂ ಕ್ರ್ಯಾಕಿಂಗ್. ಪೆಟ್ರೋಲಿಯಂ ಕ್ರ್ಯಾಕಿಂಗ್ ಪ್ರಾಸೆಸ್ನಲ್ಲಿ ಅಂದರೆ ಹೈಯರ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಆಫ್ ಪೆಟ್ರೋಲಿಯಂ ಎಲ್ಲಿಂದ ಒಬ್ಟೈನ್ ಆಗಿರುವ ಹೈಯರ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸನ್ನು ಚಿಕ್ಕ ಚಿಕ್ಕ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಯೂಸ್ಫುಲ್ ಕಾರ್ಬನ್ಸ್ ಆಗಿ ಮಾಡುವ ವಿಷಯದಲ್ಲಿ ಖಂಡಿತ ಕೆಟಲಿಸ್ಟ್ ಬೇಕಾಗಿದ್ದಾವೆ. ಅದಕ್ಕೆ ಮಿಕ್ಸ್ಡ್ ಆಕ್ಸೈಡ್ಸ್ ಆಫ್ ಲ್ಯಾಂಥನೈಡ್ಸನ್ನು ಈ ಥರ ತಗೊಳ್ತಾರೆ. ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಇಂಡಿವಿಜುವಲ್ ಲ್ಯಾಂಥನೈಡ್ ಆಕ್ಸೈಡ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಆ್ಯಸ್ ಫಾಸ್ಫಾರ್ಸ್ ಇನ್ ಟಿ ವಿ ಸ್ಕ್ರೀನ್ಸ್. ಅದು ಕೂಡ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಯಾಕಂದರೆ ಇಂಡಿವಿಜುವಲ್ ಆಕ್ಸೈಡ್ಸ್ ಏನದಾವೆ ದೇ ಪೊಸೆಸ್ ಫಾಸ್ಫಾರಸೆಂಟ್ ಪ್ರಾಪರ್ಟೀಸ್. ಫಾಸ್ಫಾರಸೆಂಟ್ ಪ್ರಾಪರ್ಟಿ ಅಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ದೊಂದಿಗೆ ನಾವು ಆ ಸಬ್ಸ್ಟೆನ್ಸನ್ನು ಹೊಡೆದಿದ್ದಾಗ ಇಟ್ ಆ್ಯಕ್ಚುಲಿ ಗಿವ್ಸ್ ಸ್ಪಾರ್ಕ್ಸ್ ಆನ್ ಇಟ್. ಆ ತರಹದ ಸಿಂಟಿಲೇಷನ್ಸನ್ನು ಕೊಡ್ತಾ ಇದೆ, ಸ್ಪಾರ್ಕ್ಸನ್ನು ಕೊಡ್ತಾ ಇದೆ. ಅದಕ್ಕೆ ಅದನ್ನು ನಾವು ಖಂಡಿತ ಇಟ್ ಈಸ್ ಡೆಫಿನೆಟ್ಲಿ ಅ ಕೈಂಡ್ ಆಫ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದಿಸ್ ಅಂತ ನಾವು ಅನ್ಕೋಬೋದು. ದೇರ್ ಫಾರ್ ಇಂಡಿವಿಜುವಲ್ ಲ್ಯಾಂಥನೈಡ್ ಆಕ್ಸೈಡ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಆಸ್ ಫಾಸ್ಫಾರ್ಸ್ ಆ್ಯಂಡ್ ದೇ ಆರ್ ಯೂಸ್ಡ್ ಇನ್ ಟಿ ವಿ ಸ್ಕ್ರೀನ್ಸ್. ಇದು ಕರೆಕ್ಟ್. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ 1 is true. Statement 2 is also true. Next statement. Dichromate and Cr+3 ಅವುಗಳ SRP ವ್ಯಾಲ್ಯೂಸನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರಿಂದ ನಾವು ಏನು ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ಬೋದು ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್ ಇಲ್ಲಿ. ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ನಲ್ಲಿ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಆ್ಯಂಡ್ ಸೀರಿಯಂ +4 ಕ್ಯಾನ್ ಆಕ್ಸಿಡೈಸ್ ವಾಟರ್. ಎಸ್, ಅದು ಕರೆಕ್ಟ್. ಬೇಕಂದರೆ ವಾಟರಿನ SRP ವ್ಯಾಲ್ಯೂ 1.23 ಇದೆ. ಉಳಿದ ಎರಡಿನ SRP ವ್ಯಾಲ್ಯೂಸ್ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅದಾವೆ. ಹೈಯರ್ SRP ಇರುವ ಒಂದು ಎಲಿಮೆಂಟ್ ಖಂಡಿತ ತನಕ್ಕಿಂತ ಲೋವರ್ SRP ಇರುವ ಇನ್ನೊಂದು ಎಲಿಮೆಂಟನ್ನು ಖಂಡಿತ ಇಟ್ ಕ್ಯಾನ್ ಡೆಫಿನೆಟ್ಲಿ ಆಕ್ಸಿಡೈಸ್, ಎಸ್ಪೆಷಲಿ ಇನ್ ದ ಆಕ್ಸಿಡೈಸ್ಡ್ ಫಾರ್ಮ್. ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಆಕ್ಸಿಡೈಸ್ಡ್ ಫಾರ್ಮ್ನಲ್ಲಿದೆ, Cr+4 ಆಕ್ಸಿಡೈಸ್ಡ್ ಫಾರ್ಮ್ ಇದೆ. ಯಾವುದು ಆಕ್ಸಿಡೈಸ್ ಆಗ್ತಾ ಇದೆ ಅದು ರೆಡ್ಯೂಸ್ಡ್ ಫಾರ್ಮ್ನಲ್ಲಿದೆ. ಸೊ ಪರ್ಫೆಕ್ಟ್ ಆಗಿದೆ, ಅದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಬಿ, ದ ರಿಯಾಕ್ಷನ್ ಬಿಟ್ವೀನ್ Cr+4 ಆ್ಯಂಡ್ ವಾಟರ್ ಈಸ್ ಫಾಸ್ಟ್. ನೋ, ಸ್ಪಷ್ಟವಾಗಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ನಲ್ಲಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಆಕ್ಸಿಡೇಷನ್ ಆಫ್ ವಾಟರ್ ಬೈ Cr+4 ಆ್ಯಂಡ್ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಈಸ್ ಅ ವೆರಿ ಸ್ಲೋ ರಿಯಾಕ್ಷನ್. ನೋ, ಇಟ್ ಈಸ್ ನಾಟ್ ಫಾಸ್ಟ್. ಇದು ಥರ್ಮೋಡೈನಮಿಕಲಿ ಫೀಸಿಬಲ್ ಆದರೂ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕಲಿ ಸ್ಲೋ. Cr+4 is the strongest oxidizing agent. Cr+4 ಏನಿದೆ ಅದು ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟೇ, ಯಾಕಂದರೆ ಇದ್ದಿದ್ರಲ್ಲಿ ಅದಕ್ಕೆ ಹೈಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ, SRP ವ್ಯಾಲ್ಯೂ. The oxidizing power can be compared as dichromate, permanganate, Cr+4, permanganate. ಇದು ತಪ್ಪು ಆರ್ಡರ್, ಯಾಕಂದರೆ ಡೈಕ್ರೋಮೇಟ್ಗೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ SRP ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ಇದೆ, ದಟ್ ಕಾನ್ ಬಿಕಮ್ ದ ಪವರ್ಫುಲ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್. ಇನ್ಸ್ಟೆಡ್ ಇದು ಇಲ್ಲಿ ಬಂದರೆ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ ಡಿ ಈಸ್ ಫಾಲ್ಸ್, ಬಟ್ ಎ ಬಿ ಸಿ ಆರ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ 58th ಕ್ವೆಶ್ಚನ್ ಸ್ಟಡಿ ಮಾಡೋಣ. ದ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ Neptunium and plutonium exhibit the least oxidation states among actinoids. Neptunium and plutonium least ಅಲ್ಲ, highest oxidation states ಆದ +7 ಅನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತವೆ. ಸೊ ಅದು ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. Actinoid contraction is greater from element to element compared to lanthanoid contraction. ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಯಾಕಂದರೆ ಆಕ್ಟಿನಾಯ್ಡ್ಸ್ನಲ್ಲಿ ನಮಗೆ ಪೋರರ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಇರುತ್ತೆ ಕಂಪೇರ್ಡ್ ಟು ಲ್ಯಾಂಥನಾಯ್ಡ್ಸ್. ಈ ಪೋರರ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಆಫ್ 5f ಆರ್ಬಿಟಾಲ್ಸ್ ಇರೋದ್ರಿಂದ ಕಾಂಟ್ರಾಕ್ಷನ್ ಅಕ್ಕರ್ಸ್ ಮೋರ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಆಕ್ಟಿನಾಯ್ಡ್ಸ್. ದಟ್ಸ್ ಅ ಟ್ರೂ ಸ್ಟೇಟ್ಮೆಂಟ್. ಆಲ್ ಆಕ್ಟಿನಾಯ್ಡ್ಸ್ ರಿಯಾಕ್ಟ್ ವಿತ್ ನೈಟ್ರಿಕ್ ಆ್ಯಸಿಡ್. ಆಕ್ಟಿನಾಯ್ಡ್ಸ್ ಅನ್ನೋವು ನೈಟ್ರಿಕ್ ಆ್ಯಸಿಡ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ. ಕಾರಣ ಏನಂದರೆ ಆಕ್ಟಿನಾಯ್ಡಿನ ಸರ್ಫೇಸ್ ಮೇಲೆ ಒಂದು ಪ್ರೊಟೆಕ್ಟಿವ್ ಆಕ್ಸೈಡ್ ಫಿಲ್ಮ್ ಇರುವುದರಿಂದ ನೈಟ್ರಿಕ್ ಆ್ಯಸಿಡ್ ಅದರ ಮೇಲೆ ಬಿದ್ದರೂ ಕೂಡ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ. ಸೊ ನೈಟ್ರಿಕ್ ಆ್ಯಸಿಡ್ ಡಸ್ ನಾಟ್ ರಿಯಾಕ್ಟ್ ವಿತ್ actinides due to a protective oxide film on the surface of actinide anta tilkobeku. Next one, magnetic susceptibilities of actinoids are higher than that of lanthanoids is a wrong statement. Lanthanoids ke magnetic susceptibility ಅನ್ನೋದು ಖಂಡಿತ ಜಾಸ್ತಿ ಇರುತ್ತೆ, therefore actinoids ke iralla. ಇವು ಸ್ಟೇಟ್ಮೆಂಟ್. therefore ನಮಗೆ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಬಂದ್ಬಿಟ್ಟು ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್. Moving on. Photosensitive compound is ಯಾವುದು photosensitive compound ಅಂದರೆ ಲೈಟ್ ಸೆನ್ಸಿಟಿವ್ ಯಾವುದಿದೆ? ಸಿಲ್ವರ್ ಬ್ರೋಮೈಡ್, ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್, ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್, ಫೆರಸ್ ಸಲ್ಫೇಟ್. ಈ ನಾಲ್ಕು ಕೂಡ when we consider ಅದರಲ್ಲಿ ಸಿಲ್ವರ್ ಬ್ರೋಮೈಡ್ is a photosensitive compound and it is used in black and white photography also. Next one, hybridization of chromium ions in chromate and dichromate ions is respectively. ಎರಡರಲ್ಲಿ ಕೂಡ ಡೈಕ್ರೋಮೇಟ್ ಮತ್ತು ಕ್ರೋಮೇಟ್ ಎರಡೂ ಕೂಡ ಟೆಟ್ರಾಹೀಡ್ರನ್ಸೇ. ಟೆಟ್ರಾಹೀಡ್ರನ್ಸ್ ಅಂದರೆ sp3 ಹೈಬ್ರಿಡೈಸೇಷನೇ. ಅದರಲ್ಲಿ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಯೂಸ್ ಮಾಡಿ DP ಪೈ ಬಾಂಡ್ಸ್ ಫಾರ್ಮ್ ಮಾಡಿದರೂ ಕೂಡ sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್, ಟೆಟ್ರಾಹೀಡ್ರಲ್ ಸ್ಟ್ರಕ್ಚರ್, ಬೋತ್ ಡೈಕ್ರೋಮೇಟ್ ಆ್ಯಂಡ್ ಕ್ರೋಮೇಟ್. ಡೈಕ್ರೋಮೇಟ್ ಇಸ್ ಡಬಲ್ ಟೆಟ್ರಾಹೈಡ್ರನ್, ಎರಡು ಟೆಟ್ರಾಹೈಡ್ರನ್ನು ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ದಾಗ ಬಂದಿದ್ದು. therefore ಎರಡು ಟೆಟ್ರಾಹೈಡ್ರಲ್ಲೇ, ಎರಡು sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್. 61st next question, which is colored because of DD transition. ಯಾವುದು DD ಟ್ರಾನ್ಸಿಷನ್ ದೊಂದಿಗೆ ಕಲರ್ಡ್ ಆಗಿದೆ ಅಂತಂದರೆ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ನೋಡಿ, ಅದರಲ್ಲಿ ಯಾವುದೇ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲ, +7 ಸ್ಟೇಟ್ ಅದರಲ್ಲಿ. ಸೊ ಯಾವಾಗ DD ಟ್ರಾನ್ಸಿಷನ್ನೊಂದಿಗೆ ಕಲರ್ ಬರುತ್ತೆ ಅಂದರೆ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದಾಗ. ಯಾವಾಗ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಲ್ಲ ಆದರೂ ಕೂಡ ಕಲರ್ ಬಂದಿದೆ, ಆ ಕಾಂಟೆಕ್ಸ್ಟ್ನಲ್ಲಿ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಎಲಿಮೆಂಟ್ನಲ್ಲಿ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಅಬ್ಸರ್ವ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. ಸೊ ನಮಗೆ ಕ್ವೆಶ್ಚನ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ವಿಚ್ ಈಸ್ ಕಲರ್ಡ್ ಡ್ಯೂ ಟು ಡಿ ಡಿ ಟ್ರಾನ್ಸಿಷನ್ ಅಂತಿದ್ದಾರೆ. ಅದರಲ್ಲಿ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇದರಲ್ಲಿ ಚಾರ್ಜ್ Mn+7 ಆದರೆ ಅದರಲ್ಲಿ ಕಾನ್ಫಿಗರೇಷನ್ ಆರ್ಗಾನ್, ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 0 ಅದಾವೆ. ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸೇ ಇಲ್ಲ ಅಂದರೆ ಅದು ಕಲರ್ಡ್ ಆಗಬಾರ್ದು, ಆದರೂ ಕೂಡ ಪರ್ಪಲ್ ಕಲರ್ ಬರುತ್ತೆ. ದೇರ್ಫೋರ್ ಇದು ಡಿ ಡಿ ಟ್ರಾನ್ಸಿಷನ್ದಿಂದ ಅಲ್ಲ, ಇಟ್ ಈಸ್ ಡ್ಯೂ ಟು ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಸ್ಪೆಕ್ಟ್ರಮ್. ನೆಕ್ಸ್ಟ್ ಒನ್ ಪೊಟ್ಯಾಷಿಯಂ ಕ್ರೋಮೇಟ್. ಪೊಟ್ಯಾಷಿಯಂ ಕ್ರೋಮೇಟನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾಗ ಅದರಲ್ಲಿ ಕ್ರೋಮಿಯಮಿನ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ +6 ಬಂದಿದೆ, ಅದರಲ್ಲಿ ಕೂಡ ಆರ್ಗಾನ್ ಕಾನ್ಫಿಗರೇಷನ್ ಇದೆ, ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 0 ಅದಾವೆ. ದೇರ್ ಫೋರ್ ವಿ ನೀಡ್ ಟು ಸೇ ಇದು ಕೂಡ ಯೆಲ್ಲೋ ಕಲರ್ಡ್ ಕಂಪೌಂಡ್, ಆದರೂ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲದೇ ಇಲ್ಲ ಅಂದರೆ ಇದು ಕೂಡ ಡಿ ಡಿ ಟ್ರಾನ್ಸಿಷನ್ ಅಲ್ಲ, ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಸ್ಪೆಕ್ಟ್ರಮ್. COCl3 ಕೊಬಾಲ್ಟ್ +3 ಅಂದರೆ 3d6 ಕಾನ್ಫಿಗರೇಷನ್. ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 4 ಅದಾವೆ, ಕಲರ್ಡ್ ಆಗುತ್ತೆ ಡ್ಯೂ ಟು ಡಿ ಡಿ ಟ್ರಾನ್ಸಿಷನ್. ಸೊ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದು ಕಲರ್ಡ್ ಆದರೆ ಡಿ ಡಿ ಟ್ರಾನ್ಸಿಷನ್ದಿಂದ, ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಲಾರ್ದ ಕಲರ್ ಬಂದರೆ ಅದು ಡ್ಯೂ ಟು ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಅಂತ ತಿಳ್ಕೋಬೇಕಾಗತ್ತೆ. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್. Next question. General electronic configuration of actinides can be shown as. Electronic configuration of actinides ಯಾವುದು ಬರುತ್ತೆ ಅಂತ ನಾವು ವಿಚಾರ ಮಾಡಿದರೆ ಅವು 5Fಗೆ ಸಂಬಂಧಪಟ್ಟಂಥದ್ದು. 5F ಅಂದರೆ 6 - 2 5 ಬರಲ್ಲ, 7 - 2 ಬರುತ್ತೆ. ಸೊ ಆಪ್ಷನ್ 3 ಆರ್ ಆಪ್ಷನ್ 4 ಆಗಿರಬೇಕು. ನೆಕ್ಸ್ಟ್ 1 to 14 ಇಸ್ ಫೈನ್, ಅದರಲ್ಲಿ ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಮತ್ತು 7 - 1 D1 to 10 ಅದು ತಪ್ಪು, ಅದರಲ್ಲಿ 0 or 1 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮಾತ್ರ ಇರ್ತವೆ. ದೇರ್ಫೋರ್ ಆಪ್ಷನ್ ನಂಬರ್ 4 ಈಸ್ ಪರ್ಫೆಕ್ಟ್ ಆನ್ಸರ್. 63rd next question. Manganate in acidic medium undergoes disproportionation to give. ಮ್ಯಾಂಗನೇಟ್ ಅನ್ನೋದು ಡಿಸ್ಪ್ರಪೋರ್ಷನೇಷನ್ ಆಗಿ ಎಸಿಡಿಕ್ ಮೀಡಿಯಮ್ನಲ್ಲಿ ಏನೇನು ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ, ಇದು ಪ್ರಿಪರೇಷನ್ ಆಫ್ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್ರಿಂದ. ಮ್ಯಾಂಗನೇಟ್ ಅನ್ನೋದು ಈ ಥರ ಆದರೆ ಅಂದರೆ ಇಫ್ ಇಟ್ ಅಂಡರ್ಗೋಸ್ ಡಿಸ್ಪ್ರಪೋರ್ಷನೇಷನ್ ಇಟ್ ಫಾರ್ಮ್ಸ್ MnO4- ಆ್ಯಂಡ್ MnO2 ಇವು ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಒನ್, ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಟೈಟ್ರೇಷನ್ಸ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಹೈಡ್ರೋಕ್ಲೋರಿಕ್ ಆ್ಯಸಿಡ್ ಆರ್ ಅನ್ಸ್ಯಾಟಿಸ್ಫ್ಯಾಕ್ಟರಿ ಬಿಕಾಸ್. ಇದು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ ನಾನು. ಈ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಅನ್ನೋದು ಕ್ಲೋರೈಡ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಅದನ್ನು ಕ್ಲೋರಿನ್ ಮಾಡಿ ಪರ್ಮ್ಯಾಂಗನೇಟನ್ನು Mn+2 ಮಾಡುತ್ತೆ. ಹಾಗಾಗಿ ನಾವು ಇದನ್ನು ಈ ಥರ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ದೇರ್ ಫಾರ್ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಟೈಟ್ರೇಷನ್ಸ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಹೈಡ್ರೋಕ್ಲೋರಿಕ್ ಆ್ಯಸಿಡ್ ಆರ್ ಅನ್ಸ್ಯಾಟಿಸ್ಫ್ಯಾಕ್ಟರಿ ಸಿನ್ಸ್ hydrochloric acid is oxidized to hydrogen, hydrochloric acid is oxidized to chlorine, hydrochloric acid is highly volatile in nature, hydrochloric acid forms salt with permanganate ion. Therefore the answer is hydrochloric acid is oxidized to chlorine. Option number 2 is correct answer. Let's go to the next question. The value of spin-only magnetic moment in Bohr magneton for a transition metal of 3D transition series is 4.89. Its electronic configuration is. Electronic configuration ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ 4.89 ನಿನ್ನೆ ಮಾಡಿದ್ವಿದೆ ಕ್ವೆಶ್ಚನ್. ಅಂದರೆ 4.89 ಅಂದರೆ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 4 ಅದಾವಂತ ಅರ್ಥ. ಆ ಥರ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 4 ಇರಬೇಕಂದ್ರೆ 3d5 4s2ನಲ್ಲಿ 4 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಲ್ಲ, 5 ಇರ್ತವೆ. 3d6 4s2ನಲ್ಲಿ ಖಂಡಿತ 4 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರ್ತವೆ. ಸೊ ಆಪ್ಷನ್ 2 ಈಸ್ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೆಕ್ಸ್ಟ್ ಒನ್, 66th question. Identify the paramagnetic lanthanoid ion among the following. ಯಾವುದು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಲ್ಯಾಂಥನಾಯ್ಡ್ ಅಯಾನ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಲ್ಯಾಂಥನಾಯ್ಡ್ ಅಯಾನನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾಗ ಸೀರಿಯಂ +4, ಸೀರಿಯಂ +4ನಲ್ಲಿ ಕಾನ್ಫಿಗರೇಷನ್ ಝೆನಾನ್. ಸೊ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲವೇ ಇಲ್ಲ, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಹೆಂಗಾಗತ್ತೆ ಅದು? ಆಗ್ಲಿಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ. ಲ್ಯಾಂಥನಮ್ +3, ಲ್ಯಾಂಥನಮ್ +3 ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಕೂಡ ಕ್ಸೆನಾನಿನ ಕಾನ್ಫಿಗರೇಷನ್, ಸೊ ಅದು ಕೂಡ ಬರಲ್ಲ. ಯುರೋಪಿಯಂ +3, ಯುರೋಪಿಯಂ +3 ಇದರಲ್ಲಿ ನಮಗೆ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರ್ತವೆ. ಯುರೋಪಿಯಂ +2 ಕಾನ್ಫಿಗರೇಷನ್ ಬಂದ್ಬಿಟ್ಟು ಕ್ಸೆನಾನ್ 4f7. ಈಗ +3 ಅಂದರೆ 6 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರ್ತವೆ, ಇದು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಆಗತ್ತೆ. ಇಟರ್ಬಿಯಂ +2, ಇಟರ್ಬಿಯಂ ಅಂದರೆ ಕ್ಸೆನಾನ್ 4f14 ಕಾನ್ಫಿಗರೇಷನ್, ಇದರಲ್ಲಿ ಕೂಡ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಲಿಕ್ಕಿಲ್ಲ. ದೇರ್ಫೋರ್ ಆಪ್ಷನ್ ನಂಬರ್ 3 is correct answer. Next question, 67. In dichromate ion, all 8 CRO bonds are equivalent and have CRO-CR bond. 6 CRO bonds are equivalent and have CR-CR bond. 6 CRO bonds are equivalent and have CRO-CR bond. And 4 CRO bonds are equivalent and have CR-CR bond is a statement. So, ಇದರಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ವಿ, CR ಇಷ್ಟಿದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಇವಾಗ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಥಿಂಗ್ನಲ್ಲಿ ಏನಿದೆ, CRO CR ಇದೆಲ್ಲ ಇದೆ ಅಲ್ವಾ. ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಬಾಂಡ್ನಲ್ಲಿ ನಾವೇನು ಮಾಡಬೇಕು ಅಂತಂದರೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ -2 ಇದು ಈ ಥರ ಇದೆ ಸ್ಟ್ರಕ್ಚರ್, ಆ್ಯಕ್ಚುಯಲ್ ಸ್ಟ್ರಕ್ಚರ್. ಇದು ರೆಸನೆನ್ಸ್ನಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡ್ತವೆ ಈ ಮೂರು ಕೂಡ. ಇಲ್ಲೇನು ಬಾಂಡ್ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಇದೆ ಅದು ಕೂಡ ಅಲ್ಲೇ ಇದೆ, ಅದೇ ಥರ ಇದೆ ಅಲ್ಲಿ ಕೂಡ. ಸೊ ಈ 6 CRO ಬಾಂಡ್ಸ್ ಕೂಡ ಸೇಮ್, ಬಟ್ 2 CRO ಬಾಂಡ್ಸ್ ಏನಿದಾವೆ ಅವು ಡಿಫ್ರೆಂಟ್. ಆ್ಯಂಡ್ ಇಲ್ಲಿರೋದು CR ಬಾಂಡ್. Therefore, we need to take option number 3 as correct answer. ಇದೇ ತರಹ ಬ್ರಿಡ್ಜ್ ಇರೋ ಕೆಲವು ಅದಾವೆ ನಮಗೆ. Mn2O7 ನಿನ್ನೆ ಕೂಡ ಹೇಳಿದ್ದೀನಿ ನಾನು. Mn2O7 ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ಅದು ಕೂಡ ಅದೇ ತರಹ ನಮಗೆ ಬ್ರಿಡ್ಜನ್ನು ಹೊಂದಿದ್ದು ಆಗಿರುತ್ತೆ. Therefore, ಖಂಡಿತ ಈ ಸ್ಪೀಷೀಸ್ ದೇ ಕಮ್ ಅಂಡರ್ ದ ಕ್ಯಾಟಗರಿ ಆಫ್ ಬ್ರಿಡ್ಜ್ ಬಾಂಡ್ ಕಂಟೈನಿಂಗ್ ಕಂಪೌಂಡ್ಸ್. ಅವು ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಜಸ್ಟ್ ಕಾಂಟೆಕ್ಸ್ಟ್ನಲ್ಲಿ ಹೇಳಿದನಷ್ಟೇ. ನೆಕ್ಸ್ಟ್, ದ ಕಲರ್ಡ್ ಪ್ರಾಡಕ್ಟ್ ಒಬ್ಟೈನ್ಡ್ ಆನ್ ರಿಯಾಕ್ಷನ್ ಆಫ್ ಫೆರಸ್ ಕ್ರೋಮೈಟ್ ವಿತ್ ಸೋಡಿಯಂ ಕಾರ್ಬೊನೇಟ್ ಇನ್ ಫ್ರೀ ಆಕ್ಸಸ್ ಆಫ್ ಏರ್ ಈಸ್. ಅಂದರೆ ಫೆರಸ್ ಕ್ರೋಮೈಟ್ ಅಂದರೆ ಐರನ್ ಕ್ರೋಮೈಟ್, ಅದು ಸೋಡಿಯಂ ಕಾರ್ಬೊನೇಟ್ ಜೊತೆಗೆ ಆಕ್ಸಿಜನ್ ಪ್ರೆಸೆನ್ಸ್ನಲ್ಲಿ ರಿಯಾಕ್ಟ್ ಆಗಿದೆ. ಅಂದರೆ Fe2CrO4, FeCr2O4, FeOCr2O3, ಐರನ್ ಕ್ರೋಮೈಡ್, ಸೋಡಿಯಂ ಕಾರ್ಬೊನೇಟ್, ಆಕ್ಸಿಜನ್ಗಳು ರಿಯಾಕ್ಟ್ ಆದಾಗ ನಮಗೆ ಬರೋದು ಏನದು, ಪೊಟ್ಯಾಷಿಯಂ ಸೋಡಿಯಂ ಕ್ರೋಮೇಟ್. ಈ ಸೋಡಿಯಂ ಕ್ರೋಮೇಟ್ ಅನ್ನುವ ಕಂಪೌಂಡಿನ ಕಲರ್ ಜನರಲಿ ಯೆಲ್ಲೋ ಆಗಿರುತ್ತೆ. ಸೊ ವಿಚ್ ಈಸ್ ಅ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಅನ್ನೋದು ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಪರ್ಪಲ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಫೆರಿಕ್ ಡೈಕ್ರೋಮೇಟ್ ತಪ್ಪು, ಯೆಲ್ಲೋ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ರೋಮೇಟ್ ಅದೇ, ಗ್ರೀನ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸೋಡಿಯಂ ಡೈಕ್ರೋಮೇಟ್ ತಪ್ಪು, ಬ್ರೌನಿಶ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಫೆರಸ್ ಆಕ್ಸೈಡ್ ತಪ್ಪು. ದೇರ್ಫೋರ್ ಇಟ್ ಈಸ್ ಯೆಲ್ಲೋ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ರೋಮೇಟ್. ಇದರದು FeCr2O4 ಐತಿ, ಸೋಡಿಯಂ ಕಾರ್ಬೊನೇಟ್ ಮತ್ತು ಆಕ್ಸಿಜನ್ ಜೊತೆಗೆ ಟ್ರೀಟ್ ಆದಾಗ ಸೋಡಿಯಂ ಕ್ರೋಮೇಟ್ ಬರುತ್ತೆ. ಸೋಡಿಯಂ ಕ್ರೋಮೇಟ್ ಅನ್ನೋದು ನಮಗೆ ಯೆಲ್ಲೋ ಕಲರ್ ಕಂಪೌಂಡ್ ಆಗುತ್ತೆ. ಎನಿ ಕ್ರೋಮೇಟ್ ಇಸ್ ಯೆಲ್ಲೋ ಕಲರ್ಡ್ ಕಂಪೌಂಡ್. ನಮಗೆ ಸಾಲ್ಟ್ ಅನಾಲಿಸಿಸ್ನಲ್ಲಿ ಕೂಡ ಅದೇ ಬರುತ್ತೆ. ದೇರ್ ಫಾರ್ ಯೆಲ್ಲೋ ಕಲರ್ಡ್ ಕ್ರೋಮೇಟ್, ಆಲ್ ಕ್ರೋಮೇಟ್ಸ್ ಆರ್ ಯೆಲ್ಲೋ ಕಲರ್ಡ್. ಲೆಡ್ ಕ್ರೋಮೇಟ್, ಬೇರಿಯಂ ಕ್ರೋಮೇಟ್ ಆ್ಯಂಡ್ ಪೊಟ್ಯಾಷಿಯಂ ಕ್ರೋಮೇಟ್, ಸೋಡಿಯಂ ಕ್ರೋಮೇಟ್, ಆಲ್ ಆಫ್ ದೀಸ್ ಆರ್ yellow colored. So this is an yellow color compound. So option number 2 is correct answer. Moving on. Consider the following statements. Zirconium, hafnium have almost identical radii. That's correct because of lanthanide contraction. When we consider 4D and 5D series elements, ಈ 4D ಮತ್ತು 5D series elements ನಲ್ಲಿ ಖಂಡಿತ there is Lanthanoid contraction observed, and as a result of lanthanoid contraction, you know, the elements like when we start from yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver and cadmium are the elements present here. Whereas in the 5D series we get lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, and then gold and mercury are the elements present. And after lanthanum, we have a set of 14 elements called lanthanides, which actually have 4f orbitals, which are poor shielders in them. As a result, there is a phenomenon that takes place called lanthanide contraction. So, ಆ ತರಹ lanthanide contraction ಇರುವುದರಿಂದ ಹಾಫ್ನಿಯಮ್ದಿಂದ ನಮಗೆ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ, there is this decrease in size instead of increase in size. As a result, zirconium to hafnium, niobium, tantalum, molybdenum, tungsten, technetium, rhenium ಇವೆಲ್ಲ ಕೂಡ ಸೇಮ್ ಸೈಜನ್ನು ಹೊಂದಿರ್ತವೆ ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಮೂವಿಂಗ್ ಆನ್. ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಸೀರಿಯಂ +4 ಇಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ರಿಡಕ್ಟೆಂಟ್. ಈಗ ಹೇಳಿದ್ದೀನಿ +4 ಸ್ಟೇಟ್ನಲ್ಲಿರುವ ಆಕ್ಸಿಡೆಂಟ್ಸ್ ಆಗ್ತವೆ ಬಿಟ್ಟು ರಿಡಕ್ಟೆಂಟ್ ಆಗಲಿಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ. ಸೊ ಅದು ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಲ್ಯಾಂಥನೈಡ್ ಕಂಬೈನ್ ವಿತ್ ನೈಟ್ರೋಜನ್ ಆ್ಯಂಡ್ ಫಾರ್ಮ್ LnN3 ಅದು ತಪ್ಪು. LnN ಫಾರ್ಮ್ ಮಾಡ್ತವೆ, LnN3 ಫಾರ್ಮ್ ಮಾಡಲ್ಲ. ಸೊ ಅದು ಕೂಡ ತಪ್ಪೆ. ಯಾಕಂದರೆ ಲ್ಯಾಂಥನೈಡ್ Ln+3, ನೈಟ್ರೈಡ್ N-3, therefore ಎರಡೂ ಸೇರಿ LnN ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡ್ತವೆ ಬಿಟ್ಟು ಇನ್ನೊಂದು ಫಾರ್ಮ್ ಮಾಡಲ್ಲ, ತಪ್ಪಾಗತ್ತೆ. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ 1 and 2 ಆರ್ ಕರೆಕ್ಟ್. The manganate and permanganate ions have pi bonds due to manganate ಮತ್ತು ಪರ್ಮ್ಯಾಂಗನೇಟ್ಸ್ನಲ್ಲಿ ಪೈ ಬಾಂಡ್ಸ್ ಅನ್ನೋವು ಯಾವ ಥರ ಅಯಾನ್ಸ್ ಹ್ಯಾವ್ ಪೈ ಬಾಂಡ್ಸ್ ಡ್ಯೂ ಟು ಅನ್ನೋದು ನೋಡ್ತಾ ಇದ್ವಿ. ಅಂದರೆ ಯಾವ ಪೈ ಬಾಂಡ್ಸ್ ಇರ್ತವೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಪರ್ಮ್ಯಾಂಗನೇಟ್, ಮ್ಯಾಂಗನೇಟ್, ಕ್ರೋಮೇಟ್ ಅದು ಯಾವುದಾದ್ರೂ ಇರಲಿ, ಇದು ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಅಯಾನ್. ಕ್ರೋಮೇಟ್ ತಗೋ, ಮ್ಯಾಂಗನೇಟ್ ಕೂಡ, ಯಾವುದಾದ್ರೂ ತಗೋ ನೀನು ಮೂರರಲ್ಲಿ. ಈ ಮೂರರಲ್ಲಿ ಕೂಡ ಬಂದಿದ್ದ ಪೈ ಬಾಂಡ್ಸ್ DP ಪೈ ಬಾಂಡ್ಸ್. D ಆರ್ಬಿಟಾಲ್ ಆಫ್ ಮ್ಯಾಂಗನೀಸ್, P ಆರ್ಬಿಟಾಲ್ ಆಫ್ ಆಕ್ಸಿಜನ್. D ಆರ್ಬಿಟಾಲ್ ಆಫ್ ಮ್ಯಾಂಗನೀಸ್ ಮತ್ತು P ಆರ್ಬಿಟಾಲ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಎರಡು ಸೇರಿ ನಮಗೆ it forms actually a pi bond. I mean therefore it is the pi bonding involves overlap of P orbitals of oxygen with D orbitals of manganese is correct statement. 71st, which one of the following statements related to lanthanides, lanthanoids, they are all one and the same, is correct? Europium shows +2 state. Correct, europium shows +2, I already told you. The basicity decreases as the ionic radius decreases from praseodymium to lutetium. Ionic radius decrease ಆಗ್ತಾ ಇದ್ರೆ ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿ ಬೇಸಿಕ್ ಸ್ಟ್ರೆಂಗ್ತ್ ಖಂಡಿತ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಥರ್ಡ್, all the lanthanins are much more reactive than aluminum. So lanthanins ಏನದಾವೆ ಇವೆಲ್ಲ they are much more reactive than aluminum ಅನ್ನುವ ಥಿಂಗನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ, yes actually they are almost same reactivity they have as lanthanin ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. their behavior, chemical behavior is close to aluminum. ಆದರೆ ಫಸ್ಟ್ ಹಾಫ್ ಕ್ಯಾಲ್ಶಿಯಂ ಥರ, ಉಳಿದ ಫಸ್ಟ್ ಪ್ಲಸ್ ಹಾಫ್ ಅಲ್ಯೂಮಿನಿಯಂ ಥರ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ ಬಿಟ್ಟು ಆಲ್ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಒಂದೇ ಥರ ಬಿಹೇವ್ ಮಾಡಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಒನ್, Cerium plus 4 solutions are widely used as oxidizing agents in volumetric analysis. This is the correct statement because cerium plus 4 is very stable even in solution, so it can be definitely used in volumetric analysis. Next question. Which one of the following does not correctly represent the correct order of the property indicated against it? Idu ninne already navu discuss madidde, ಆದರೆ I think there is a small change. Let's discuss that. Titanium, vanadium, chromium, manganese, increasing number of oxidation states. ಇದು ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ ನಾನು. ಟೈಟಾನಿಯಂ, ಕ್ರೋಮಿಯಂ, ಮ್ಯಾಂಗನೀಸ್, ವ್ಯಾನಿಡಿಯಂ, ಇದು +2 +3 +4ಗಳನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡಿದರೆ ಇದು 3 4 5ಗಳನ್ನು, ಇದು 3 4 5 6ಗಳನ್ನು, ಇದು 7ವರೆಗೂ ಕೂಡ ಎಲ್ಲ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತಾ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಒನ್, therefore ಅದು ಕರೆಕ್ಟ್ ಆರ್ಡರ್. Increasing magnetic moments, so titanium +3, vanadium +3, chromium +3, Mn +3. Titanium +3, 3d1, 3d2, 3d3, 3d4. Number of unpaired electrons 1 2 3 4 ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ಖಂಡಿತ ಆ ಆರ್ಡರ್ ಕೂಡ ಕರೆಕ್ಟೇ. ಸೊ ಇನ್ಕ್ರೀಸಿಂಗ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ಸ್ ಅದು ತಪ್ಪು ಆರ್ಡರ್. ಸೇಮ್ ಕ್ವೆಶ್ಚನ್ ಇನ್ನೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದೆ. ಟೈಟಾನಿಯಂ, ವ್ಯಾನಿಡಿಯಂ, ಕ್ರೋಮಿಯಂ, ಮ್ಯಾಂಗನೀಸಿಗೆ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಇನ್ಕ್ರೀಸಿಂಗ್ ಸೆಕೆಂಡ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ, ಟೈಟಾನಿಯಂ, ವ್ಯಾನಿಡಿಯಂ, ಮ್ಯಾಂಗನೀಸ್, ಕ್ರೋಮಿಯಂ. ಇದರಲ್ಲಿ ನೋಡಿದ್ದಾಗ ಸೆಕೆಂಡ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಂದರೆ ಆ್ಯಕ್ಚುಲಿ ಇದರ ಕಾನ್ಫಿಗರೇಷನ್ 4s2 3d2, 4s2 3d3, 4s2 3d5 and 4s2 3d4 or 4s1 3d5. ಸೆಕೆಂಡ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಹೈಯೆಸ್ಟ್ ಕ್ರೋಮಿಯಂಗಿರುತ್ತೆ, ಕಾರಣ ಸೆಕೆಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ 3d5ರಿಂದ ತೆಗಿಬೇಕು. ಮ್ಯಾಂಗನೀಸಿಗೆ ಡೆಫಿನೆಟ್ಲಿ ಕಮ್ಮಿ ಇರುತ್ತೆ, ಕಾರಣ ಈ 4s1 ತೆಗೆದ್ರೆ ಅದಕ್ಕೆ ಸ್ಟೆಬಿಲಿಟಿ ಬರುತ್ತೆ. ಸೊ ಎಸ್, ದಟ್ ಈಸ್ ಕರೆಕ್ಟ್. ದೇರ್ಫೋರ್ this is all about the assignment that I just had sent today, and I don't know whether you have those copies or not. But anyway, let us discuss the remaining important concepts from the same chapter because we still have 15 minutes of duration. Or some more questions from a different source. I can dictate the, I can write the questions. Let's see. So here we will discuss certain important concepts of the same chapter, D and F block, where we can talk about the various things like, important thing, especially where the questions are repeated on the concept of applications of D block elements. Let me remind you that concept first, and then we'll see the rest of the things. It's taking a little time to connect. Therefore, what I am trying to tell you here is applications of D and F block elements, especially the D block elements. When we consider the applications of D block elements, what we need to understand here is we have iron in the first place, where iron is very important component in the production of steel and in the production of, in the construction. Steel is used. Steel, iron forms different alloys. In that, steel is very important. And in that particular type of, in steel also, we have varieties of steels like, stainless steel and all. By combining different elements with different properties along with iron, we can produce different types of steel, and that's an important first application that we need to understand about iron. Moving on, we also have certain other important things like we have titanium oxide, which is used in pigment industry where it shows color, and we also have manganese and then cadmium, mercury, zinc, and all of these elements are used in battery industry. From D block, all of these elements are used in battery industry. And then we have a list of coins used actually. When we consider list of coins in D block, we have metals called coinage metals, where the metals like silver, gold, copper, all of these are called coinage metals. And these coinage metals were used as currency at one particular period of time in the history. And when we consider coinage metals here, even today in countries like UK, United Kingdom, there are coins used, but not literally the coins which are made up of whatever the name that they call it with. But when you consider, copper coins in UK are copper coated steel. Inside it is steel, but outside it is copper. And the UK silver coins, when they say it is a combination of copper and nickel alloy. So it's not really steel that they use. So these are, silver that they use. And after this, we also understand the catalytic properties of D block elements where in Haber's process, Haber's process is manufacture of ammonia. In this process, there is iron, finely divided iron or iron oxide used as a catalyst. ಕೆಲವು ಸತ iron ಅಂತ ಹೇಳ್ತಾರೆ, iron oxide ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. So we can take that. Next one, contact process. Contact process ಅಂದ್ರೆ manufacture of sulfuric acid, in which they use vanadium pentoxide as catalyst. Then we have other important process like hydrogenation of oils. In hydrogenation of oils nalli nickel is used as catalyst. And we also have other processes like in case of polymerization, benzene, acetylene, ಇವುಗಳ ಪಾಲಿಮರೈಸೇಷನ್ ನಲ್ಲಿ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಆಫ್ ನಿಕೆಲ್ are used actually as catalysts. So these are different types of things where also like process we have Wakers. In Wakers process we use palladium chloride as catalyst. So ivella kuda ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕಾಗುತ್ತೆ. ವೇಕರ್ಸ್ ಪ್ರಾಸೆಸ್ ಅಂದರೆ ಈಥೀನ್ ಅಥವಾ ಈಥೈನನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡುವ ಪ್ರಾಸೆಸ್ ಏನಿದೆ ಅದು PDCl2 ಯೂಸ್ಡ್ ಆಸ್ ಕ್ಯಾಟಲಿಸ್ಟ್. ಇವೆಲ್ಲ ಕೂಡ ಡಿಫ್ರೆಂಟ್ ಕ್ಯಾಟಲಿಸ್ಟ್. ಇನ್ನೊಂದು ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಝೀಗ್ಲರ್-ನಾಟಾ ಕ್ಯಾಟಲಿಸ್ಟ್. ಈ ಝೀಗ್ಲರ್-ನಾಟಾ ಕ್ಯಾಟಲಿಸ್ಟ್ is the mixture of titanium tetrachloride and tri-alkyl aluminum. ಈ ಕಾಂಬಿನೇಷನ್ ಏನಿದೆ ಇದನ್ನು ಝೀಗ್ಲರ್-ನಾಟಾ ಕ್ಯಾಟಲಿಸ್ಟ್ ಅಂತ ಕರೀತಾ ಇದ್ವಿ. ದಿಸ್ ಈಸ್ ಯೂಸ್ಡ್ ಇನ್ ಪಾಲಿಮರೈಸೇಷನ್ ಆಫ್ ಈಥೀನ್ Then silver bromide. Silver bromide is a photosensitive material which is used in photo industry, the black and white photo industry. It was used once a long time ago. So these are the important applications of D block elements that we need to remember. Moving on, we have certain other important things like E naught values anna ondsala discuss madana. E naught values of D block elements consider ಮಾಡಿದಾಗ E naught m plus 2 m values. These values are high for copper, low for zinc, and then manganese and nickel. When we consider copper case nalli edakke high ide ninne kuda helidini ee particular values enadave ivella kuda they are actually useful in converting. I mean, they actually depend on a solid getting converted to gas that involves sublimation enthalpy. This next becomes M plus gaseous ion, where this includes first ionization enthalpy, then another time we have second ionization enthalpy involved, where in the last step this is dissolved in water to make M plus 2 aqueous. Idu hydration enthalpy. So E naught values ಅನ್ನೋವು ಹೈ ಇದೆಯಾ ಲೋ ಇದೆಯಾ ಅನ್ನೋದು ಇವುಗಳ ಸಮ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಇದರಲ್ಲಿ ಸಬ್ಲಿಮೇಷನ್, ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್, ಸೆಕೆಂಡ್ ಅಯೋನೈಸೇಷನ್ ಮತ್ತು ಹೈಡ್ರೇಷನ್ ಇವೆಲ್ಲ ಕೂಡ these all three processes are endothermic, whereas this process is exothermic in nature. ಎಂಡೋಥರ್ಮಿಕ್ ಪ್ರಾಸೆಸ್ ಆದ ಇವುಗಳು ಜಾಸ್ತಿ ಇದ್ದರೆ ಓವರಾಲ್ ವ್ಯಾಲ್ಯೂ ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ಒಂದು ವೇಳೆ ಇದು ಜಾಸ್ತಿ ಇದ್ದರೆ ಓವರಾಲ್ ವ್ಯಾಲ್ಯೂ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ. ದೇರ್ ಫೋರ್ ಹೈ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕಾಪರ್ ಇದೆ ಅಂತಂದರೆ ಅರ್ಥ ಏನು ಅಂತಂದರೆ, ಪಾಸಿಟಿವ್ ಇದೆ ಅಂತಂದರೆ, ಇಟ್ ಈಸ್ ಬಿಕಾಸ್ the sum of all these three values is not compensated by hydration enthalpy, the negative value, so it remains positive. Zinc and manganese ಗಳಿಗೆ ಎದಕ್ಕೆ ಲೋ ಇದೆ ಅಂತ ಅಂದರೆ, ಜಿಂಕ್ ಮತ್ತು ಮ್ಯಾಂಗನೀಸ್ಗಳಲ್ಲಿ 4s2 3d10 ಮತ್ತು 4s2 3d5 ಕಾನ್ಫಿಗರೇಷನ್ಸ್ ಅದಾವೆ. ಅದರಲ್ಲಿ 4s2 ಕಳೆದು ಹೋದರೆ ಅವುಗಳಕ್ಕೆ ಸ್ಟೆಬಿಲಿಟಿ ಬರುತ್ತೆ. ಆ ಕಾರಣಕ್ಕೆ they are actually losing electrons readily, and their second ionization enthalpy is very low, and also the sublimation enthalpies are low. As a result, E naught values are low. When it comes to nickel, the sum of all these three, even though it is higher, the hydration enthalpy is surmounting all of those, overpassing that. Therefore, nickel will be definitely higher, a lower hydration enthalpy because of high negative hydration enthalpy, but not because of these three things being high or low. So that's all about this. Now moving to the next important part, copper ge aa taraha positive potential irodrinda enagutte, ಯಾವುದಾದ್ರೂ ಒಂದು ಎಲಿಮೆಂಟ್ಗೆ ಪಾಸಿಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ ಅಂತಂದರೆ, ಲೈಕ್ ಕಾಪರ್, ಆ ಎಲಿಮೆಂಟ್ ಆಸಿಡ್ಸ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಡಸ್ ನಾಟ್ ರಿಯಾಕ್ಟ್ ವಿತ್ ಆಸಿಡ್ಸ್ ಟು ಲಿಬರೇಟ್ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್. ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸನ್ನು ಲಿಬರೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಸಿಡ್ಸ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ ಆ ಎಲಿಮೆಂಟ್ ಅಂತ ಅರ್ಥ. ಸೊ ಕಾಪರ್ ಮಾತ್ರ ಆಸಿಡ್ಸ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸನ್ನು ಲಿಬರೇಟ್ ಮಾಡಲ್ಲ. ಇದು ಫಸ್ಟ್ ಪಾಯಿಂಟ್. ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ದಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್ ಇಸ್, ಇದು ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಆದರೂ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಬರಲ್ಲ. ಆದರೆ ಅದರ ಬದಲು ಇದು ಕಾಪರ್ ನೈಟ್ರೇಟ್ ಮತ್ತು ನೈಟ್ರೋಜನ್ ಡೈಆಕ್ಸೈಡ್ ಮತ್ತು ವಾಟರ್ಗಳನ್ನು ಫಾರ್ಮ್ ಮಾಡ್ತಾ ನೈಟ್ರೇಟ್ ಅಯಾನ್ ಜೊತೆಗೆ ಇಂಟ್ರಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಬಿಟ್ಟು ಹೈಡ್ರೋಜನ್ ಜೊತೆಗೆ ಇಂಟ್ರಾಕ್ಟ್ ಆಗ್ತಾ ಇಲ್ಲ. ಅದೇ ಬೇರೆ ಯಾವುದಾದ್ರೂ ಮೆಟಲ್ ಆದರೆ ಜನರಲಿ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಬಿಟ್ಟು ನೈಟ್ರೇಟ್ ಜೊತೆ ಅಲ್ಲ. ಅಂದರೆ ಈ ಕಾಪರ್ ಏನು ಮಾಡ್ತಾ ಇದೆ, ನೈಟ್ರೇಟನ್ನು ರೆಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೆ, H+ ಅನ್ನು ರೆಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ನೈಟ್ರೇಟ್ ಕಾಪರನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡ್ತಾ ಇದೆ. ಈ ಕಾರಣಕ್ಕೆ ನಾವು ಈ ಕಾಪರ್ಗೆ ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಪಾಸಿಟಿವ್ ಇದ್ದಿದ್ದ ಕಾರಣಕ್ಕೆ ಇದೆಲ್ಲ ಆಗ್ತಾ ಇದೆ. ಅದು ಆ್ಯಸಿಡ್ಸ್ರಿಂದ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸನ್ನು ಲಿಬರೇಟ್ ಮಾಡೋದಿಲ್ಲ, ಪಾಯಿಂಟ್ ನಂಬರ್ 1. ಪಾಯಿಂಟ್ ನಂಬರ್ 2 ಏನಂತಂದರೆ, ಇಟ್ ಆ್ಯಕ್ಚುಲಿ ಹ್ಯಾಸ್ ದಿಸ್ ಕೈಂಡ್ ಆಫ್ reaction with nitric acid in which it gets oxidized by nitrate but does not release hydrogen gas. It gets oxidized by nitrate and that reduces nitrate ion to NO2 ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಸೊ ದಿಸ್ ಈಸ್ ಆಲ್ ಅಬೌಟ್ ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್. ಇಲ್ಲಿವರೆಗೂ ನಾವು ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಮೇಲೆ ವೇರಿಯಸ್ ಟಾಪಿಕ್ಸ್ನಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸನ್ನು ಅರ್ಥ ಮಾಡಿಕೊಂಡಿದ್ದೀವಿ. ಇಲ್ಲಿವರೆಗೂ ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ. ನಾಳೆ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್, ನಾಳೆ ನಾಳೆದು ಕೂಡ ಅರ್ಥ ಮಾಡಿಕೊಳ್ಳೋಣ. ಈ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿರುವ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಯಾವ ತರಹ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನು ನಾಳೆ ನೋಡೋಣ. ಸೊ ಹಿಯರ್ ವಿ ಶಲ್ ಸ್ಟಾಪ್ ಫಾರ್ ಟುಡೇ ಆ್ಯಂಡ್ ಡಿಸ್ಕಸ್ ದ ರೆಸ್ಟ್ ಆಫ್ ದ ಥಿಂಗ್ಸ್ ಟುಮಾರೋ. ಥ್ಯಾಂಕ್ ಯು. ರಮಣ